Well, we'll start in a minute. Lights are down, I guess. Well, apart from the ones in my eyes, the lights are down. So I guess we'll kick it off. It's big, isn't it? It's huge. I don't think we could actually fit the whole of Riddle Hall in here, but we could have a damn good go at it. So, yeah, I should probably run on and say, hello, Belfast, and all that sort of stuff. But, yes, well, welcome to NIDC 2022, in-person and hybrid. So, sort of, do feel free to stream or watch the recordings later. And welcome to our wonderful new venue. Thank you to all the ICC staff for putting all this together. As you can see, we can actually fit everybody into one room here, so it'll be a little easier to breathe as we go on. I'll just quickly run through the venue, because you probably haven't seen it before. This is Hall 1A, which is sort of the track 1. Through that wall there on the other side is Hall 1B. On the other side of Hall 1B is the exhibitors hall, so that's where you get your tea and coffee and biscuits and lunch and all that sort of stuff. Second floor is for childcare and speakers, so you just go through that. And on the top floor are Conference Room 1, Conference Room 2A and Conference Room 2B. So 2 of those are talk rooms, and the other one has the Raspberry Jam and Product Camp in it. Also up there, if you need a quiet room or a prayer room, there's a wee room in the corner there. So, yes, that's our wonderful new venue. Hopefully you can find your way around. Just a quick walk through what we've got going on that's not talks. You may have seen it when you were checking in downstairs, but there's a photo wall. In other words, just a huge, great roll-up banner. So if you want to take selfies and stick yourself on social media, that's a nice place to stand and do that. On the 3rd floor, David Kane will be doing headshots. I believe there's a booking link on the sort of slidey things that are outside, or I guess if you go up there, he can point you at the link. But he will be doing professional headshots for anybody who wants them. We have, oh yeah, Lego. If that got set up, then there's a table up there with Lego for people to play with, just as a bit of fun. That's sort of an NIDC gear set joint thing, because I'm an NIDC gear set joint person. If we can get somebody to staff it, there's an Oculus Quest 2 out there for people to play with if you like it and they just want to have a bit of fun with VR. The Raspberry Jam will be in 2A, conference room 2A on the 3rd floor. So if you want to have a wee play with projects that they've got going on, or just go and see what it is that they're going on, they'll be there until about 3 o'clock. At which point that room will switch over to product camp. So anybody who is interested in product management and the product side of things, that's sort of a drop-in open space where people will be just talking about stuff that they brainstorm about. Farset Labs, who are in the exhibition hall, have brought 3D printers and all sorts of other good stuff from their workshop for you to have a go with. And all the stands there have got stuff, prizes and competitions going on, and coffee and Prosecco and all sorts of good stuff. So make sure you get around all the stands. Speaking of which, we managed to fit all these people into this huge space, which unfortunately wasn't free, so now we're going to thank all our sponsors. So we'll start with the, is it diamond sponsors are the top one? I can never remember if diamond's better than platinum, but yeah, the bestest, biggest sponsors are Gearset and Liberty. They're both equal footing, so we'll make sure we do that. And I'm going to leave that there until you promise to go and talk to them at their stands, okay? So everybody go and talk to Gearset and Liberty? Yep, all good? Yep. Right, okay. The next one down, the platinum or diamond, whichever way they were the others, ESO and Magnite, some good people working in there I know well. The gold sponsors, Carrick, Instill, Apex, EY, and the silver sponsors, who I'm not going to read all those, but you can read them yourself. Just so you're aware, there is no fire drill planned today, so if the fire alarm goes off, follow the ICC staff's instructions and basically get out the building. And yep, that's pretty much it. If anybody needs any help, sponsors are all, so the volunteers and organisers are all wearing these pink shirts, so anybody with a pink shirt, go and hit them up and ask questions. Otherwise, usual NIDC thing, nice and informal, go and hit talks, learn something you didn't know about, go to a talk about something you've got no idea about, sort of get your sort of mind expanded, and have a damn good time. Thank you very much. You may now go and proceed back to the exhibition area and then up to whatever room you're going in, unless you're staying in here for the first talk.
Hi, I'm Brian Craig. I work at Liberty IT. I lead the architecture team, which means I make sure all the engineering is focused in the right direction and our different job families are all going towards the continuous improvement. So Liberty IT, we have about 650 people based out of both Belfast and Dublin. We produce software and world-class engineering for our parent company, Liberty Mutual, which is an insurance company based out of the US. We do so many different things from them, from straight software engineering to data scientists to product ownership to product management to a level of consultancy. So that's that we deliver, and they're a Fortune 500 company. So NIDC, the big thing about it is it's community driven. It's talks by practitioners, by developers, all levels. It's inclusive, there's support if you need childcare. Again, it's just fantastic, the level of interest we get from people attending, but also the different variety of talks you get. And it's people who have like 1 or 2 years experience to people like myself who have 20 to 30 years experience. There's just such variety. It is really, really energetic is the other thing, really energetic. This year at NIDC, I'll be talking about how the marriage of architecture and engineering comes together to deliver business value, and how do we do that in a continuous way. Liberty in Belfast, we currently have our graduate and intern recruitment open, and it is open until the end of the month, so please go ahead and apply. We'd love to see you here.
So my name's Eamon Boyle. I'm the development manager at GearSet's Belfast office. We've only just opened the office here in Belfast in April. GearSet is the DevOps solution provider for Salesforce. Salesforce is the world's largest CRM, and we basically help thousands of customers across the globe deliver solutions on Salesforce with better security, better speed, ease of use. Some of our customers include big names like IBM, Amazon, TripAdvisor, some folks like this. So the quality of the speakers at NIDC is always really good. I'm really excited with this year's. The lineup looks absolutely amazing. It'll be nice just to be in the room with people physically because we haven't been able to do that for the last number of years. So I'm looking forward to seeing both like the attendees and the speakers. I'm doing a talk at it. I'm really looking forward to that because I haven't talked in Belfast in a while. So that's covering how GearSet has moved from JavaScript to TypeScript. So I'm really looking forward to that. And then we're also running a wee puzzle on the stand. People can come along, have a go at it, and then we're going to raffle off a prize. So I'm really looking forward to seeing what people sort of make of that. Should be a bit of fun and some to talk around at the booth. One of the things we're really looking forward to is just meeting the engineers, the attendees at the event. We have more work than we can do, so we're like eager for people to join the team. And as a company, we've got a startup environment, we've got a startup attitude, but we've also got the stability and the ambition of a scale up. So if anybody at the event is looking to join that sort of team, we'd really love to hear from you.
Hello, can everybody hear me okay? Great. Hi everyone, my name is Gemma Simpson and I'm going to be your MC in this hall today. Next up, we are going to have Brian W. Craig, who is with our Diamond sponsor, Liberty IT. And Brian's talk today is around architecture and engineering, delivering continuous value. In large companies, how do architecture and engineering work together so that technology delivers continuous value to the business via complementary focuses? So if we can welcome Brian up to the stage, thank you very much.
Good morning. Thank you, everyone. This is probably, I don't know, the biggest and darkest room I've ever presented in. So if you are out there, hello. Good morning. So I'm Brian Craig. I'm from Liberty. I'm the Director of Architecture, and hopefully I will give you an interesting talk over the next half an hour. So if you work for a large company, you find that architecture starts to have to split out from engineering, purely because of scale. Enterprise architecture itself is about that, blending together not just the solution architecture of the applications, but also the business architecture, the data architecture, and in many cases the technical architecture. Again, these are the group that have to work out what is your messaging platform, as well as what are the solutions that you actually develop on. Aligned with that, you have the pillars around ensuring you've got observability, you have data quality, you have security, and then you've also got the outputs. You know, looking to the future, what strategies, what roadmaps, what standards, what decisions are being made, and explaining those. So again, that's the enterprise architecture side. On the other side, you have engineering. The engineering is the next 6 to 12 months. How do you follow those roadmaps to deliver what the business wants? And again, they're very much focused on the kind of here and now, the context that they're currently operating in. And again, there's lots of complementary parts to engineering, from having the right people in the team, the practices, looking to have a data-driven approach. But again, when you bring the two of them together, that's where the magic happens. If you just focus on your engineering, you'll be great for the first year. You'll be pretty good for the second year. But once you get to year 3, you'll start to build up the technical debt. You'll start to run issues with how does your system blend with the other systems within the eco-environment of your company, and that's where the architecture comes in. But architecture doesn't work if you don't have the feedback loop coming from your engineers. If your strategies and roadmaps are written in an ivory tower, then whenever they come down to the engineering teams, they're not going to be successful. So that's why over time you start to see the two converge. And obviously for most people, if you start off in engineering, you start off as an engineer, senior engineer, principal, and ideally you end up in either those senior engineering, distinguished engineering roles, and eventually into architecture. But again, every so often you need to come down, work with the teams to understand when you implement the roadmap, what's working, what's not working, what do you need to change. Now, when I wrote this presentation, or started to write this presentation, I got to this slide, and I realized we actually have a bit of a problem right now in our industry. We're starting to see an erosion in our engineering discipline. This is a picture of the Malahide Swords Railway Bridge between Belfast and Dublin. And as you can see, if you let erosion continue, you will collapse your ability to deliver value. And what do I mean by erosion, and what's really happening now? Well, we have a really hot talent market. That means your experienced engineers are most likely going to leave at some point. And that also means that you're going to be bringing in new people. And if you haven't got your culture defined and talked through your practices and instilled them into your company, all you've got is rumor-driven development. And that doesn't work if there isn't anybody be able to pass those rumors on. The other thing that we're now seeing is remote work. Nearly, 80 to 90%, I think, in IT are now looking to work remote most of the time. That means you can't turn to the person beside you and ask a question anymore. You have to set up a dreaded video meeting to be able to do that. and it's really not working. So I went out, Agile. When Agile came in, probably 10, 15 years ago, this was the promise. We would take and get rid of waterfall, and we turn it into iterative cycles. We do our plan, design, our development, the coding, we do our test, and we do it in very short cycles, and we get away from the problems of waterfall, where requirements will be done up front, you do big design, and by the time you actually delivered, none of that would be relevant. But 10 years down the line, there's now a movement around Agile 2, because what has happened is we've got this. We've got people coding based on what they've been asked to do, and they launch it. We've lost the discipline around design and test. And it's not about going back to big design and big testing. It's about ensuring that whenever we do Agile, we do it appropriately. So the Agile 2 movement has now appeared. And again, when I send the slides out later, you can link to it and you can see their manifesto. But what they called out is, despite Agile having strong technical roots, it has devalued the importance of engineering. And to some extent, it's certainly devalued the importance of documentation. So, whenever I look to how do we solve this as an industry, I actually found this really great piece from ThoughtWorks, and I've stolen a few of their slides. One of the most worrying things is they bannered it engineering productivity. Anytime you say engineering productivity or developer productivity, it scares the developers. It scares people because they feel that they're being measured so they can be punished. That's not what this is about. It's really about that second word. It's about improvement. And the first thing they say is you need to talk to your people to make them aware of the reasons why. And really the why of why you want to go about building a framework around your engineering is you want to be able to differentiate yourself from your competitors, and you want to be able to retain your values. I want LIT to have the same culture and an evolving culture today and in 5 years and 10 years' time. It doesn't matter if we have the same employees, as long as we have the same culture. So ThoughtWorks produced this framework, and I'm going to touch on bits of it, but this framework reflects what LIT has eventually adopted, which has really helped us, and I'll talk about the specifics on that later. But really, if you look to that bottom left-hand corner, it's about continuous improvement. This is not a big bang solution. This is about being sensible, having sensible defaults, putting together a structure that aligns what your company's culture is, writing it down, and then ensuring that aligns with where you want to go from your North Star, linking to your client values, and what everybody wants to have, which is impact. So we'll now touch on a few of those items. So sensible default practices, very fancy words, but all it really means is writing down what is your expectations of your developers. Just letting them know what good looks like. And although it'll sound strange, it isn't rocket science. It's talking to them about the fact that they should be doing CI/CD. They should be baking security into their applications. They should be doing testing. None of that is now baked into Agile as how you deliver, so you need to layer it on separately, and you need to talk directly to your engineers. We have gone about not inventing our own practices. What we've done is we've directed people to the trusted industry practices, whether that's on the engineering side, the product side, and lastly, we have opinionated company ways. So what does that mean? That means we're an insurance company and we have compliance. That means that whenever you deploy into AWS, you have to secure things in a certain way. And we're writing that stuff down so that developers don't have the cognitive load of going and finding somebody who will tell them how to do it. Now they can just follow a clear way of doing it. So the guiding principles behind all of this, it is about continuous improvement. It is about delivering quality solutions. And again, metrics, and I'll talk a bit more about that. It's about metrics that matter to the team. That may sound strange, but we start off with a team focus, working out what will matter to the team, what will give them an impact, and that impact may be about making their life easier. And then we will build that up to being also about the business. But we start small, and then we continuously improve and continuously build. So I don't know if anybody's gone out to the industry recently to actually look at what measurement options you have. Over the last few months, I've talked to Blue Optima and Linear B, who seem to be the leaders in this case, and it's depressing. It's the same stuff that I saw 15 years ago. It's, I'll connect to your GitHub, and I'll tell you how many check-ins people are doing. I'll tell you how big the check-ins are, and they'll talk to you about your code base. That's like so old school. Linear B are slightly better. They'll link your GitHub check-ins to your Jira tickets to be able to understand how quickly your tickets are flowing through, as well as your check-ins. The one that is the most interesting and seems to be getting a lot of attention is called Space, and that's from the same authors as the DORA metrics. Why is it getting interest? Because it's not just one metric. It's not just one type of metric. It also brings in business alignment. You got at the top there about performance. You're now talking about people, engineers actually being treated as people, actually wanting to find out how satisfied they are about their job, how satisfied they are about how they're being supported from the tooling, from their coaches, from their mentors. And then also we've got communication and collaboration there. And that is about how do we keep sharing stuff now we're all remote. Again, with COVID, our teams got really, really strong. But the downside of that is the teams became quite independent from each other. So we've had to put in extra effort to rebuild that communication and collaboration. And then engineering execution. You talk about activity, efficiency, and again, communication and collaboration. So I've got an example on the next slide of what this could look like. So when you think about the SPACE framework, when it comes to your satisfaction and well-being, a lot of companies are already doing it. They're doing team health checks. They're doing net promoter scores around your employees. And then you've got the high ones around retention. Companies have that. And now you're thinking about how do you link that in to be able to determine the scoring for your teams to understand how satisfied they are. Performance, again, this is the impact of the engineering efforts. How reliable are the solutions when they're in production? What number of outages do you have and how long does it take to recover from them? We use tools like SonarQube to be able to determine our code quality, and again, we can bring those metrics in, and what you'll see is you've got a whole array of values. You're not just measuring people on, okay, how many check-ins, how quickly did they did the tickets, because that's such a narrow focus and it doesn't give you a true representation of your teams. Another thing that's really good to do, and a lot of companies don't do it, writing down what your culture is and what you want to focus on. So in LIT, we are all about the learning and collaboration and continuous improvement. And again, that was what our framework has become and what it has done for our employees. So back to the framework slide, and now I'm going to go into a little bit of detail about what LIT has. Oh, yes. The framework's great, but similar to the bridge is going to erode. If you don't do any inspection, you'll never know that it's eroding beneath the surface. So we linked that framework with a couple of other psychology adoption and execution models. One of them is Drive, which has been around for quite a while, from Dan Pink, which is about autonomy, mastery, and purpose. And also the 4 disciplines of execution, which is about providing the teams themselves with a scoreboard that they care about. It's not a management scoreboard, it's a team-level scoreboard. We also ask the team themselves to think about what is their widely important goal that they're going to work on. We give them those lead measures, and then we ask the teams to look at it every 4 months and discuss it. So from there, we have our different parts of the customer focus, the autonomous teams, and the technical value. And again, that's your mastery and purpose and autonomy. And then we have our check-ins. So every 4 months, we ask the teams to come, collect their data to be able to see how they're progressing. And that's probably the most important part, is this bit here. Collecting the data is whenever the team gets together and talks about how they are performing as a team, and it's just the team having that discussion. but you'll be surprised how powerful it can be. We do retrospectives in our Agile, but whenever you take the time to actually focus on your engineering, you'll start to uncover a lot of gems. So once they've collected their data, they sit and they do a check-in with the technical leadership. And quite often, we just ask, what are your challenges? How are you doing? And from there, we agree a focus area. And one of the other key aspects of this is, it's one focus area for the next 4 months. If you ask people to do multiple, then none of them will get done. This is about a multi-year effort. It's not about fixing things in the next 3 or 6 months. It's about how do you have prolonged improvement and maintain your culture. So what does the team level self-assessment questions look like? This is not really highly technical. It's providing a level of direction, particularly for our people that we onboard. It's talking to them about, you should have CI/CD, you should have source control. You should, if you're in the cloud, you should be checking what the costs are. If you're doing performance, you should be checking your app performance. Reviews, how many code reviews are being done? Again, we expect 2 eyes to be on any piece of code that goes into production. Tech debt, we don't say people have to manage tech debt to 0. We say people should be managing their tech debt, and we leave it to the teams to decide what's right for their context. Then once you go past the technical mastery, you talk about the customer. You talk about that sense of purpose. Are the teams actually talking to their customers and their users? Are they getting regular feedback? Just as importantly, do the teams know what business value they are delivering through their software on a 4-month basis? And finally, we have the bit that links all the way back to architecture, alignment. What level of alignment do the team have in their engineering with what the architecture roadmaps are for their area? And just as importantly, are they feeding back where the roadmap is no longer relevant for that area? And autonomy, what level of influence do they have? And again, that's that feedback loop, but it's also within the teams. It's also the team's ability to decide what practices they will use to be able to meet what they're being asked for. On the right-hand side there, you'll see that's our testing one. Again, testing, it's very straightforward. Code is a liability. That is why we write features, and we want to reduce the risk of bugs, security issues, and avoid customers having a bad experience when using the product. To help to reduce the risk of this, we want to test our code the best we can. Now, that is really straightforward. You will learn that in university. But you have to constantly remind people that this is what it's expected every iteration of your Agile sprint. And down here, the team measures, that's where we just provide options that they can pick. Unit testing, component testing, and if you were to be able to click on these, you'd see us reaching out to the industry. We don't need to create our own practices when the industry already provides it. We just need to recommend it. So what does the dashboard look like? So this is a dashboard for one of the teams, and as you can see, it's pretty basic. Grey, red, green. Red meaning that the team is not practicing that area. Grey meaning that they're sometimes practicing that area, and green meaning they're doing it. On the right-hand side, we see the way you can summarize up for multiple teams. Again, if you're running quite a large company, we have 70 teams. It's important to get a feel for where are all your teams at and what initiatives might you need to kick off. You know, if you're seeing down here that cost is one of your lowest ones, and the next slide will call this out even more, then there's maybe a reason you should be kicking off a TCO initiative, helping teams understand how do they access the cost information around their solutions. So with that in mind, this is another version of that data. Here is where we focused on the costs, and blue is the line for teams that are consistently practicing. Round about February 2020, we kicked off an initiative to inform teams about how they could get access to their cost data. And I'm glad to say that after we rolled that out, you can see how we saw teams going from sometimes are not practicing to quite a lot of our teams moving into the consistently practicing. And I should stress, it isn't about getting all teams to the same level. That's an unachievable goal. It's about each team seeing themselves as continuously improving. So what value do you get from this? So I have a few quotes here at the different levels. So from the engineer, we call our framework high performance engineering. So HPE allows us to address the things that matter most so as I can do my job better. Value to the team. The team knows what good looks like and has a consistent approach to making things better. And then the business themselves, which is in truth, a lot of this is about. Increased stability and reliability of our systems, which increases profitability. And then along the bottom, for a long time we have valued delivery front and centre at the expense of our technical excellence and team behaviours. The aim of HPE is to help balance that focus, and that's what the truth's about. You know, your engineering will constantly erode as the business wants things faster and faster. And we are here to deliver faster and faster, but we must get the balance right, or erosion will start to collapse the bridge. So, in summary, HPE, or high performance engineering, which is what we use, it defines what good looks like across our engineering. It supports the evolution of our culture, attitudes and behaviours. We use the results coming out of our team discussions to be able to determine what teaching or training we need to bring in, what coaching we need to provide, what cross-collaboration we need to provide between teams that are strong, maybe on security, and teams that need to raise the bar in their space. We provide those dashboards which give those insights, and it puts people in a growth mindset. It puts people in the mindset that we want to improve, we are improving, and we will continue to improve. And I think I've called it out a few times. It's a multi-year continuous journey. If you want to improve, if you want to keep your culture, you have to keep investing in it. And if you don't, your bridge will collapse. Your engineering will slowly start to get weaker and weaker. You'll start to have instability in production. And eventually you'll get to the point where you have outages where the team need to just stop putting in features and spend their time just getting production stable. And that's me. Cool. I finished early, so I'm happy to take questions. How do we measure cost? So the really easy one is where it's deployed in AWS. So we can quickly bring up the direct data from AWS of what the cost is. For our solutions that are deployed into our internal data center, we have put a level of cost against that, and we now can access dashboards which show what our internal software running costs are. Thank you very much.
Hi, sir, I have a question. In your diagram, you had one part which kind of seemed to be the sort of the exit point from a lot of the architecture pieces, with your North Star goals. Like, what form do they take?
Oh, sorry, I'm just going to back up to that. So the North Star goals inside Liberty, we have 4 particular ones in there at the company level. And they're about us investing in people, us getting close and having deep partnerships with our business, and you're putting me in the spot for the other 2. But that's the nature of ours. The important thing is for you to determine what your own are. So to take the time, there is the North Star framework to actually define what is important for you so that all of this can align to how you generate value, really, and impact for your client and for yourselves.
Anyone other questions? We actually do have a roving mic here, I promise.
As you have the check-in every 4 months with the agile development, have you considered using something like the SAFe framework? Seems there's quite a lot of overlap.
Ooh, that's a very controversial comment. Excuse my words carefully. Safe, we haven't found to be a safe environment, particularly where we've implemented it. It's normally for 100 teams, that is both ourselves and our parent company. So we find this allows us to have more open conversations. I could see how you could use it in Safe, but we're seeing a bit of a backlash in Safe because we've been at it for about 5 years and now our backlogs are growing too long and there's a bit more discipline required in this. So right now this sits outside of it. There has been some talk about how do you, maybe your check-ins are part of a PI increment planning. So that's what certainly we're looking at, but we want to provide it. The most important is to have a psychologically safe environment.
Hi, Brian. Just one question. The HPE, right? Mm-hmm. You know, the gathering the dashboards, making sure those meetings are happening and all that stuff. Have you like a dedicated group of people to help? Is that all voluntary to make sure that runs? How's that kind of organized outside your day-to-day delivery commitments?
So the great thing is it's me. So I'm accountable for ensuring it happens. And we've evolved it to a model of somebody from org support basically schedules them all, and we've 70 teams, we talk to a team, they have 20 minutes to, again, we say present, but in truth, the first thing that we ask as a tech leadership is, what challenges have you faced? And the teams generally just take it from there. We started off with we wrote detailed reports on what the teams told us, and over time we discovered all the teams need as feedback is, what are the 3 things that they were successful at? Because again, that's important to recognize the success over the last 4 months, and what is the one thing they're going to focus on. So we've skinnied down the effort in actually doing those check-ins, and most of the value comes from the team's pre-conversation, which when the team know that this is coming up, they organize it themselves, and then those 20 minutes where the team gets to present. I'm going to probably go right back to the start. Should have put this as the last slide rather than we're nearly there. There. That conversation every 4 months really strengthens this relationship. Whenever you're sitting there being part of architecture and the team is feeling in a safe place, they will tell you just how good your roadmap, how good your strategy has been, because they've had to implement it. And from there, we're able to take actions as an architecture team to decide how we need to evolve, shall we say, our strategy and roadmap based on the implementation. And the teams really love getting time with the architects and being able to talk about the successes they've had. And they also like having time and talking about the pains that they're currently going through, because we can help them, we can support them. Sometimes it's just linking them up with another team that has done something that has solved that problem. And other times it actually does require a company level initiative to improve things.
Yeah. This is like kind of where I think everybody would love to be, you know, in terms of sort of a thoughtful sort of process. Where did you start from? And kind of what were some of the kind of the main challenges that you hit to get to this point?
Psychological safety is probably the biggest challenge. So where did we start from? We started from our most experienced engineering people just sitting down and writing down what does good look like. That actually doesn't take a lot of time. It's just people have got away from writing stuff down, and certainly writing stuff down at an org level as opposed to a team level to be able to do like onboarding of a new person. So we literally probably just documented what does plan, design, develop, test, deploy, review look like, and that's where we started. And we provided teams where I think actually we started off with just having that discussion, and we discovered the discussion was great, but if you didn't have actions or something of output at the end of it, nothing happened between the conversation and the conversation in 4 months' time. So from there, we started to actually record, and then we realized we had started to collect the stuff in spreadsheets. Well, that's not very visible, so that's where we then built a very, very basic dashboard, just that red, grey, and green. So it started small and it has grown over the last 4 or 5 years. But I will stress the first step was just for your engineering leaders to write down what they expect. And it's literally just a couple of paragraphs. It is not writing down, a full handbook of what you should do in every scenario. It's just providing that basic of what good looks like.
And within a larger organization, the implementation here is very much kind of like engineering. It's all within your domain. But who did you find were kind of the major stakeholders outside of engineering that actually had a direct involvement in shaping this?
I suppose the answer is we didn't find anybody. Because why? Because we focused this on the teams and on the engineering teams. Now, I will say that once we did the technical mastery bit, our product group then brought forth what their expectations of what good looks like for a team from a product perspective. And then layered on after that was really where you got into the architecture, the alignment, and the autonomy. I suppose another way of answering that is you do have to have your engineering leadership bought in, because quite often they're the ones that will make the call that the team can have that hour-long meeting before they come and talk for 20 minutes. But once you've got leadership bought in at the highest level, it just becomes something that you do because it's lightweight. It's not about taking people away for days on end to document stuff. It is start small and grow, and then whenever you start to see the level of engagement you get, you'll start to see how it snowballs.
I guess my point there was you talked about psychological safety. Any kind of transformation within a function, finance are going to care, products are going to care. You have all these other parts of the organization with, it's how you keep them feeling that things are safe while you undergo a transition.
So, the best example we had of that was how we structured the check-ins, where we put together clear guidance for the person who facilitates that check-in, what questions to ask. And it sounds really strange, but sometimes engineers can be a bit blunt. When they're facilitating, you had to actually ask open questions from that regard, but that's very much at the implementation level. I'm maybe not getting the gist.
Anyone else? I think that's us. Over to you, Jamet.
Thank you so much, Brian. In about 13 minutes, we're going to have Eamon Boyle coming on, so it's a great time to go and get some tea, coffee, quick toilet break if you need it as well, and we'll see you in about 10.
So I'm Russell Beggs. I'm the VP of Engineering for ESO. I look after all our engineering teams at ESO, and our company is very much focused on making a difference. Our mission is to improve the health and safety of our communities using the power of data. And what that really means is that we write a lot of software that paramedics, firefighters, and hospital staff use to track what's going on and to help create the data, track the data, and provide actionable insights to improve the quality of healthcare that's provided to people. So I'm super excited about NIDC. Early in my career, I moved out to Australia, and I got to see what an engineering community looked like out there. And when I came back, we didn't really have much of one. It was a bit of a fledgling. And it's been fantastic to see NIDC grow and grow year on year. Even with the pandemic, we still saw a lot of participation, albeit remote. So I'm really excited to see us all get back together in person, to see more of the talks, the technical talks that people are giving, to see so many different things that are happening, and to hear from management and leadership and the psychology of delivery as well. So super pumped to be back in person after such a long time being apart. We've got a lot going on in the fire space, but one that's particularly close to my heart here in Belfast is around patient registry. So you have stroke registries, trauma registries that really specialise in the care that they provide to patients. So if I give one example, a few years ago we recognised that there was a disparity between what paramedics were finding in the field and the hospitals were finding when it came to strokes. And there was about 50% chance that a paramedic would find that you had a stroke. And when we looked at the data and the correlation, the trends, we found two key things: ground level falls and diabetics. And when you look at that information, you publish insights on it, what we've seen in the last couple of years is that the detection rates have gone right up, and that's literally tens of thousands of lives that have been improved by that. So we've already done that. I'm really excited about how much more we'll be able to do now that we move further into that registry space.
Well, I've got a HDMI port. Yeah. I tested it.
Hello everybody, my name is Gemma Simpson and I'm your MC for Hall 1 today. Next up we have Eamon Boyle, who's a development manager at GearSet. Eamon's going to be discussing it's never too late to start benefiting from TypeScript. Now just before we start, thank you so much to GearSet because they are a Diamond sponsor. At the end of Eamon's talk, if there's enough time, we're going to do a Q&A. And if you do want to ask a question, could I just ask that you raise your hand and look for Glenn at the back, big man with a pink top on, so that he can give you a mic because it is being recorded, so we want everybody on the live stream to be able to hear your questions. So thank you so much, Eamon.
Thank you. Welcome everybody. Welcome to NIDC. I'm Eamon Boyle. My talk is It's Never Too Late to Start Benefiting from TypeScript. I'm a massive TypeScript fan. This talk is primarily for people who are maybe working with JavaScript and are thinking, can we actually move to TypeScript? And my answer, TLDR, is yes. You can now leave. That is the end answer. Who am I? Because why am I is a bit too difficult. I'm the development manager at GearSet. I've only been in this role a short time. I started in April. That's when we opened our Belfast office. Our HQ is over in Cambridge, but we opened up our Belfast office in April. I'm hire number 1, and I'm the development manager. We're on High Street, just opposite Lidl, which is super good for beers and power tools. So, you know, starting a new job is a big change. It's a big thing in your life. How do you actually go about doing it? I got this piece of advice a long time ago, and I think it's quite good, is just to go in and observe. So, you know, try not to just like immediately force your baggage onto the company, which is why I'm not giving a TypeScript talk, you know, but just to sit back, observe, get to know the company, get to know the people, understand the domain, understand their processes, just try to soak it all in and try to learn and ask questions, and then sort of see what really works here, what stuff have you done in the past that might be useful. That's the kind of thing that I try to do. So what did I observe when I went to GearSet? Absolutely loads to love. Incredibly focused on their customers. Customers are paramount. There's a couple of mottos that like really get sort of fired about on Slack. So you know, when you're thinking about unblocking, you're unblocking your customers first, then your colleagues, and then yourself. It's sort of, there's a value system which is like GearSet, team, self. So there's a lot to love there. The processes are really light. So from an engineering point of view, super light process. It's just about getting stuff out. We're releasing, you know, multiple times a day, and it's probably like one of the most collaborative places I've ever worked. You know, both within engineering, but also within the wider team. Everybody's on Slack, and I'm talking, you know, sales, marketing. Everybody's just talking all the time. So really nice place to work. From the tech stack point of view, it's running on top of Kubernetes, which is, you know, auto-scaling on AWS. It's a .NET backend, React on the front end, migrating from some legacy knockout stuff, but anything new is React, and it was using JavaScript. So I'm sort of like, you know, dropped into this code base, and I'm starting to add features and starting to get to use it and trying to think about how they're developing work and how they're, you know, the teams work. We have like independent pods. I'm trying to sort of think about like what's good and what's bad, and is there anything that I would maybe change, and be quite open-minded. And the thing that sort of like, you know, was still, you know, after like a month and a half was still sort of giving me pause was the JavaScript thing. Because yes, I love TypeScript, but I don't want to just come in and just say, hey, TypeScript's the answer, you know, what's the problem? Maybe, you know, JavaScript is 13 million developers. You know, they can't all be wrong. And modern JavaScript is not too bad, super popular. Well, who cares about popularity? It's good if you're in engineering because it means you've got lots of docs. It means you've got all the Stack Overflow answers when you go to do them. It means that there's lots of tools, all the bugs have been ironed out, there's lots of libraries, lots of good reasons for picking something that's popular. Even if technically it's maybe not the best, there's lots of reasons for picking popularity. And as a language, it's quite nice because it's dynamic, it's fairly succinct, and it's relatively performant, it's fast-ish. It's not going to beat Rust, but, you know, it's fine. And, you know, the data out there sort of stands up to this. If you look at, you know, a lot of surveys, JavaScript's quite often number 1 or very near the top. Stack Overflow survey from this year, JavaScript's number 1. TypeScript has been progressively over the years getting higher and higher and higher. It's now number 5. But if you look at, you know, the most loved languages, then it flips a little bit. So TypeScript's number 4 in terms of most loved, and JavaScript's way down at 16. Because a lot of people are using JavaScript because they're forced to, because you're developing for the browser, or you're doing a legacy system, or something like this. So people who switch to TypeScript generally love it, and we'll see that in some of the data within GearSet later. So why is it better? What is it? Maybe first of all, it's a superset of JavaScript. So in my mind, it's like super good engineering because it didn't like throw away the baby with the bathwater. It sort of said, okay, here's something that's not perfect, but it's pretty popular. Let's extend it and fix some of the problems. And the main problem that it tries to fix is the dynamic typing. So it adds static types. So that's basically what it does. You're leveraging all the benefits of JavaScript, and you do get some of the problems, which is maybe some of the things that people would say, hey, can't you go further? I think they've sort of picked the sweet spot from an engineering point of view. It interops really well with legacy code, and what that sort of means is you end up with your JavaScript-esque code base, but you have better autocomplete, better navigation, better refactoring, and you get compile time error checking, which for me is where I want to find my errors. I don't want to, I definitely don't want a customer finding them, but even when I'm developing, I don't want to find them at runtime. I want to find them at compile time. I'd actually really like to get it when I write the line. I would like to get it in the IDE when I hit the wrong character, and then immediately fix it then, because my brain is in the moment, in that line. It's the best time to fix it. So as you add or work with TypeScript, and even if you're in JavaScript, one of the reasons why JavaScript today is better than JavaScript in the past is that there's lots of TypeScript definitions out there. So when I'm working in JavaScript, I'm actually benefiting from TypeScript then because of the definitions. So lots and lots to love within TypeScript. And at the end of the talk, I'll throw up some code that's like a little bit gnarly, using some of the complex bits of the type system. I don't want this talk is not really about that. Go and see a different talk about TypeScript on that. This is more about like making that migration. So it is a really powerful type system. I'll show you some of that, but really the big win is the simple stuff. It's the day-to-day stuff. That's where you're getting the big wins, because when the tools know more information about your code through the type system, your life is easier. And just, when you're using unfamiliar APIs, or using APIs from somebody else that wrote the code, or somebody else who wrote it 5 years ago, it's just much, much, much easier. And anybody who's used TypeScript with AWS APIs, this is like a super big win here. So for example, if I'm using an API, but I'm not super familiar with it, and I'm checking, it's a Star Wars object, and I can say, Misa people gonna die, then I can use autocomplete and find out I can use the Force or something like that. There's an interesting one there as well, Kiss Sister Never. There's a never type in TypeScript. So yeah, that's what we've got going on with our autocomplete. So how would I introduce this into this existing company? Again, I'm not long in the company. How to go about doing that? We have this process called the technical roadmap, and this is a place where we can sort of raise engineering improvements that are basically going to allow us to deliver to our customers. So there are things that are not necessarily customer facing. There's not too many of our customers say, hey, would you mind switching to TypeScript? But maybe by doing this, we can release faster, we can scale faster, these kinds of things. So that was sort of, we had this forum to bring this feature. So I brought it, and why did I think it fitted the team? Why did we, what was my motivation, and how did I sell it to people? We've got a fairly large code base. We've got a fairly large team. We've over 50 engineers, and we want to grow that team bigger. So, TypeScript for me makes that job easier, working a large code base with a large team and adding new people. Because when we have that improved tooling, onboarding's easier, scaling's easier, because they've got that autocomplete, they've got that error checking, all that sort of stuff. Because we've got that legacy code base, the interop with JavaScript is super important. Coming out, hey, let's just rewrite it in something else, that's a very difficult thing to do. That gradual migration is an important part of the story as well. And we're using React, and the TypeScript support in React is pretty awesome. Any problems? Because again, this forum is a place to raise issues as well. So type complexity. So if you're a JavaScript house, and you're writing JavaScript and Python and everything's dynamically typed, and you've never seen a type before, that might be a problem, because it's a small addition. It's an addition worth making, in my opinion. But if you're not familiar with types, you don't like types, then that's a bit of an issue. Our guys are writing C# on the back end, so types are their bread and butter. That's not a problem. So that was a concern, but not really for us. Build time. We like to iterate fast. You know, we like to develop and be able to get features out, you know, multiple times a day. So build time is an important thing. Slowing development, maybe this migration is not worth it. So yes, it might be better, but is it worth it? Because it's going to slow down development. That's a concern that was raised. We're migrating some stuff to React. Maybe migrating 2 things at once is going to muddy the water. And again, that's something to think about in terms of like what you're trying to tackle and, you know, what stage of maturity your team's at. And then some duplication of code, because we're writing some code in .NET and we're writing some code in TypeScript. Maybe we're doubling up on models. There are some tools around automating that, but then that can lead to complexity too. So these were some of the things we raised and sort of weighed them up and decided, you know, this is actually something we want to do. So what were our non-negotiables, things that we had to get right? Had to be incremental. So any change we do have to be incremental so we can keep those releases going out. No such thing as a big bang feature in our place. Everything has to be sliced up and delivered incrementally. Has to have easy interop, because again, you've got lots of developers working this code base, so you can't then suddenly make it, hey, I can't work on this feature. So JavaScript, the TypeScript story has to be good. The TypeScript, the JavaScript story has to be good. Build speed, and more importantly, incremental build speed has to be good. So as you're working on features, you can quickly see the refresh in the browser and validate that things are working. We do testing, so we need to have good test support. We do static code analysis and linting, so that has to have good support. We leverage the tools, so it has to be good config and ID. Again, we don't want to be that we're onboarding somebody and they have to spend all day setting up their machine. And then we have to sort of roll out some training to the guys as well, make sure that people can start using this stuff quickly and we can start making that migration. So, took that forum, decided that this was something we want to do. What are the steps? First of all, we need to extend the build system to support TypeScript. Then we need to validate through a couple of things that we've said in our non-negotiables, so that we can do the interop, and that source maps work, and we can do debugging, and all these kinds of things. Then roll it out to the team and say, right, start to use this for new code. Any new classes, any new models, write them in TypeScript first. Start to migrate active code that you're in. So if you're putting a feature into legacy code, make the decision. Is it of a size that you can do the migration first as part of that, so that then the new feature, the new work is easier. And then if there's some core APIs that we're maybe not working in, but they're there and they're consumed a lot, maybe migrate those too, or put a TypeScript wrapper around them so we get the benefit there. And again, starting to roll out some training. So extend the build system, depending, again, what your setup is relatively easy. This was fairly easy because modern JavaScript is complicated in and of itself. The build system is pretty complex. We have lots of tools. We've got our Webpack, Babel, we've got linting tools, testing tools. So, you know, there's quite a large complexity there. There's quite a lot of configuration there already. Making it work with TypeScript was just small transitions because it's very, very popular and somebody's already done all the work. So largely it's going into these tools, following a tutorial, and adding a small bit of config, adding a few NPM packages, and then you're up and running. And now your system supports both JavaScript and TypeScript. And this was more of a concern for us because we're using some older technologies like Knockout in there in places. But again, that was sort of fairly simple and seamless. Then starting to validate, so again, picking the things we're going to go after first. So take some JavaScript, migrate it to TypeScript. Start off with some basic models, things that doesn't have any dependencies. Then find a React component, again, no dependencies, something really small, something very simple. Migrate that, prove that it works. Then danger time, go into Knockout and find some Knockout code and try and migrate that. Again, something that's quite small. Prove that out. Then make sure that we can actually consume the TypeScript that we're migrating from JavaScript easily. And we maybe get some of those benefits, some of that autocomplete. Go the other way, make sure that we've got some TypeScript code written and that we can actually consume that from JavaScript. And just as we're doing this, we're getting more and more confidence that actually this is going to work and we can start rolling this out. Putting in some type declaration files as well, just to make sure that that's working, and we could document some of this and give people some best practices about how to migrate the common things. So part of the training side is just documenting as we go here. And then, yeah, extending with tests, verifying linting, so putting in some bad code and then verifying that it's getting fixed, and then consuming some JavaScript libraries. So all of the concerns, we're just going down that checklist, and every time we're sort of passing the test and getting something into the code base, just gaining more and more confidence, and then start rolling it out on the team. So off the back of this, from, you know, like rolling it out in the team and seeing some of the questions that came back, would have any guidance for people that are maybe going to do this. One of the things to keep remembering about TypeScript is that it's going to help you at compile time. It's not going to help you at runtime. So I used to do quite a lot of training, and when I did that, and when we were doing this with people who hadn't used TypeScript internally, this is again a misconception that people quite often have. They think that TypeScript is types, so at runtime, if something's the wrong type, you'll get errors. You won't. TypeScript is largely erased. It's only, or the main benefit is at compile time. So there are certain points in your system around the periphery where you don't have types. So the big one, if you're doing, you know, like a hosted service, is you're making a REST request and you get back an object. The object is coming back as text. It's coming back as JSON. When you convert that into an object in JavaScript, it's just an object with some stuff in it. Whenever you're using that code from TypeScript, you're just going to assign a type typically. You can write some JavaScript code to validate it, but typically you're just going to say, okay, I'm making this call, and what I get back is this kind of object. And there's no checking, absolutely no checking there. The system is going to trust what you have told it. So it will give you the autocomplete and the error checking given the information that you've provided. So here, for example, I'm hitting a Star Wars endpoint, and what I'm going to get back is a Star Wars object, but in TypeScript, I've said it's a Star Trek object. So whenever I do my autocomplete, I'm going to get Star Trek things. And in fact, if I try to do anything Star Warsy, I'm going to get a compiler error, you know? Yeah. This is something to really keep in mind. It's really during development, it's at compile time, making sure that you're writing the right code. And I've got some other sort of guidance there as well, just in terms of things that you can do. So avoid any as much as possible. Any basically drops you down to JavaScript. I did sort of like promote TypeScript once to a company, and then I checked in with them a little while later, and they said, hey, yeah, we've adopted TypeScript, but everything was any. So they'd added types, but it was just the any type, which is a type, I guess, but you know, it doesn't give you any of the benefit of what TypeScript's doing for you. But whenever you're doing migrations like this, you're going to be dealing with some legacy codes, maybe some libraries that haven't been wrapped up, and they're not necessarily going to have, they could be quite complex, they're not going to necessarily have types, so you might want to use any to get some feature in or to get some other piece of code migrated. So there is a time where you will use any. That's sort of what it's for. If you're doing that, I would suggest aliasing out the type. So for example, I have some complex type that's used many times in a file. I don't want to define that type today, but I can alias it out. So in my code, it's going to say complex type everywhere. It's going to resolve to any, but then it means there's a single point where I can then come in later and add the stronger type definitions around that. So avoid any as much as possible. If you have to use it, create a nice little alias for it. A big question that keeps coming up as people start to get familiar with this stuff is like, which way do we define our shapes? Which way do we define our objects? Do we do them inline? Do we do them as interfaces? Do we do them as types? How do we actually describe these things? Because there's several different ways of doing it. For the most part, because again, the big win is the simple stuff, for the most part, use interfaces. They're readily understood by people coming from other languages. It's a concept that we're all very familiar with. There's an added benefit that the compiler processes them slightly faster. So there's like a slight build time win. That wouldn't be the main reason I would say to do it. I would say to do it for simplicities. I would say keep the type stuff for the more complex things. Okay, so just stick with interfaces as much as possible. If you're using classes, again, people that weren't familiar with TypeScript, if they are writing classes, you know, we sort of had to say, hey, make sure you're using the parameter properties. So this is a nice little feature that TypeScript has, where when you're defining the inputs to a constructor, you can add a modifier keyword, such as public or read-only, and it makes the parameter both the parameter and the definition and initialization of a property. So the code above and the code below are equivalent, but obviously there's less noise in the code below. In general, especially as you start to write your code a bit more functionally, especially if you're doing things in React and maybe using some of the libraries around React, you're generally going to tend away from classes anyway. You're going to just stick with basic objects and interfaces. But if you are writing classes, this is a good tip for that one. So, you know, this is sort of the kind of things we were doing, rolling out, giving the team the training. How quickly can you actually implement this stuff? This is a graph of our migration, because again, I've talked to people before and they've said, oh yeah, my company said we were going to convert to TypeScript. It's 2 years later, we still haven't started. Or my company said we were going to switch to this framework like React, but like 2 years on, it's a pipe dream. You can do this stuff fairly quickly as long as you get everybody on board. So this is only like after 4.5 months. The yellow is the number of JavaScript files in our code base, and the blue line is the number of TypeScript files. So yeah, there's going to be a crossover point. Hopefully, if I do this talk again, I'll have crossed over. The TypeScript files are increasing faster than the JavaScript are decreasing. because there's legacy code there that we don't need to migrate because it just works and it's sitting there. So, this is not just an academic exercise because Eamon prefers TypeScript. We want to do this because it's actually going to make our lives easier, so we're going to do it around the code that's active. We're also continuing to add features to the code, so all of that's getting written in TypeScript. So, yeah, it's definitely very, very doable. I did some analysis in the team before this talk just to see, actually, yeah, I like it. I think it's good. What did you guys think? So I did like a little survey just within engineering to see how they found it. So how have you found the ongoing migration to TypeScript from easy to difficult? And yeah, as you can see there, the graph is mainly over in the easy column. Some people, as I say, didn't have TypeScript experience, which is probably why it's like one-off, super easy. It's like, yeah, it's pretty easy, and but not super, super easy. In terms of how do you compare using TypeScript to JavaScript, notice how I flipped where the good side is, you see, to make sure people were reading the questions. So most people have said that using TypeScript in the code base is easier, which is interesting because not everybody said that it was like super, super easy, but once it's in there and they're actually using it, at that point it's like, yeah, I'd much rather work in TypeScript than JavaScript. And then what's your opinion on, did we make the right choice in terms of doing the migration? Again, resoundingly yes. One person's not saying definitely, that's a good scientist and a good engineer, not 100%. I also got some comments just to again see what people thought about it. We love TypeScript, pretty succinct, to the point. Gives me so much confidence when refactoring. And then this one I really liked. So TypeScript plus React plus Redux have made the front-end development from something I try my best to avoid to something I'm quite happy to work on and improve. So that was sort of the goal that we wanted to do. There again, we're sort of a pretty pragmatic bunch, so there was also some criticism here. And this is I would really take this one on, I'd agree with this one. So the only negative is that it can make me a bit lazy when refactoring normal JavaScript, which can lead to mistakes, and then that TypeScript would have picked up. And this is definitely true because this is the thing that, this was the instigator for me, or the motivation for me, was like working in the code base in JavaScript without the types, without knowing the APIs, without knowing the domain. I wasn't there when this code was written. It's just harder to work with in JavaScript, and you have to do a lot more like search and replace and really like looking closely. And then when you're in TypeScript, you go Shift F6, Command and B, and you just trust the tool to do the work. So yeah, I totally agree with that one. So I didn't want to bore you all with just process stuff, so I thought I'd throw in some code as well, because we are at a developer conference after all. So these are some snippets of bits of code from our code base, or things we found useful. As I say, it's generally the day-to-day simple stuff. It's the boring stuff of this variable's a number and this variable's a string. That's the stuff where it's wins all the time. But I just thought I'd show you some other features. This is a discriminated union. So in TypeScript we have union types, which basically say there's a type that is a set of multiple types. So this thing in my hand is either this, this, or this. So we have this polling function, and when you call the polling function, it gives you a result, and the result is either that it's still polling, or it's completed, or it had an error. So when we call this function, we're going to get one of these three kinds of objects back. And the objects have slightly different shapes. One of them, when it completes, you have a result. When it errors, you get an error. And if it's still polling, you get nothing. So they're different shapes. And what a discriminated union does is it gives us a mechanism within a union to easily discern which type it is. And it's usually by having one or more common parts. So in this one here, we have a common state, which basically says what state the poll is in. That object was there. This type existed, by the way, in JavaScript. So this code worked the same. The objects were the same shapes. All we did was add types to it after the fact, okay? And that's, again, what TypeScript does really well. It works really well with your JavaScript code. So here we've got this state, which would have said, anyway, what value the state property had would tell you what state the poll was in, polling, complete, or error. Here we're defining as part of the type. We're saying that when it's polling, the type of state is polling. It's a value and a type. And what this allows the compiler to do is to automatically narrow and sort out your types by looking at how your control flow works around this state. So When I call this function and I've got this union, I don't know what it is. Because I don't know what it is, the compiler will not let me use result, will not let me use error. Sometimes there will be a result, but not every time. Sometimes there will be an error, but not every time. So the compiler will actually complain if I try to use this in that form. So what do I have to do? What did the JavaScript code do before? It had to check the state variable. So this code, again, existed in JavaScript. We say, what is state? If it's polling, do this. If it's complete, do this. If it's error, do this. But remember that the compiler is not letting me use result. It's not letting me use error. But whenever I check the state variable, it does. And in fact, it gives me autocomplete, and it will give me errors if I try to use the object in one of the other states. So the code that I've written is identical to the JavaScript code that I would write. But the compiler is keeping me right, and it's giving me the error checking, and it's forcing me to do this check. And it does lots of other nice little things, like so if I'm building out the switch statement, it knows all the possible values of state. So it'll, you know, with option enter, enter, it'll like populate my cases and build those out. If I miss a case, then it'll give me a compiler and say, hey, you haven't handled all the cases. This is super useful when code's being maintained, because somebody goes in and they add a case, and then they've updated several of the places where that's been used, but they've missed one. Here they'll get a compiler error. So that's like some of the nice things that we get with TypeScript. It also has tuples, which we use quite a lot. So these are just like fixed sized arrays where each element in the array has a specific type. And again, the compiler knows information about the position. So here I've got a tuple that has a string, a number, a date. In the first position, I can do stringy stuff. In the second position, I can do numbery stuff, etc. So tuples are super useful data type in TypeScript. We use them a lot in React when we're creating pieces of state. The state function returns two things. It returns the value and a function to update the value. That comes back as a tuple. The compiler understands which piece of data is in which position. So in we destructure, it lets me use the value, and it also lets me call the function and gives me autocomplete and all of that good stuff that I want. We had a function we needed to write, which is just pulling out some query parameters from the URL. So we want to say, you know, pull out the search parameter and the page parameter, or pull out search, page, and count. That's going to return with some values. How many values? It's going to match the number of values going in. So we can create a tuple that comes out the other side that is the same size as the number of parameters going in. And the type system allows us to do this, and again, gives us compiler errors if we try to use it incorrectly. If we try to use 3 parameters on the first line there, for example. The way you program this up, I'm not going to linger on this slide too long, but this is the kind of sort of gnarly stuff that you can do in TypeScript. So this is using conditional types to basically decide between one of two types. It's using recursive types. So we have a type calling itself to build out a more complex type. And it's super gnarly code, and you put it in a little box, and you put it in the corner, and then you just consume it. And then it just means that your life is easy over here. So you can do this sort of stuff. It is really, really powerful, but it's more the day-to-day the simple stuff that you gain day to day, that's the real benefit. But when you need to, you can put your hand and do some really sort of funky stuff. So, wrap up. Super easy to add. Really recommend that you do it if you have the existing build system. It can be introduced gradually, so it's not a big bang thing, so it should be an easy sell. You'll start to see an immediate benefit. It's not like once we converted, we're done. It's like you'll start to see an immediate benefit. And because it's a superset of JavaScript, if you're using JavaScript today, the skills are easily transferable. That's me. Any questions? We're also got a booth out there if you want to come and chat to us and get some popcorn. And we're also doing like a raffle, little coding puzzle, and you can win a £100 Amazon voucher. So come and see us afterwards. So.
Okay, everybody, in about 15 minutes at 11:30, Maurice Kelly will be joining us, and he'll be discussing all things about ad tech, which I am very interested in. So grab teas, coffees, quick toilet break, and we'll see you back in 15.
So my name's Darren Abel, so I'm the Director of Engineering at Apex FinTech Solutions. So I joined the company 2.5 years ago. My role is really to supervise all the technology projects that we do in Belfast. Apex FinTech Solutions was formed in 2012 by Peak 6. So Peak 6 is an investment company, and Apex is essentially the technology company that is behind the trading solutions that we build for our customers. So the whole mission of Apex is really to democratize trading. They're one of the big disruptors in the industry. So it's because of Apex that people now can actually trade through their mobile phones. A lot of the work that we do, we can't disclose. It's under the radar, so to speak. We are really looking forward to. We have one of our other companies is speaking on it as well, Evil Geniuses. So we're looking forward to hearing what they've got to say, and as well as one of our own managers, Niall Haslam. He's also speaking at the conference. So we're really excited about those and to see what else other people are doing in Belfast. Like I say, the tech community in Belfast is huge, and we can't wait for the conference. Yeah, so obviously we were given the opportunity to sponsor NIDC. We jumped at it. So NIDC is obviously conference for developers by developers. So one of the big things for us in Belfast is really getting our brand out there. We were previously known as Peak 6, and now we're known as Apex. So we're a subsidiary of Peak 6. So it's making sure that we get that out to our target audience, who are developers, because we're a technology company. And really then, obviously, during COVID, for instance, everybody's been at home, so we recognise how important it is to have events like this where we get everybody together, so that's why we kind of jumped at the chance and the opportunity then to sponsor NIDC, and we're really looking forward to the conference. So over the past 2.5 years, we've grown to 98 people. We're continuing to grow and continuing to hire in technology and operations. So if you're interested in joining us, please get in touch or speak to Clark and Robin in our stand.
I'm here.
Oh, sorry.
No, you're okay. Hello, everybody. Next up, we're going to have Maurice Kelly. Maurice Kelly, I'm so sorry. Maurice Kelly talking about ad tech. It's cooler than you think. Just want to say a massive thank you to Magnet for being our platinum sponsor, for which Maurice is a member of their staff. At the very end, if we have time for Q&A, can you please look for Glenn at the back in the big pink t-shirt, and he'll pass you a mic to ask a question. But if we are running off time, lunchtime is next up after Maurice's chat, so then you can go outside and check them out at their stalls. So, thank you very much.
Thank you, Gemma. Let me hit reset in this. So, thanks for being here today. I get to do the whole thing where I say I'm the person who stands between you and lunch, so I will go fast. I can't promise to go any faster than I would normally would, but I'll do my best. So, I'm Maurice Kelly from Magnite. It is brilliant to be here, and I hope you're having a great day. I also really hope that you're interested to hear more about programmatic advertising, because it is actually a lot cooler than you would think. So we'll start with a bit of an introduction, then we'll dive into how programmatic advertising actually works, and then we'll talk a little bit about the challenges that the industry faces. So, meet Magnite, the world's largest independent sell-side platform. I kind of have to put that slide in there, but it does explain a little bit about what we do. So we are an independent ad platform, and we focus mostly on the sell side. So that's on the side of the publisher. So the people who are selling the inventory on their website. Magnite itself was born from the merging of two advertising companies. We had the Rubicon project, which is quite an amazing name. I'm sad they gave that up, and Talaria. So the Rubicon project brought a DV+, or digital video and more, technology and online video advertising tech to the table, while Talaria was in the connected TV market. In mid-2021, Magnite acquired SpotX. So you might have heard of SpotX. They have been around in Belfast for a while, and they had started as Spot Exchange in 2007. And they built out a real-time bidding engine that was very much focused on connected TV as well. And since then, Magnite has gone on an acquisition spree as well, and we have bought some more companies such as SpringServe for doing ad serving, and Carbon and Nth Party, who are focused around audience data. So programmatic advertising. Wikipedia defines programmatic advertising as the fully automated and individualized purchase and sale of advertising space in real time, which is quite a mouthful. Me, I am a director of engineering at Magnite. I'm the author of some tech books and a former magazine writer. If you're in the NI Tech Slack, I'm at Mo. Say hello sometime. And I get a little bit too into my Apple stuff and especially my synthesizer collection. So programmatic advertising, how does it actually work? To best understand it, it's probably important to go back to the beginning. Back in the 90s, there was some bright spark called Tim Berners-Lee, and he said, let there be web. And there was web, and it was good and pure and existed mostly on GeoCities. And within seconds, or roughly thereabouts, some Don Draper wannabe said, let there be banner ads. And there were banner ads, and online advertising began. So the first banner ad was displayed on the Hotwired website, which was an online offshoot of Wired magazine. It was part of an AT&T campaign called You Will, which was an attempt to predict future technology. So they did things like, they said, have you ever bought concert tickets from your computer without queuing in the rain? You will. And their first banner ad was, have you ever clicked your mouse right here? You will. And people did. And probably the biggest prediction they made that day was that the online ad would become ubiquitous. So actually selling those ads, how it would have been done was a website would have offered some space to an advertiser to insert an ad. And because of the legacy of the advertising industry, we do have some terms for it. So, and you'll hear these a lot through this talk. The website would be known as the publisher or the seller or the supplier. The space that they use, they're offering to advertise in is known as the inventory, and the advertisers themselves are known as the buyer. And in the case of that first banner ad, Hotwired, they would be the seller or the publisher. The space in which you inserted that banner ad would be the inventory, and AT&T would have been the buyer who wanted to insert their ad. So how do you go about making such a deal? Well, the first step is you get your seller and your buyer. The advertiser, the buyer, will give you a URL for an ad image. You could update the HTML on your website and stick in an image tag and link to that ad image. And if you want to go a wee bit further, you could wrap that image tag with an anchor link, and that would bring the person to a call to action page. And we've basically just solved online advertising. The natural thing to do is to head to the drinks cabinet and make yourselves an old-fashioned Don Draper style. But the problem with that is that it's not really scalable. It works for one ad or one site or maybe a few more, but as a publisher, you're probably going to want to sell your inventory to multiple buyers. As an advertiser, you want to sell your inventory to multiple, or you want to buy inventory from multiple publishers. And you could end up with every advertiser having a direct deal set up with every publisher. And that will grow exponentially, and as we all know, that's not web scale. So it's fair to say that online advertising exploded from those early days, but we did need to solve specific problems to allow growth beyond those simple direct deals. And the best way to understand how that went is to reinvent ad tech. So the first thing we'll reinvent is the tracking of ad views. We'll look into tracking clicks, changing the ad itself, supporting multiple advertisers in a single slot, and then we'll look at not having to manage those ads for ourselves. So any advertiser needs to know how many people see their ads, or they might not bother advertising again. And it's critical for that relationship between a publisher and an advertiser. Since the ad's hosted on a web server, we can use some old technologies like the tried and true access.log. Web servers, they can record every request that's made, so a wee bit of grepping, that will solve the question of how many times that ad image was requested. And we can from that infer a value for impressions, which is how often an advert is shown. Now, it's definitely not an accurate science. You could find that the page load had been cancelled, or the server might not have returned 200 OK, or the request could come from a non-human client. So if you've got a search engine crawling that website, that really doesn't count as an ad impression. And advertisers do pay by impression, which we also call the cost per mille, or cost per 1,000 impressions. So there's no point in running millions of ads if your business can't keep up with demand. And there's also no point in running any ads if your business is not getting any clicks on those ads. And that's where a simple A link will actually let us down. So it does let the viewer click it and find out more information, subscribe, donate, whatever you want to do, but it doesn't offer much in the way of tracking. If we wanted, we could analyze access.log again, but it's not as straightforward, because if it's to be any use to the publisher, it's got to be, or sorry, the advertiser, it's got to be pointing to something that they control. But if it's not a link to something on the advertiser server, well then it's not going to appear in the publisher's logs. So we could use a redirection feature in the website. We could point the A link to the URL path that does redirects, and the redirect logic will then, after we've registered the click, the redirect logic can take you to the appropriate advertiser URL. So now everybody gets to analyze their own logs. You know, publisher can look at their logs, see how many clicks were there. Advertiser can see how many people landed on their website. Everybody gets happy. At some point, you're also going to want to change that ad. So the initial ad was a direct deal, but eventually that deal has to come to an end, and it could come to an end after a specific amount of time, or it could reach a certain cost threshold. But whatever the reason is, when you have a new ad to display, and it could be from a new publisher, a new advertiser. So we've got to update some stuff on our publisher site. So that means you need to change the image URL, the anchor link, any scripts you're using to analyze access.log, they're going to have to be updated. And that's feasible. You could do that for a time-based threshold, but if you're talking about cost, you have no idea when you're going to hit that threshold. So the other problem is you've got to change your HTML every time you want to change your ad. Of course, then you've got multiple concurrent advertisers. So if you have one person, that's fine, or one advertiser, that's fine. But what if you had two? Thankfully, it's the 90s, so we can use CGI bin, which is, of course, the ultimate hammer that is used to smash anything that is a nail, looks like a nail, or may have been a nail in a previous life. So a CGI bin script could handle the round robining between advertisers, and it will also do things like state tracking or impression tracking, and even stuff like doing an uneven distribution of ads between advertisers. So we could replace that original bit of HTML with an SSI, a server-side include, and we end up in a much better place. So we no longer have to change that ad-specific code in our HTML every time, and any future improvements get done in one place. So how do you manage all those ads? You don't want to be doing this by hand all the time. Any errors and code changes will or could affect revenue if they cause problems to your site. And you don't want your ad sales team getting in touch with the devs every time they want to put in a new advertiser. So the only way to solve a software problem is to add more software. Publishers, they're going to have a content management system. So ads, they're a form of content. You could stick those in. You put in an image, you put in a threshold, some configuration for how long or how much the campaign should run for, and stick in that link to the advertiser website. And you've got a rudimentary ad management server. So the obvious step for any company that invents new software, you're going to want to pivot. And we want to give a special shout out to Netflix for recently seeing the light and introducing an ad-supported tier. It's good of you to join us. So a direct deal working with an ad server. There's two parts to this. There's a setup flow, and then there's a user flow. So in the setup flow, you've got an advertiser who are going to load their ads into the ad server. That advertiser will then arrange a deal with the publisher, and the publisher will say, hey, give me some stuff from the ad server so that I can put that into my web page. When you bring the user in, the user will then request a page from the publisher. The publisher returns that content, and it includes a link to the ad server. So the browser will then request the ad from the ad server. That will cause an impression to be recorded, and the ad gets returned to the user. So the user browses their page, they find the ad super compelling, and they decide they're going to click through. So the ad will link them to the ad server, and that click can now be tracked. The ad server will return the real link to the advertiser website, and the client can then go and contact the advertiser directly. So it's a nice system, but it's it's still a lot of overhead. But we can see now why the ad tech industry took off. There are challenges in such a manual system. First one, we've got a nice system, but there's a lot of human interaction required. Anytime we try to scale it out, it's going to become even harder. And there are some challenges to be overcome. How do you place your advert in multiple websites? How do you accept adverts from multiple advertisers? Or how do you target the right audience with your ads? And how do you get, as a publisher, the best return on your inventory? And most of all, how do you do all that without making a human being cry? This is where programmatic advertising really comes in. We need something to bring this ecosystem together. What we need is a service for the publisher to list their inventory. We need a service for an advertiser to list their ad campaigns. And we need a service that matches a publisher's ad request to an ad. Those are inventory, campaigns, and ad matching. Are you getting it yet? This is not 3 separate services. This is one service. What we have is the ad exchange. So the ad exchange it follows a simple model that we've been following for most of our lives as human beings. We buy and sell goods. We've been doing it for thousands of years. And direct deals are always going to be a thing for us. But we develop markets and exchanges for a reason. We've got multiple buyers able to negotiate with multiple sellers at the same time. And we see that all around us, whether it be livestock markets, flower markets in Amsterdam, the White Linen Hall in Belfast where linen was bought and sold, or even our stock markets and commodities exchanges. So when we introduce an ad exchange into our ecosystem, it allows us to have multiple advertisers involved at the same time. It's a similar flow to what we saw previously, but this time when an ad is requested from the ad server, the impression is again recorded, and this time the ad server will connect to the ad exchange to ask for the best price for that ad. The ad exchange will contact multiple advertisers with information about that ad request, and the advertisers will respond with bids in a real-time auction. The best price ad will win, and the ad details get returned to the ad server, and the ad server returns that ad to the user, who will then follow the flow as before when they see that super compelling ad that's extremely relevant to them. So what do we gain from this? As a publisher, you get support from multiple advertisers for any ad request. We've got no need to maintain relationships with every advertiser, and we get the best possible price for our inventory. And it also means that we've got more relevant advertising, and that gives us, again, better prices. As an advertiser, there's no need to negotiate with deals with publishers. We can add to you can get yourself added to that exchange at any time, and you can get more relevant advertising, which is more click-throughs for you. And as a consumer, there is a benefit. You get more relevant advertising that gets displayed to you. So the question then for any advertiser is, how much would you bid? What's a good amount? Are you going to throw your money blindly at some auction? Or is there some sort of science to the process? Are you going to end up like Joey and buy yourself a sailboat at the silent auction? Thankfully, advertisers will get information. When they're invited to bid, they get some context for the ad request. So they're going to get some publisher information, and they can tell if this publisher is relevant to the brands or products. They also find out if there's like a shared customer base or anything else that's relevant. You get content information. You find out what the page is actually about. And you can find out things like, is this page, mentioning our competitors, or that could be a good thing or a bad thing, depending on whether or not you want to be associated with them. And you get some user information. Like if you already have a relationship with this user or have advertised them before, that's significant. And you get some information about that particular request. Is this a good time for us to be advertising? Do people want to be advertised alcohol at 9 a.m. in the morning? Possibly. Or you could find out if there's not much time left in your campaign, you might want to push out as much adverts as possible. So how do you increase those bid amounts? Well, the first step is to make the advertisers want it more. And the second step is to increase the number of bidders. If you make them want it more, you can, or to make them want it more, you can give them more information. And the most valuable information is probably about the user. And what you know about that person who sees your ad is critical to what you'll bid. And that's why you get asked questions like this nowadays. It's an unfortunate side effect, but it is important. And it's where we get data management platforms. So whether or not you do consent to those cookies, some information about you will go to a DMP. And the purpose of a DMP is to collect data about the audience. So once you have that information, you can then categorize your audience into segments. So for example, you can look at specific age groups, locations, interests, behaviors, device characteristics. There's so many of them. And you can get this from first-party information, which the publisher supplies, but you can also get it supplemented by third-party data. If you want to increase the number of bidders, well, the number of bidders that you have is important, because the more you have, the more likely you are to get a higher bid. You don't necessarily bid against the other bidders, but the more you have in the auction, the better it is. When advertisers are segmented, it's harder to get an ad request to all of them. So if you have 2 different ad exchanges with advertisers that are completely unconnected, they'll start asking for sending out ad requests. They'll get responses, but what you'll find is that you're missing some of the best bids. However, if you connect all of them to one ad exchange, well then all of a sudden you can get the best range of bids for your ad request. And that's where demand-side platforms come in. So the DSP was developed to give advertisers access to multiple ad exchanges. So an advertiser can connect directly to a DSP, and the DSP can then connect to multiple ad exchanges on behalf of that advertiser. It is important to remember that the DSP is still optional, but they do offer more control over where and how your ads are inserted, so it's pretty important to a lot of our advertisers. Of course, publishers also want to get in on this, and they want to increase the number of exchanges they're connecting to. That's why we have a supply-side platform as well. So that supply-side platform can allow the publisher to maintain their inventory in one place, and then allow multiple exchanges to handle that. And they can still connect directly to an ad exchange if they want. So what we're getting here is a pretty complicated ecosystem. You know, we started out with a simple publisher and advertiser. We threw them an ad server, then we gave them an ad exchange. And as we increased the number of advertisers, we introduced DSPs to help things scale. And then we introduced more publishers, so we brought in SSPs. And that because we've got SSPs and DSPs, we can put in more ad exchanges as well. And just to make it nice and complex, we'll throw in a DMP just to season it all off. When you work in programmatic advertising, there are 3 big challenges that you've got to face. They're scale, speed, and accuracy. When you're dealing with billions of ad requests per day, you have to be able to scale. For us, for our connected TV platforms, we're doing about 40 billion ad requests per day. For our digital video and more platform, we are doing 625 billion requests per day. You've got to be able to scale your costs effectively, but still keep the performance levels high so that the auctions aren't affected. Those auctions have to happen quickly. Banner ads can't load in long after the page is loaded, and videos can't be, they need to be inserted seamlessly to maintain the experience for the user. We need to be able to do this all in under a second, and interactions all with other systems, they have to be fast too. Finally, the best decisions are always made with accurate data. If you are making real-time decisions at the point of the ad request, you've got to be able to make the right decisions, and so having really good data is vital for that. But it also helps when you're making decisions after the campaign has run. Maybe you want to figure out if the campaign has been successful, if other targeting options would have been better. So, working at Magnite, because I have to put this in here, if you wanted to work on scale, speed, and accuracy, you can help us to scale our capabilities so that we handle more auctions, speed up our responses so that we can win more auctions, and then improve the data accuracy so we can get the best prices for our customers. So as lunch approaches, so does our tour of programmatic advertising. Thank you for listening. And if it was actually cooler than you thought, then why not talk to us some more? We are out in the sponsor hall, so come to us with your questions if you don't want to ask anything right now. And see us on magnite.com and magnite.com/careers. Thank you.
Can you take a question, Mo?
Go for it. As long as it's not where the babies come from.
Hello. I'm actually a publisher, not from websites, but mobile apps. I actually recently integrated Magnite with AdMob mediation. I have no idea that Magnite was in Belfast, so I'm quite surprised. That's good to know. I have a question that always bugged me since I started using it as a publisher. It's a bit of a black box for us in terms of pricing. And we don't really know, for example, what commission or how that commission factors in, because obviously for us to make money, you make money and AdMob makes money, but there's a lack of transparency of what we get and they get, because I see that, for example, with AdMob, and I know it's seasonal throughout the year, but there are moments that it's like very suspicious how it drops. Because, for example, when Google was hit by big fines from European Union, there was an impact there. I don't know if it's a coincidence or it's not, if they adjust how much they take, but the publishers don't know anything about it. Do you have anything to say about that?
I'd love to tell you that you've hit upon the person who's exactly responsible for that area, but unfortunately you haven't. I don't know how we get more transparency to the users on that. I don't know if is your relationship directly with Magnite or is it with AdMob? AdMob. So it's probably up to AdMob to give you that information. Whether or not they get it from us is another question.
Exactly.
When I say another question, I don't mean for somebody to ask, because I'm just going to say I don't know. Do you have a question, Glenn?
I was going to say any more questions for Mo to dodge, but there is one more.
I'll just make it quick. I'm actually a publisher as well. Sorry. New Ireland TV. It's available free worldwide on Roku and Amazon Fire TV Stick. I'm trying to program in advertising now. I'm getting 120,000 monthly views, and I've been getting that sustained since about January. I'm finding it extremely difficult just to. You've actually broken it down quite well there, but just breaking down the whole process of it. And every time I feel like I've cracked it, it seems to be another mountain to get over. Is there any way? I didn't realize Magnite were in Belfast, so I'll get chatting to you outside. But is there any way just to make things a bit more simpler, or am I just making it too difficult for myself? Or is there any advice you would give to people who are trying to sort of do this from their own front room?
So, are you working with Magnite at the minute?
No, I've actually initiated a relationship with a company in Tel Aviv. And they've given me code that Google Ad Manager. They want me to write that into my code, and I was trying to just copy and paste it, and it's just breaking every time I do it. So yeah, it's just another hurdle that sort of.
Well, if you were with Magnite, I would recommend reaching out to either developer relations departments or some sort of client relations department. I should have made it clear that we're an engineering site in Belfast, so we're not doing ad sales or anything like that, or managing clients. But give us a shout outside, and we can always talk to you and see if we can get you in touch with people.
That's time.
Lunch. Yes. Thank you.
Mo, thank you so much. If you come back for 1 o'clock, so after lunch, we're going to have Neil McCallan, who's going to be discussing building VR in the browser. So that's at 1 o'clock. See you then.
Hi, I'm Brian Craig. I work at Liberty IT. I lead the architecture team, which means I make sure all the engineering is focused in the right direction and our different job families are all going towards the continuous improvement. So Liberty IT, we have about 650 people based out of both Belfast and Dublin. We produce software and world-class engineering for our parent company, Liberty Mutual, which is an insurance company based out of the US. We do so many different things from them, from straight software engineering to data scientists to product ownership to product management to a level of consultancy. So that's that we deliver, and they're a Fortune 500 company. So NIDC, the big thing about it is it's community driven. It's talks by practitioners, by developers, all levels. It's inclusive, there's support if you need childcare. Again, it's just fantastic, the level of interest we get from people attending, but also the different variety of talks you get. And it's people who have like 1 or 2 years experience to people like myself who have 20 to 30 years experience. There's just such variety. It is really, really energetic is the other thing, really energetic. This year at NIDC, I'll be talking about how the marriage of architecture and engineering comes together to deliver business value, and how do we do that in a continuous way. Liberty in Belfast, we currently have our graduate and intern recruitment open, and it is open until the end of the month, so please go ahead and apply. We'd love to see you here.
So my name's Eamon Boyle. I'm the development manager at GearSet's Belfast office. We've only just opened the office here in Belfast in April. GearSet is the DevOps solution provider for Salesforce. Salesforce is the world's largest CRM, and we basically help thousands of customers across the globe deliver solutions on Salesforce with better security, better speed, ease of use. Some of our customers include big names like IBM, Amazon, TripAdvisor, some folks like this. So the quality of the speakers at NIDC is always really good. I'm really excited with this year's. The lineup looks absolutely amazing. It'll be nice just to be in the room with people physically because we haven't been able to do that for the last number of years. So I'm looking forward to seeing both like the attendees and the speakers. I'm doing a talk at it. I'm really looking forward to that because I haven't talked in Belfast in a while. So that's covering how GearSet has moved from JavaScript to TypeScript. So I'm really looking forward to that. And then we're also running a wee puzzle on the stand. People can come along, have a go at it, and then we're going to raffle off a prize. So I'm really looking forward to seeing what people sort of make of that. Should be a bit of fun and some to talk around at the booth. One of the things we're really looking forward to is just meeting the engineers, the attendees at the event. We have more work than we can do, so we're like eager for people to join the team. And as a company, we've got a startup environment, we've got a startup attitude, but we've also got the stability and the ambition of a scale up. So if anybody at the event is looking to join that sort of team, we'd really love to hear from you.
So I'm Russell Beggs. I'm the VP of Engineering for ESO. I look after all our engineering teams at ESO, and our company is very much focused on making a difference. Our mission is to improve the health and safety of our communities using the power of data. And what that really means is that we write a lot of software that paramedics, firefighters, and hospital staff use to track what's going on and to help create the data, track the data, and provide actionable insights to improve the quality of healthcare that's provided to people. So I'm super excited about NIDC. Early in my career, I moved out to Australia, and I got to see what an engineering community looked like out there. And when I came back, we didn't really have much of one. It was a bit of a fledgling. And it's been fantastic to see NIDC grow and grow year on year. Even with the pandemic, we still saw a lot of participation, albeit remote. So I'm really excited to see us all get back together in person, to see more of the talks, the technical talks that people are giving, to see so many different things that are happening, and to hear from management and leadership and the psychology of delivery as well. So super, super pumped to be back in person after such a long time being apart. We've got a lot going on in the fire space, but one that's particularly close to my heart here in Belfast is around patient registry. So you have stroke registries, trauma registries that really specialise in the care that they provide to patients. So if I give one example, a few years ago we recognised that there was a disparity between what paramedics were finding in the field and the hospitals were finding when it came to strokes. And there was about 50% chance that a paramedic would find that you had a stroke. And when we looked at the data and the correlation of the trends, we found two key things: ground level falls and diabetics. And when you look at that information, you publish insights on it, what we've seen in the last couple of years is that the detection rates have gone right up, and that's literally tens of thousands of lives that have been improved by that. So we've already done that. I'm really excited about how much more we'll be able to do now that we move further into that registry space.
My name's Chris Kitson. I work for Corrick Group here in Belfast. So Corrick, I've been going for about 3 years now. We're headquartered in New York City. We have an engineering hub here in Belfast. Our first engineering hire was in Belfast. And we also have offices in Buffalo and in New York as well. So we're sitting around just over 100 people globally. So yeah, we're proud to support NIDCC as well as a company. Personally, I've spoke at it a few years ago. We thoroughly enjoy it, and it's just very proud for Corrick to be able to support the Northern Ireland development community in this way. So Corrick is a business. We specialise in digital transformation with a particular emphasis on cloud, particularly Google Cloud. So one of our founding executives was ex-Google. We've got lots of ex-Google employees in the US as well. So we have our engineering hub here in Belfast. So we've got many different disciplines, including data science, cloud, UI, UX, and many others as well. So I can't explicitly mention our clients, but rest assured you will have used a product or a service that Corrick's worked on.
So my name's Darren Abel, so I'm the Director of Engineering at Apex FinTech Solutions. So I joined the company 2.5 years ago. My role is really to supervise all the technology projects that we do in Belfast. Apex FinTech Solutions was formed in 2012 by Peak 6. So Peak 6 is an investment company, and Apex is essentially the technology company that is behind the trading solutions that we build for our customers. So the whole mission of Apex is really to democratize trading. They're one of the big disruptors in the industry. So it's because of Apex that people now can actually trade through their mobile phones. A lot of the work that we do, we can't disclose. It's under the radar, so to speak. We are really looking forward to, we have one of our other companies is speaking on it as well, Evil Geniuses. So we're looking forward to hearing what they've got to say, and as well as one of our own managers, Niall Haslam, he's also speaking to the conference. So we're really excited about those and to see what else other people are doing in Belfast. Like I say, the tech community in Belfast is huge, and we can't wait for the conference. Yeah, so obviously we were given the opportunity to sponsor NIDC, we jumped at it. So NIDC is obviously conference for developers, by developers. So one of the big things for us in Belfast is really getting our brand out there. We were previously known as Peak 6, and now we're known as Apex, so we're a subsidiary of Peak 6. So it's making sure that we get that out to our target audience, who are developers, because we're a technology company. And really then, obviously, during COVID, for instance, everybody's been at home, so we recognize how important it is to have events like this where we get everybody together. So that's why we kind of jumped at the chance and the opportunity then to sponsor NIDC, and we're really looking forward to the conference. So over the past 2.5 years, we've grown to 98 people. We're continuing to grow and continuing to hire in technology and operations. So if you're interested in joining us, please get in touch or speak to Clark and Robin in our stand.
Hi, I'm Brian Craig. I work at Liberty IT. I lead the architecture team, which means I make sure all the engineering is focused in the right direction and our different job families are all going towards the continuous improvement. So Liberty IT, we have about 650 people based out of both Belfast and Dublin. We produce software and world-class engineering for our parent company, Liberty Mutual, which is an insurance company based out of the US. We do so many different things from them, from straight software engineering to data scientists to product ownership to product management to a level of consultancy. So that's that we deliver, and they're a Fortune 500 company. So NIDC, the big thing about it is it's community driven. It's talks by practitioners, by developers, all levels. It's inclusive, there's support if you need childcare. Again, it's just fantastic, the level of interest we get from people attending, but also the different variety of talks you get. And it's people who have like 1 or 2 years experience to people like myself who have 20 to 30 years experience. There's just such variety. It is really, really energetic is the other thing, really energetic. This year at NIDC, I'll be talking about how the marriage of architecture and engineering comes together to deliver business value, and how do we do that in a continuous way. Liberty in Belfast, we currently have our graduate and intern recruitment open, and it is open until the end of the month, so please go ahead and apply. We'd love to see you here.
So my name is Eamon Boyle. I'm the development manager at GearSet's Belfast office. We've only just opened the office here in Belfast in April. GearSet is the DevOps solution provider for Salesforce. Salesforce is the world's largest CRM, and we basically help thousands of customers across the globe deliver solutions on Salesforce with better security, better speed, ease of use. Some of our customers include big names like IBM, Amazon, TripAdvisor, some folks like this. So the quality of the speakers at NIDC is always really good. I'm really excited with this year's. The lineup looks absolutely amazing. It'll be nice just to be in the room with people physically because we haven't been able to do that for the last number of years. So I'm looking forward to seeing both like the attendees and the speakers. I'm doing a talk at it. I'm really looking forward to that because I haven't talked in Belfast in a while. So that's covering how GearSet has moved from JavaScript to TypeScript. So I'm really looking forward to that. And then we're also running a wee puzzle on the stand. People can come along, have a go at it, and then we're going to raffle off a prize. So I'm really looking forward to seeing what people sort of make of that. Should be a bit of fun and some to talk around at the booth. One of the things we're really looking forward to is just meeting the engineers, the attendees at the event. We have more work than we can do, so we're like eager for people to join the team. And as a company, we've got a startup environment, we've got a startup attitude, but we've also got the stability and the ambition of a scale up. So if anybody at the event is looking to join that sort of team, we'd really love to hear from you.
And to help create the data, track the data, and provide actionable insights to improve the quality of healthcare that's provided to people. So I'm super, super excited about NIDC. Early in my from management and leadership and the psychology of delivery as well. So super, super pumped to be back in person after such a long time being apart. we've got a lot going on in the fire space, but one that's particularly close to my heart here in Belfast is around patient registry. So you have stroke registries, trauma registries that really specialise in the care that they provide to patients. So if I give one example, a few years ago we recognised that there was a disparity between what paramedics were finding in the field and the hospitals were finding when it came to strokes. And there was about 50% chance that a paramedic would find that you had a stroke. And when we looked at the data and the correlation, the trends, we found two key things: ground level falls and diabetics. And when you look at that information, you publish insights on it, what we've seen in the last couple of years is that the detection rates have gone right up, and that's literally tens of thousands of lives that have been improved by that. So we've already done that. I'm really excited about how much more we'll be able to do now that we move further into that registry space.
My name's Chris Kitson. I work for Coric Group here in Belfast. So Coric, I've been going for about 3 years now. We're headquartered in New York City. We have an engineering hub here in Belfast. Our first engineering hire was in Belfast. And we also have offices in Buffalo and in New York as well. So we're sitting around just over 100 people globally. So yeah, we're proud to support NIDCC as well as a company. Personally, I've spoke at it a few years ago. We thoroughly enjoy it, and it's just very proud for Coric to be able to support the Northern Ireland development community in this way. So Coric is a business. We specialise in digital transformation with particular emphasis on cloud, particularly Google Cloud. So one of our founding executives was ex-Google. We've got lots of ex-Google employees in the US as well. So we have our engineering hub here in Belfast. So we've got many different disciplines, including data science, cloud, UI, UX, and many others as well. So I can't explicitly mention our clients, but rest assured you will have used a product or a service that Coric's worked on.
So my name's Darren Abel, so I'm the Director of Engineering at Apex FinTech Solutions. So I joined the company 2.5 years ago. My role is really to supervise all the technology projects that we do in Belfast. Apex FinTech Solutions was formed in 2012 by Peak 6. So Peak 6 is an investment company, and Apex is essentially the technology company that is behind the trading solutions that we build for our customers. So the whole mission of Apex is really to democratize trading. They're one of the big disruptors in the industry. So it's because of Apex that people now can actually trade through their mobile phones. A lot of the work that we do, we can't disclose. It's under the radar, so to speak. We are really looking forward to, we have one of our other companies is speaking on it as well, Evil Geniuses. So we're looking forward to hearing what they've got to say, and as well as one of our own managers, Niall Haslam, he's also speaking at the conference. So we're really excited about those and to see what else other people are doing in Belfast. But like I say, the tech community in Belfast is huge, and we can't wait for the conference. Yeah, so obviously we were given the opportunity to sponsor NIDC, we jumped at it. So NIDC is obviously conference for developers, by developers. So one of the big things for us in Belfast is really getting our brand out there. We were previously known as Peak 6, and now we're known as Apex, so we're a subsidiary of Peak 6. So it's making sure that we get that out to our target audience, who are developers, because we're a technology company. And really then, obviously, during COVID, for instance, everybody's been at home, so we recognize how important it is to have events like this where we get everybody together. So that's why we kind of jumped at the chance and the opportunity then to sponsor NIDC, and we're really looking forward to the conference. So over the past 2.5 years, we've grown to 98 people. We're continuing to grow and continuing to hire in technology and operations. So if you're interested in joining us, please get in touch or speak to Clark and Robin in our stand.
Hi, I'm Brian Craig. I work at Liberty IT. I lead the architecture team, which means I make sure all the engineering is focused in the right direction and our different job families are all going towards the continuous improvement. So Liberty IT, we have about 650 people based out of both Belfast and Dublin. We produce software and world-class engineering for our parent company, Liberty Mutual, which is an insurance company based out of the US. We do so many different things from them, from straight software engineering to data scientists to product ownership to product management to a level of consultancy. So that's that we deliver, and they're a Fortune 500 company. So NIDC, the big thing about it is it's community driven. It's talks by practitioners, by developers, all levels. It's inclusive, there's support if you need childcare. Again, it's just fantastic, the level of interest we get from people attending, but also the different variety of talks you get. And it's people who have like 1 or 2 years experience to people like myself who have 20 to 30 years experience. There's just such variety. It is really, really energetic is the other thing, really energetic. This year at NIDC, I'll be talking about how the marriage of architecture and engineering comes together to deliver business value, and how do we do that in a continuous way. Liberty in Belfast, we currently have our graduate and intern recruitment open, and it is open until the end of the month, so please go ahead and apply. We'd love to see you here.
So my name is Eamon Boyle. I'm the development manager at GearSet's Belfast office. We've only just opened the office here in Belfast in April. GearSet is the DevOps solution provider for Salesforce. Salesforce is the world's largest CRM, and we basically help thousands of customers across the globe deliver solutions on Salesforce with better security, better speed, ease of use. Some of our customers include big names like IBM, Amazon, TripAdvisor, some folks like this. So the quality of the speakers at NIDC is always really good. I'm really excited with this year's. The lineup looks absolutely amazing. It'll be nice just to be in the room with people physically because we haven't been able to do that for the last number of years. So I'm looking forward to seeing both like the attendees and the speakers. I'm doing a talk at it. I'm really looking forward to that because I haven't talked in Belfast in a while. So that's covering how GearSet has moved from JavaScript to TypeScript. So I'm really looking forward to that. And then we're also running a wee puzzle on the stand. People can come along, have a go at it, and then we're going to raffle off a prize. So I'm really looking forward to seeing what people sort of make of that. Should be a bit of fun and some to talk around at the booth. One of the things we're really looking forward to is just meeting the engineers, the attendees at the event. We have more work than we can do, so we're like eager for people to join the team. And as a company, we've got a startup environment, we've got a startup attitude, but we've also got the stability and the ambition of a scale-up. So if anybody at the event is looking to join that sort of team, we'd really love to hear from you.
So I'm Russell Beggs. I'm the VP of Engineering for ESO. I look after all our engineering teams at ESO, and our company is very much focused on making a difference. Our mission is to improve the health and safety of our communities using the power of data. And what that really means is that we write a lot of software that paramedics, firefighters, and hospital staff use to track what's going on and to help create the data, track the data, and provide actionable insights to improve the quality of healthcare that's provided to people. So I'm super, super excited about NIDC. Early in my career, I moved out to Australia, and I got to see what an engineering community looked like out there. And when I came back, we didn't really have much of one. It was a bit of a fledgling. And it's been fantastic to see NIDC grow and grow year on year. Even with the pandemic, we still saw a lot of participation, albeit remote. So I'm really, really excited to see us all get back together in person, to see more of the talks, the technical talks that people are giving, to see so many different things that are happening, and to hear from management and leadership and the psychology of delivery as well. So super, super pumped to be back in person after such a long time being apart. we've got a lot going on in the fire space, but one that's particularly close to my heart here in Belfast is around patient registry. So you have stroke registries, trauma registries that really specialise in the care that they provide to patients. So if I give one example, a few years ago we recognised that there was a disparity between what paramedics were finding in the field and the hospitals were finding when it came to strokes. And there was about 50% chance that a paramedic would find that you had a stroke. And when we looked at the data and the correlation of the trends, we found two key things: ground level falls and diabetics. And when you look at that information, you publish insights on it, what we've seen in the last couple of years is that the detection rates have gone right up, and that's literally tens of thousands of lives that have been improved by that. So we've already done that. I'm really excited about how much more we'll be able to do now that we move further into that registry space.
My name's Chris Kitson. I work for Corrick Group here in Belfast. So Corrick, I've been going for about 3 years now. We're headquartered in New York City. We have an engineering hub here in Belfast. Our first engineering hire was in Belfast. And we also have offices in Buffalo and in New York as well. So we're sitting around just over 100 people globally. So yeah, we're proud to support NIDCC as well as a company. Personally, I've spoke at it a few years ago. We thoroughly enjoy it, and it's just very proud for Corrick to be able to support the Northern Ireland development community in this way. So Corrick is a business. We specialise in digital transformation with a particular emphasis on cloud, particularly Google Cloud. So one of our founding executives was ex-Google. We've got lots of ex-Google employees in the US as well. So we have our engineering hub here in Belfast. So we've got many different disciplines, including data science, cloud, UI, UX, and many others as well. So I can't explicitly mention our clients, but rest assured you will have used a product or a service that Corrick's worked on.
Hello everybody, we're all fed and watered and ready for the second half of NIDCon. My name's Gemma Simpson, I'm the MC for this room, and I'm delighted to introduce Neil McCallan, who is a development manager at Lightspeed. And Neil's talk today is all about building VR in the browser. Now, after the chat, if there is time for questions, if you want to raise your hand and look out for Glenn in the pink t-shirt, and he'll bring a mic over to yourself to speak into, just because we're live recording and want the folks at home to hear your question. So if we can just bring on Neil for your chat.
Hello folks. Hope you're enjoying the conference so far. This is a huge room, so thanks very much for everyone who attended. My name is Neil. I'm going to talk about VR today in the browser. Just some content warnings for the slides here. There's going to be some first-person motion, because it's VR, obviously, and some pixelated blood and skulls, most of which are on the next slide, so hopefully not too bad. In the late 80s and early 90s, there was a kids' game show called Nightmare. A player was blindfolded and put through a dungeon of traps and monsters and puzzles. It was part serious adventure, part camp, and fairly terrifying, particularly the various ways in which the dungeoneer could meet a sticky end. You know, they're being blown up or falling from a great height or getting cut in half with, you know, circular saws. Kids TV in the 80s was pretty hardcore. I was really, really hooked on this show, like borderline obsessed, because there was nothing else like it, right? I mean, video games at the time release abstracted 8-bit concerns, but this was a whole other world you could, you know, be immersed in, seemingly. Even though I knew deep down it was like a blue screen illusion, the urge to inhabit that world was so strong. I didn't just want to be a player, I wanted to be in the world. I wanted to be able to see through the helmet. I wanted to be able to reach out and touch the illusion, but alas, the TV screen always stayed my hand. Around the same time, at the late 80s, early 90s, virtual reality was having its first big moment in the spotlight, I guess. There were lots of news articles and hype pieces about how VR was going to transform our entertainment lives and our work lives. There was arcades sprouting up with custom hardware, bulky headsets, and, you know, immersive, albeit very crude, polygonal graphics. The concept was there, the interest was strong, but it wasn't quite VR's time back then. The technology just wasn't ready for the mainstream, or vice versa, and so the hype subsided, and it was left to fiction like movies and novels to envision what a virtual reality future might like, with results ranging from the sublime to the faintly ridiculous. Fast forward to now, 2022, and things have come a long way. VR has, I guess, achieved something like mainstream saturation, certainly in the gaming space. The technology has improved in terms of hardware and visuals, and several companies are now kind of staking their future on the success of VR, particularly when it pertains to fairly nebulous corporate concepts like the metaverse. Whatever you might think about that stuff, it's undeniable that the impact that VR's had on gaming and the arts and research has been considerable. There's obviously a lot of ways to create for VR as well. There's creation engines now like Unity and Unreal that provide a lot of power. Me though, I'm a web dev at heart. I believe the browser can be a fairly unique, creative and democratic tool for being, you know, a creative person. The browsers are starting to adopt standards that will allow us to interface with immersive gear and VR in the browser with existing web technologies. So even though it's early days, there's a lot you can do, so I'd like to take some time today to take a look at what open web standards can do in the realm of VR and build a few things along the way. So I'm Neil, I'm a dev manager at Lightspeed, and this is building for VR in the browser. Can I just get a quick show of hands who here has used a virtual reality device of some kind? Okay, so a good number of you. And keep your hands up if you are building for VR currently in any way. Okay, so a few of you. So broad understanding of what VR is in this room, so I'll just, you know, skim this slide. VR is essentially an immersive technology that will replace or replicate your environment in some way fully. It is sensory, so it can give you obviously visual feedback, positional audio, vibration from your controllers, that kind of thing. It reacts to your movements, so when you move or turn your head in a virtual reality environment, you look around as if you were in your real world. And currently, at least, until technology advances quite a way, it does require some kind of specialist hardware, like a head-mounted display with some touch controllers, that kind of thing. So, like I said, there's creation engines for this stuff, Unreal, Unity, many other stuff. Why would we do this in the browser? I'll come back to this slide at the end of the talk, but the general gist of this is that doing VR in the browser is a way to very quickly get moving and building scenes with minimal code, minimal kind of setup, and you're leveraging all of the great strengths of the web in terms of distribution and cross-device accessibility, that kind of thing. Also, it's very fun. Hopefully that'll come across in this talk, but that's kind of the thesis for why I'm talking here today. Normally when I am talking or teaching, I like to give like a 10 lines or less example of the technology I'm describing. It's this basic minimal example. Here's all you need to do to get something working. Unfortunately, when it comes to VR in the browser, that's a tall order because there's several different technologies at play here. The two main ones are WebXR, which is a set of open standards being developed to read positional controllers, to set up immersive sessions inside headsets, that kind of thing, and WebGL, which is the 3D tech which is rendering the scene that you're immersed in. Writing WebGL code in itself can be painful, I guess, for want of a better term, so we tend to use libraries like 3JS to abstract that away into a more usable framework. If I was to write code for this to use all three of these, it would be huge. So instead today, for all of the examples, I'm going to use a framework called A-Frame, which is a framework that encapsulates all these technologies and provides a HTML-based declarative language for describing VR scenes and JavaScript APIs to be able to actually create your own components, that kind of thing. So with that said, here is a 10 lines or less A-Frame example. So this is just all HTML, essentially. A-Frame is included through a script tag, and then you describe a scene tag, and then it encapsulates all of the things inside your scene. So in this example, we've got a floor, as a plane, a box, a sphere, and a light. They haven't been given any special material properties, so they all appear as white. And so with these few lines, you get this very strange, abstract, matrix construct looking kind of scene. But if you were to copy this exact code, paste it into a browser, and load it in a VR headset, you would be inside the scene. As you can see in the example, I'm using Firefox in an Oculus Rift. You click the VR button and you're there. You can look around, you're fully immersed. Also, this stuff degrades really nicely, or at least has good fallbacks. If you visit this on a desktop browser, you can use mouse controls to look around. If you use it on the mobile, you automatically get gyro positioning to be able to look around. I even tried it on Edge on my Xbox One, and sure enough, the analog stick was able to look around in the environment very well. So even if you don't have VR hardware, you can still use this stuff to create 3D scenes in the browser very efficiently. And so that's an immersive 3D scene, albeit very basic in less than 10 lines of HTML, which I think is pretty powerful stuff. So A-Frame uses a architecture which will be quite familiar to game devs or anyone who's used any of the aforementioned engines called Entity Component System. Entities are essentially unique elements that do nothing by themselves. They're basically containers for components, and it's the components that define the behavior of the entity itself. So in A-Frame, an entity is just an A entity tag, which can be nested together. So the child entities inherit the parent's position, rotation, that kind of thing, and then you offset them relative to that. And then we use a number of components that A-Frame provides, or third-party components, or ones we made ourselves, to be able to define that behavior. And that's everything from what it looks like in terms of geometry and materials, where it's positioned in the scene, scaling, does it have lights attached to it, is it animated, all that kind of stuff. So again, if you've used Unity or something like this, entities and components, you're probably familiar with the paradigm. Systems are more global things that sit on top of the scene, like physics or how the shadows are rendered, that kind of thing. But entities and components are the basis of how A-Frame works, and all the code you see today will use that kind of stuff. So the most basic, I guess, required entity or the required thing for A-Frame is the scene. The scene is basically the wrapper for everything that goes into your A-Frame scene, and you can configure some properties like the background color of the canvas, whether there's fog in the scene and how that behaves, the color, that kind of thing. Positioning in A-Frame and in WebXR is done in meters. So if you set an entity at position 010, that's X, Y, Z, so it's 1 meter up on the Y-axis. Same with dimensions. If you specify a 1 unit square cube, that cube will look 1 meter square when you enter the immersive VR. Rotation is given in degrees as well, and you can rotate along any of the 3 axes. And this footage that has been captured here shows what those axes are like and the effective rotation in the positive and negative space on those axes. All the footage today, by the way, was captured in an extremely beaten up Oculus Rift S that's connected to Firefox through the Oculus browser. So I mentioned entities as being kind of the crux of A-Frame. And it's true that you could build your entire scene by just defining entities and then adding the relative components to it to define geometry, position, that kind of thing. But for convenience, A-Frame does provide what they call primitives out of the box, which is essentially prefabs in other engines. Instead of writing an entity and giving it a geometry component with box-type properties. You can use an A-box tab, which has some of those components pre-configured under the hood, so it just gets you moving faster. It also makes your code more readable. I'm using primitives where I can today for legibility's sake, but it's the same thing. The two code snippets there, the entity and the box, display exactly the same. It just shows how the entities are abstracted away by the primitives a bit. And primitives are available for most of what the engine offers out of the box. Most standard geometry types like planes for 2D flat surfaces, boxes, spheres, cylinders, lights, all that kind of stuff. So if you've got geometry, as you said, or as you saw in the first example, if we don't define any properties, the materials just come out flat white. A-frame does expose a material component, which will let us define a number of different properties about how the material actually looks and behaves in accordance with light. And it can be everything from adding custom shaders to it, to changing its color. You can specify roughness and metalness, which kind of determines how light reflects off the object, for want of a better explanation. Make it transparent, and many other options. You can also apply texture maps. So the bottom three, the right three on the bottom row are source is just a flat picture of a texture that you can apply to a piece of geometry. In this case, it's like a bit of stone brick. And you can also define different maps. A normal map is a special type of RGB texture that determines how light will kind of interact with the surface of the object when it's rendered. And if you combine the source and normal map together, it's quite subtle on the slides, but you can still see kind of like the brickwork seems to have more depth and more kind of reflectiveness to it than you would get through geometry alone. So there are other maps you can provide as well, displacement maps, ambient occlusion, other stuff that will be familiar to people who have done 3D or game dev, but it can all be provided just by using the material component on any other piece of geometry. Obviously, we need to be able to see what's going on in our scene, so light plays a huge part in any immersive 3D scene. A-frame exposes a light component as well as a light primitive and offers various types of lights you can use. Some of them are global. You can do ambient, hemispherical, or directional, which light the entire scene equally. And you can also provide point and spotlights with angles and distances to light certain parts of the scene. A-frame does support shadow casting. You just need to enable the shadow system on the scene, and then for your geometry and your light, say whether you want it to cast shadows or receive them. Now, it looks great, as you can see. It looks pretty cool. But in WebXR and in VR in general, these things are all performance trade-offs, particularly on the likes of mobile. Real-time shadows, where you're forcing the lights to recalculate every frame, can take quite a bit of a performance hit. So if you can find ways to smoke and mirrors it or use it very judiciously, you should. But the option is there if you want it. And like I said, I think it looks pretty cool. So we've got primitive geometry and we've got different types of material. You can go really far with that, but eventually you might want something more detailed and you'll want to import a model from a 3D package like Blender or Maya or something else. A-frame can support the importing of different models, notably GLTF, which is GL transmission format, and that is just like a sort of web-friendly model format, if you like. You just need to import that as an asset into A-frame's asset system using just a asset item tag pointed at the file, and then if you use a GLTF model on an entity, it will load that model and apply it to the scene. And I've just got examples here. Relatively low poly, but still quite good looking, of a skull and a fairly oversized looking apple. Again, models tend to increase the triangle count, the polygon count, and so again, it's a performance trade-off, but used sparingly alongside the standard geometry, you can get really impressive results. So, in case you're wondering how or why all these things are spinning, A-frame does expose an animation component. A-frame's built on top of, I think it's Anime.js, which is a fairly well-known JavaScript animation framework. The animation component exposes a lot of its properties for doing tween animations from one value to another. If you've done CSS animations or use something like GreenSock, you're probably familiar with the syntax. You define the property you want to transition, its beginning and end values, how long the animation should take, and other things like easing and looping, that kind of thing. You can also specify multiple animations on the same entity by using that kind of double underscore notation. And so the box has 3 separate animation components, each doing a different transition. The syntax in the box one's quite interesting. A-frame recommends that you don't animate an entire component's value over time because it's doing a lot of updates under the hood and can lead to some performance drain. Instead, it provides some hooks where you can directly address through a property called Object3D. That's actually reaching in and addressing the 3JS object that the entity encapsulates. And so instead of animating the entity's component values, you're actually directly editing and animating the 3D object's position or rotation, that kind of thing. Makes it much more performant, and you can do it quite easily in just this animation component. Obviously, as you're building your scene, you're maybe having a lot of objects that have the same kind of properties, same geography, same geometry, same materials, same animations, you end up with a lot of typing. There are a couple of ways to reduce your typing. A-Frame has a fairly robust mix-in system. You just define a mix-in with a unique ID, and you can apply any combination of components and properties to that mix-in. It doesn't render anything by itself, but you can then apply those mix-ins to geometries and do multiple inheritance, that kind of thing. So we've got here 2 mix-ins, one for the blue material, one for the spinning animation, and we're applying them in different combinations to the 3 pieces of the 3 primitives underneath. And you can see that we can override the mix-in properties as well. So on the rightmost box, we're taking the spin animation, but we're overriding its duration to make it slower. So pretty powerful to build up like a set of mix-ins that define your common look and feel, and then applying them to your geometry to save yourself on typing. Eventually, though, you'll want to start building your own custom primitives or start to get beyond the norm. A-Frame, this is kind of where the power of A-Frame lies. You can register custom components and primitives and use them in your scene, or use ones that have been shared by the community. This is a very simple example. We use JavaScript to register a component. I've called one marker. And the goal is to render essentially this kind of sphere and cone map marker looking thing with just like one line. So the init function, when the marker is attached to the entity, will very simply set its internal HTML. And again, because entities can be nested, the sphere and the cone take on the relative position of the parent entity. And we pass in a color parameter into those objects. So whenever you pass a color into marker, the internal geometry gets colored that way as well. And so you just need to use the marker component on the entity then, pass in the color as a property, and you can get this kind of thing working. To abstract it even further then, once you've created the custom component, you can make your own primitive that consumes it by default. So this is very much the same way as A-Frame registers its own internal primitives. You give it a tag name, say what components and properties it has by default, and map the primitives attributes to the internal component's values. So instead of doing marker as a component, we can actually do an A-marker tag and just give it a color, and that renders. There are other lifecycle functions you can hook into here, like you can get access to when the component's properties are updated, so you can make sure if we change color on marker after it's rendered, the cone and sphere adopt that color. You have access to like a tick function, which will let you do time-based animations, or every frame gets called essentially. So very, very powerful. Most of A-Frame's power comes from being able to define this stuff, and there are entire tool sets and third-party libraries that use custom components to give you much more power than the framework comes out of the box. So we've been standing around, right? Currently we've kind of been rooted to the spot. And you can do room scale, like physically walk around the environment to move in VR. But if you're limited for space or just want to have a bigger world, you need to have a movement system. I've actually used, A-Frame provides a couple of built-in components for things like keyboard controls or touch controls on Oculus or gamepad controls. But there's an extras package which has a component called movement controls, which encapsulates it all in one. So I've used that here. Lower the speed, because by default it's quite fast, and then you wrap the camera in an entity with movement controls on it, so you can move the camera successfully while still getting the positional information from your VR headset. So I'm just walking around the scene here. Just as a kind of aside on best practice, moving the camera can be not always great in VR, particularly if you're new to VR as a user, if you haven't got your VR legs yet. If the camera moves and your body's not moving with it, strange things can happen. People lose their balance, fall over, throw up. It can be pretty messy. So generally, new VR people will want to use like a teleport control instead. There are third-party components that allow you to essentially use the cursor to point where you want to go and blink layer instead of moving layer directly. But it's not included in A-Frame yet, and I hope at some point they'll get to include that. But so that's an example of how you can move around the scene. So what have we got so far? We've got geometry, materials, we've got animations, we've got lights, we've got mix-ins, that kind of thing. My partner, Nina, is an artist. She's been selling and exhibiting her work recently. And so as an example scene, I figure that an art gallery would be quite a good way to demonstrate how this works. Yeah, that looks okay. So this is all built with primitives. There's no custom models in here. It's just planes, boxes, and a few of the other primitives that are there. It's got some materials. The floor is a tile texture with a very small normal map so that the light doesn't play off the middle parts of the tiles, gives it a bit of depth. The fireplace is actually just a video loop. You can apply looping videos as textures, not just image sources. There's text components to give the details. The walls have a slight kind of normal map and texture to give them a bit of interest. The hanging lights are just cylinders with their emissive properties set up really high so that they are always kind of glowing bright. And those strange kind of D12 looking sculpture things are just, they've got a high shininess on them. So it's a very simple scene. It's maybe 30 lines of HTML. No custom components and just positional and lighting and rotation information, but it looks like a fairly decent scene, I think. You could use this on an art gallery website, for example, and this is probably a good practical example of how to use this tech if you are doing product demos for e-commerce or car showrooms, art galleries, walkthroughs for things like real estate, event spaces, that kind of thing. This is a pretty good practical example of the tech, so I think that looks pretty cool overall. And again, running in the browser in Firefox, pretty crazy. Just click a VR button, stick it on your headset, and you're there. No photos, but videos seem okay. So being in there and looking around is one thing, right, and moving around, but we do want to be able to influence the world in some way. There are many ways to do that, but probably one of the easiest, both from a user point of view and also from a developer point of view, is using essentially a 3D cursor and being able to respond to click events. So if we've done web programming before, we know that DOM elements in the browser can raise events when they're clicked on or when they're moused over, that kind of thing. A-Frame gives you an event system which behaves very similarly inside a VR environment. So we have a laser controls component that can be attached to one of the touch hands, and it essentially casts array out, and you can define which objects in the scene it's going to listen to. And then when you pull the trigger of one of these, you can intercept a click event and respond to it in some way. Very simple example here is when you click on one of the boxes, it reads the material color of that box and sets the sphere's material color to the same thing. So very simple, but already a way to start to interact. And you can define how this all looks and functions and make it look way more engaging. But that's a nice, simple, fairly effective way. It also degrades nicely. If you were using a mobile for this scene, you could have a cursor in the middle of the screen, and if you focus on something for a couple of seconds, that counts as a click. So it's gaze-based controls. So again, another power of A-Frame and of WebXR in general is the ability to provide fallback options. There's way too much detail to go into here, so it's just an aside that A-Frame doesn't ship with a physics system, but there is kind of an unofficial, official third-party component that implements physics. I think it uses Canon and Ammo under the hood, which are physics systems. You just need to set this up by defining some properties on the physics system, on a scene. In this case, I've reduced the gravity, and then it exposes two main components: static body, which can be collided with but doesn't actually provide any reaction to the collision, kind of to set up static geometry, and then dynamic body, which is subject to forces like gravity, friction, mass, acceleration, that kind of thing. In this scene, I've just suspended a bunch of dynamic bodies in the air, started the scene, and gravity takes over. They fall and bounce and respond in meaningful ways. Physics in VR can be extremely compelling, as you can imagine, particularly if you're using your hands or other movement controllers to manipulate them. But again, the topic is way too advanced for this talk, so I'll just have to say it's there, play around with it, and see what you can do. So I mentioned at the top of the talk how Nightmare was a formative experience on me and how I longed to be immersed in that world as a kid. It would probably be a disservice to my younger self if I didn't at least try to replicate some of this stuff in VR using this technology. So here's the corridor of Blades in the original show. Panic kids who can't tell their left from right getting bisected by rotary saws, standard stuff. So I have tried my best to replicate something similar to this in A-Frame and try to recapture some of my use. So the geometry here is just planes for the walls and floors and a half cylinder for the ceiling. The textures are just custom ones I've kind of sourced and made to make it look more like it. Nothing's actually moving here apart from the blades. The geometry's static. I've wrote a custom component that animated the texture offset over time on the walls and the ceiling. Because the textures wrap around, it gives the appearance of movement, just this infinite conveyor going into the void. The blades are also interesting. They are geometry, but I did not model them myself. 3JS has an SVG extruder function where you can provide an SVG image and get some geometry from it. So I found a custom component that lets A-Frame use that, and I was able to provide then just a black and white SVG image of a chainsaw, a rotary blade, extrude it and give it the right kind of shiny material, and it makes it fairly convincing, at least compared to Nightmare kind of rotary blade. Collision was interesting. I originally tried to play with the physics engine to get like a proper collision between saws and the camera. It didn't work. Long story short, dynamic bodies can't be animated because they have to be responding to physics and gravity and stuff like that. And the static bodies can't detect collisions. And obviously I needed the animation for the animation of the blades moving down the scene and also spinning. After much ado, I just ended up writing a very simple custom component that uses basic trig to get the distance from the center of the blade to the camera. And if it's within a certain radius and the blade is lower than or equal to the camera's height, you've been hit. So it's not a perfect illusion, but it's good enough for these purposes. I've called this cardio blades because playing this long term can be quite taxing. There's no movement controls here. Physically throwing myself around the room to avoid these blades. There is footage of me somewhere of like playing this, as in the camera's pointing at me, but it's not going to be shown. If someone like Meta or someone could solve looking like an idiot in VR, they'd make billions of dollars, but I don't think they're there yet. So again, maybe about 40 lines of HTML using A-frame. I've been able to replicate my childhood fantasy / trauma through VR in the browser. And again, run in a Firefox, stick on your headset, and you're there. So I think that's pretty cool. I have only just scratched the surface of what we can do with A-frame and WebXR today. There are so much more functionality that we haven't been able to get to. Check out their docs, check out their community hubs. There are other frameworks in JavaScript and HTML that will let you do this kind of stuff, but I find A-frame is very quick to get started, and it exposes a lot of power. There's immersiveweb.dev as well, which is kind of a hub for this kind of technology and how the standards will grow. And my code pen is NGM code. Eventually, when I clean up this code a bit, I'll publish this stuff in the coming weeks. And if you have a VR headset or a compatible browser, you can have to play around with it yourself. So why do we do this? Again, just to recap, you saw how minimal this was to get set up. Literally 5 or 6 lines of HTML, drag it onto a browser, and you've got a VR environment. Okay, it's not going to match Unreal Engine yet, but the power and the speed with which you can do this is pretty staggering, really. And again, if you're a web dev or know HTML, you don't have to get familiar with the creation engine to start building in VR. You can just sling some tags about, and there you go. And that can then teach you concepts like geometry and lighting and materials that you can transfer into the likes of Unity or a more powerful creation engine. And again, we're leveraging the power of the web to make this distributable. You don't need to do any App Store stuff. You don't need to do any installs. Just go onto a URL, and if you've got the right tech, you can start using these environments straight away. There's been a lot of future hype recently about metaverse and how our lives are going to be transformed by, like, VR tech and immersive persistent worlds. I do believe in the future of this technology for things like entertainment, art, gaming, research, that kind of thing. I'm not sure I believe in a world where we're sitting at our work desk wearing extremely expensive VR headsets to join a glorified Zoom call. Even if that stuff is 10 years away, it's just really not the kind of thing I'm interested in. So I'm less about the metaverse hype and more about seeing what independent artists, creators, the everyday dev can do with this tech using open standards and the power of the open browser. So a little less metaverse, a little more 3D open web, I think, is what I'm interested in, and I hope people will be inspired by this. And if you're building anything or are inspired to build anything by what I've talked about today, I would love to see it. Please share it with me. Finally, all that aside, hopefully you can see this is pretty fun stuff. You're creating your virtual world, you're throwing yourself about, dodging chainsaws or whatever it is you want to do with your virtual worlds. It's inspiring, it's engaging, and it just feels very different. The first time you stand in a world you've built your own, even if it is just a couple of bits of geometry, it's a very powerful, very engaging feeling. So I hope you will enjoy it too. Thank you for joining me today. I hope you've enjoyed it. Thanks very much to NIDConf for hosting me, and enjoy the rest of the conference. Thanks very much indeed. Do we have time for questions? Yeah. Any questions, folks? Yes?
Are there already VR CAPTCHAs, and should they be there?
Are there VR CAPTCHAs, as in like security measures?
Yes.
Interesting idea. I do fear, actually, that some of this tech will be used for dark patterns like that, but so far I'm not aware of any VR CAPTCHAs now.
Thank you.
Thank you. Any other questions? Going once, going twice. Okay, thanks very much, folks. Appreciate it. Cheers. Flew by.
Okay, just tell them what's up next. Exactly, go and heckle the other speakers.
Yeah, well, I might get something to eat now, I think.
Yeah, oh yeah, good point. Thank you so much, Neil. That was really interesting. Yeah, oh great, thank you. Just if you're coming back in the next 15 minutes, we are going to have 3 evil geniuses joining us talking about esports. So in the next 15 minutes, gives you enough time to get some more drinks, some water, and then come back and see us then. I really like
How do you check? Oh.
My name's Chris Kitson. I work for Carrick Group here in Belfast. So Carrick, I've been going for about 3 years now. We're headquartered in New York City. We have an engineering hub here in Belfast. Our first engineering hire was in Belfast. And we also have offices in Buffalo and in New York as well. So we're sitting around just over 100 people globally. So yeah, we're proud to support NIDCC as well as a company. Personally, I've spoke at it a few years ago. We thoroughly enjoy it, and it's just very proud for Carrick to be able to support the Northern Ireland development community in this way. So Carrick is a business. We specialise in digital transformation with a particular emphasis on cloud, particularly Google Cloud. So one of our founding executives was ex-Google. We've got lots of ex-Google employees in the US as well. So we have our engineering hub here in Belfast. So we've got many different disciplines, including data science, cloud, UI, UX, and many others as well. So I can't explicitly mention our clients, but rest assured you will have used a product or a service that Carrick's worked on.
Hello everyone, very welcome. We are about to kickstart with 2 evil geniuses. We were supposed to have 3, but the third one has turned good. So the evil genius team is going to be talking about esports gaming with a few secret weapons, the current tech and data stack, and how they have helped the League of Legends. So just after their talk, if you do have any questions you'd like to ask, can I just please ask you to go to the mic or look for Glenn in the back with the big fella with the pink top on, and he will help to bring you over to a mic. So please welcome Herman and Stefan to the stage.
Cool, thanks for coming. Quick show of hands, I guess, before we get started. Who has heard of esports? Keep your hands raised. Cool, okay, sweet. Who's heard of evil geniuses? Yeah, you don't count at the front. Okay, good to know, good to know. So we're going to talk a little bit about what we do at Evil Geniuses, and specifically from an innovation angle. So, we are the Evil Geniuses innovation team. There are about 14 of us at the moment. We're a team of engineers, data scientists, analysts, and product people. And we all work within Evil Geniuses across 3 locations. So we've got a team here in Belfast, some in New York, and some in Seattle. Keep hearing Evil Geniuses. What does that mean? Okay, so Evil Geniuses is an esports organization that's existed in the US since about 1999, I think, which makes it one of the oldest teams in North America. We compete in we compete in a couple of main titles, League of Legends, if you've heard of it, CSGO, Valorant, Dota 2, Rocket League, and a bunch of fighting games. These are some of our players and their highlighted moments. However, in the last couple of years, what you'll have seen is a change from this team, specifically focusing more on data and really making sure that we have data-driven decisions. So we're going to talk a little bit about the tech behind that. So who's here today? Obviously, one of us has not made it. He's fallen to the side, but I'm here, Stefan. I'm the product manager at EG, and then Herman is one of our senior engineers. So what are we actually building? It kind of comes down into 2 parts. The first is internal tools, and this is actually the big division between us and our competitors. We have built out a team to build internal tools to support our different teams. And what that means is we've built performance monitoring platforms, video review platforms, and we're currently working on voice communication analysis to really basically bring the most out of the data that we get from esports. And there is an incredible amount of data, which we'll get into in a minute. The other half is Factor, and this is a consumer-facing platform. If you want to think about sort of BBC Sports, but for esports. And at the moment, we're covering League of Legends. It's also got a little bit of fan engagement side of things, and we're kind of leaning into that social aspect because that's ultimately what sets esports apart from regular sports. We recently released a new piece to kind of watch pros practice. So if you think about it, I'm an Arsenal fan, so it was if I got to go to London Colney, I could watch all the players practice, but then I could hear them speak to each other. I mean, that's the kind of access that you can't really get for regular sports, but all of a sudden in esports, that's possible, and that gave us, that bumped our traffic up to about, I think we hit about 500,000 monthly active users just on that alone. So the journey so far, and I guess this is how we got to Factor. Essentially in 2020, our head of data science, who was called ex-Tesla, ex-Google, was building these reports for our teams. And what that meant was he was basically generating spreadsheets, handing off to the team, generating spreadsheets, handing off to the team, and he's doing these complex data analysis pieces, but ultimately it's just spreadsheets. And I think anybody who's worked in corporate for long enough knows that a scary amount of it runs on spreadsheets. So the part was to really turn that into something that we could use, put it in a more user-friendly manner. So that was Sign. And that kind of started off at the end of 2020. So built a very basic platform, put a lot of time into it, and it wasn't very good. But what it meant was there was a lot there for users to really, specifically our internal teams, to look at and go, okay, this is what I'm looking at. This is the prep that I need to do for certain situations. However, data is a funny one because at a professional level, you don't really know what the impact is. And we kind of came up with a thesis that essentially, actually, we can show a lot of this stuff to the general consumer as a communications platform, as a place where they can go and really see these stats themselves. So That's how Factor came about, and that was really the first stage. We then iterated on Sign a little bit and built it into a video review platform, which Herman will show off a little bit later, which really basically took all the data that we gather for esports, which is, again, an incredible amount, and put it into a browsable, accessible tool that would let players and coaches kind of see the breakdown of a game, right? So if it's the equivalent in a football game was like, I want to see the exact moment where someone kicked the ball at this angle. You could find that. You could find it with timestamps. You could click a button. You could see exactly where that was. And then we're kind of taking Factor to the next level. So that's what the second half of this year has been about. Essentially taking Factor to what we think it can be, and that's more of a focus on how a person interacts with the game. So you can see on the top left, we've got sort of like a browsing companion tool where you're watching the game on maybe one device on your TV, and then you can whip up on your phone, open Factor, see a live map of seeing exactly where everybody is, see what people's stats are, and really have that like engaging viewing experience. We've got 1,000 pages for Factor, but it's really kind of expanding esports to a wider audience, because the problem is at the moment, to get into esports, you have to understand the game, and that's a really difficult ledge for someone like my mom to explain, okay, how does she understand an exact like damage per minute of a player? That doesn't really matter to her. So tools like this are to help take that to them. So I'm going to pass to Herman to talk a little bit about what the actual backend is.
Yeah, before I started, like, I was thinking about, like, you know, build it and they will come, you know, we're utilizing all the stats. Like, even today, you know, what we planned to do, like, it didn't even happen because, like, initially I wanted to do, like, a more of a casual chat, have myself, Stefan, Paul, and Paul couldn't even make it today, unfortunately. So it is quite funny, like, building products, even talking to people today, you know, in the conference room, you know, talking about the past, like, all the dumb stuff that happened, you know, all the choices that were made. So there's been a lot of that. And when we built Factor, you know, we thought, we'll give them stats, people will make sense of it, you know, and it didn't happen like that. And it was very difficult at that time, but we did review, you know, Stefan came on board shortly afterwards and, you know, enforced a lot of discipline and understanding what the user actually wanted. But one of the key issues that we had was there was so much data that we had to deal with. We thought we can summarize this data, show them in a post-match sort of sense, give them as much information as possible, they can decipher it. So for some context, an average game is around 30 minutes in League of Legends. And for any given player, there's about 10,000 data points. And also there's 10 players that are involved in any given game, so that's 100,000 data points. So this year alone, EG, the main roster, played 67 games. That's a lot more because we actually qualified in MSI, which is mid-season invitational, and also in Worlds as well, which means that we played an extra potentially 15 to 20 games in here. And that's roughly around 9.3 million data points. So can you imagine, like, we also have 3 different rosters too. We've got the Academy, we've got Prodigy as well, and Factor as a platform serves 355 teams. So one of the things that we started looking into, like, how do you make sense of some of this data? So I started prototyping different things, like, let's condense some of this data and just show it into a heat map of, you know, I started playing around with looking at wards placed, kills, deaths in a particular season. So this particular data was EG data 2021. So we just kept prototyping, playing around with it, talked to a couple of people. I even had to talk to, you know, Lisa there about, we need to downsample this because there's so much data. And in order to explain it, I drew like a Sudoku diagram, even though it doesn't really make sense, but the concept of Sudoku was about adding numbers. And when you add numbers, you're essentially downsampling things. However, we had to make conscious decisions on how far we take this, because at some point when you downsample data, it just becomes meaningless. And we have essentially a visualizer now, and we didn't like do everything. We just straight up took the ward placement stuff and then kills and deaths for the start, just to see how people use it. We enabled a couple of filters like region and season, and there was a couple of conversations that happened on Twitter. So people from the French League started using this particular tool, and then we had conversation with them on Discord, see like, how can we help you a bit more? So we started adding in filters like by team, and then in even more granular level at matches, and even what the players are actually doing. So this particular heat map example is actually a game that happened last week against G2. If anyone watched that game, like, you know, essentially stomp them. And we prioritized, if you look at the map, it's for awards, so a lot of awards were placed on the top side, so we were prioritizing on top vision for the early game. So you'll see like a wee filter for game time, 0 to 14, that's basically that time. And we wanted to know a bit more, what are key times for particular games, and these are all the questions that we would drill into and question the analysts that are using our product. So, yeah. So we do spend a lot of time trying our best to speak to coaches, but mostly we have access to analysts. I think that's because coaches are super busy, like their seasons are super crammed, there's a lot of stuff going on, but they do work closely with analysts, so we're so fortunate as a team that we're like literally right beside them. We can go to them and ask them a question when we need to. I've worked into like a lot of startups and stuff, and you just start making a lot of assumptions, you start building out features and try things out. We have the luxury of just going around and knocking on a door and say, what's the crack like, how can we help? And I think that kind of differentiates us to them, and I believe we were like one of the only team in esports that has a dedicated innovation team. So one of the tools that we built, actually at the start of the year, we went through a design sprint. We started looking at what are the coaches looking into, what's important. So video review is quite important. So over in LA, Santa Monica, they have dedicated rooms for VOD reviews. It's basically just like reviewing videos of games that have been played, and also debrief after a game or scrims, and even looking at oppositions as well. So like if they wanted to know about a particular team, how did they behave in certain scenarios and key events. And we decided, what, we have these VODs, they're just publicly available on YouTube, and the data that we get from our data provider, we know exactly when key events happen. So we just kind of combine the two together. So I'm just going to do a quick demo here. So this is a tool that we built for our coaches, and what you can do in here is essentially a coach would be super interested in a particular champion. For example, a Cali, or what was the other one? Hecarim. You can see that I'm not familiar with League of Legends, so you can narrow it down and see what matches this was played. So you can go in here, it basically pulls out different events that happens within that game. And for example, if I wanted to know what happened during Inspire killing Rift Herald, was there contention in that space? Yes, there was. There was a lot of stuff going on the screen. You can go and do so as well. Or if you care about like Jojo taking down a turret bot, yes, wonder what's happening, you just click onto it and it just jumps in that video. And the coaches can come in here, start adding their notes in, have conversations with other people as well. So we just built this tool, and it's actually worked quite well. And the surprising thing was it wasn't just the coaches using it, there was actually other people in marketing using it because they cared about certain things that happened, like last week, like, collate all the kills that happened at certain times, they might potentially post it on social media and engage in conversations as well. So, and also you can search by objectives. So if you wanted to see things like dragon kills or Baron or Rift Herald, or if a team is like, if we're going to play against Rogue, for example, you can search for games that Rogue has played, and they played in the Worlds recently, but I care more about how they perform at a regional level. You can do so too as well, and you can click into that, and you can see the games. So for example, if I wanted to see what was happening, Rift Herald up here, was there contention? No, there's not. Let's see the second one, also not much happening. And then maybe a dragon, that's happening in the background. Let's have a look at, I don't know, the Baron setup, for example. A coaches tends to go back and forth like this. This tend to be what they do during any given VOD review. You can imagine they'll just blow it up and have like the rest of the player review what's actually happening and dissect like, why would they have players there? Why is I can't really see. Trimbley, tends to be like looking at whether they're going to come and attack, etc., or steal the Baron. There's things like that that we built into this. I'm not going to go into the note section because there's stuff in there that is more for us, but that's the gist of a video tool. It's essentially using what currently exists and kind of utilizing what we already have, essentially, and making that value for the coaches themselves. We'll talk about the...
Yeah, sure thing. So you can kind of see that we work with a lot of data, and this kind of stuff is pretty new. So we have this challenge where essentially we're first to market on a lot of this stuff, and it's not because people don't want to do it. It's that all of you guys, you're working on real engineering products. You're really working hard on those pieces. So what you have is a hobbyist space essentially. You've got a lot of analysts who like League of Legends, maybe taught themselves to code, and have now worked their way into the scene. They're working with teams professionally. They may not understand how to use Git, but they know the very intricate details of how to really turn a lot of raw data into something useful. So the industry as a whole is super immature. And the other problem that we have is essentially when you look at who's putting the money into the scene, it's betting companies. And ultimately, betting companies don't really care about the teams. They care about providing it odds to whoever's going to be betting, but they don't really care about, oh, how can we make this team better, or how can we make that team better? So we have to be building a lot of these pieces ourselves. We also struggle with support from these companies that we're getting the data from. So basically, part of our responsibility is to turn this into enterprise solutions, turn it into pieces that a lot of people can use, and then really build it out ourselves. And kind of mentions here, but the data is a mess. We have something like 4 different machine learning algorithms. We've got one for win probability, we've got one for pre-match win probability, we've got one for daily fantasy, and then we've got one for a proprietary metric, which we call power, to rank different teams against each other. However, our data provider doesn't even tell us when a game is missing. We're trying to sell this to customers, and they're like, something weird with this? It's like, yeah, okay, cool, don't worry about that, we'll fix that. So we have a real struggle for consistency and correctness. And particularly completeness, which means we're taking in multiple data sources, trying to parse it. And one of those data sources ultimately is normally some guy who watched the match and typed it into an Excel spreadsheet, and you're like, hey, can I use that for my data, please? So how do you deal with this? How do you work on this problem? And essentially, the big part that we're all finding is none of us are from esports. Herman's worked on a lot of AI-based stuff. I used to work in game development, and then I worked with PwC for a short time. None of our team are from esports. And what we've found is that all of these problems have been solved by you guys, essentially. And it's how can we apply that to this space? So the other part is also applying this as sort of a long-term data strategy. I mentioned it before, but having multiple data sources, for example, to make sure that you're not floundering when a game is missing. So, looking at the future. We had a great success with all of the work that we've been doing, because what happened was one of our teams won a championship. In fact, EG has never won a League of Legends championship until spring this year. We won our first one, and it was a very big deal for the whole team. But not just the team, the entire organization, all 150 of us, how many there are working now. So we want to keep pushing this forward. So there's a couple different avenues. I think the first one, when we look at our consumer-facing platforms, is turning these into more of a social platform. And I think this is where the comparison between traditional sports and esports is hard, because in traditional sports, you have a fan base. I've supported Arsenal my entire life. I was a kid. It was in my blood. But nobody really cares about evil geniuses, the concept. It's not something that your dad gave you a scarf when you were a little kid and say, this is who you're going to support. It's like you found an individual that you like, and you're like, oh, cool, he's on that team. I'll watch him. And this is a change that makes it a very different space to traditional sports. And what this means is individuals. So recently, Valorant is the big game that's kind of taking off. Franchising has happened. And some of the individuals there have bigger brands than a championship football team. These guys have millions of followers, and they're playing this game. People aren't following them, their team, they're following them. So we need to shift what we're building to cater to that, and that's kind of what our social platform did before that gained a lot of fandom. The other part is engineering growth. So as Herman alluded to, not many teams are doing this because engineering is expensive. We have a team of 15 people about working on this across multiple locations, and other orgs are basically saying, we can't do that. So they look to us, and they're like, okay, what are you guys doing? Seeing where it's working for us, seeing where it's not, and that's kind of a hard one for us to deal with, but we have to kind of understand the fact that we're kind of the leaders in this space. The other part is kind of the comparison between trad sports and esports. Right now, the number I kind of throw around is that esports, from a technical perspective, is about 10 years behind traditional sports. There's a lot of stuff that's not being done. There's a lot of pieces that we can't do because we don't have the time. But what we do have is an incredible amount of data. So in football, you see, if you've heard of stat sports, they have the GPS tracker. They're kind of walking around. They're able to track their movements, but that's kind of it. You can track like sleep performance maybe beforehand. In these games, we can track micro mouse movements. We can even do eye tracking for like where players are looking. We can do minor tracking to see if something way over on the other side of the map impacted a specific moment. You can kind of build these massive trees of what's happened. So we have this wealth of data that we need to kind of get into, and I think that gives us an ability to kind of get beyond where trad sports is. So what's next for EG? Obviously, I mentioned a little bit that we have been using data-driven decisions, I guess you would call it, for some time. And a key part of this is sort of player scouting, and that's something we want to lean into more. If you're familiar with EG and our LCS team, you'll know that we have a rookie called Jojo Pyun. He's 18, just turned 18, and he was scouted from a Fortnite roster. He was a kid playing Fortnite in his basement, and our scouts were like, this guy's good, and they were only able to do that because of the data. To give you an idea of how much an esports team costs, a mid laner, which is what Jojo Pyun became in our League of Legends team, gets something like a high-quality mid laner who's been in the scene for a while, $2 to $3 million a year as their salary. Jojo Pyun was a rookie. We were able to bring him in, say, hey, this is the scene, welcome, help him on board, and ultimately it's infinitely cheaper, but he can still perform at that level. The other part is performance monitoring, so making sure that when you have teams, you have players, you're really tracking them over time. So a big initiative that EG took on recently is typically in CSGO, one of the first-person shooters that we compete in, you have a roster of 5 players. EG kind of looked at traditional sports and was like, okay, why don't we have more than 5 players in case something goes wrong? We took 15 players. In fact, I think now we have maybe like 25 players. And we can swap them out and swap them depending on how they're performing. But what you need to be able to do is track their performance, otherwise none of that matters. I mentioned it a little bit before, but leaning into fandom is another big part. Enthusiasts love stats, and like those were our initial users, but like your average viewer doesn't really care about Jojo Pyun's damage per minute. They just want to see him do some cool stuff. So how can we focus on them and enabling them to track their pros? And that was that feature that I mentioned before. It was called a Champions Queue Hub. And essentially that was a place where all the pros would practice for the world tournament. Everyone from the best players from across the world came to North America to compete. And all of a sudden it's like, I don't even know how to compare it. It's like Messi is playing against like the guy from your local school, essentially. And you get to watch that and you get to hear Messi talking through that guy's headphones. And you're like, okay, cool. So that was massively successful for us. And the last one is a bit of a controversial one, but it's about supporting other orgs. This is a really hard sell from me to my leadership, but essentially we are moving so quickly through this that nobody else can really keep up, and it means that we have to essentially build platforms for them to come along with us. And it's a difficult one because I have to say to Nicole, our CEO, like, hey, we're doing some really cool stuff, but what can we give to other people for no cost? And she often doesn't like that part. But ultimately, like it says there, rising tide lifts all boats. If one team in esports is dominating for years, nobody's going to watch. It's all about the competition, and ultimately, the competition is more important than winning. So it's about how we can bring that engineering mindset to esports and kind of help other teams build out their own platforms, but also build out their own engineering structures. And even if this is through resources like low-code spaces where they can build their own little tools using our back end, that's something we're probably okay with, because if it means they're better, it means our competition's better, which means people want to watch more. So that is a very quick summary of everything we do at EG. There's a lot of stuff that we didn't cover today. I think we'll be doing some questions, but if you don't get to it, feel free to hit us up. Cool. Yeah.
Yeah, we'll take
5 minutes for questions. Any questions? Anything about esports? I think there's one at the back. A couple.
You kind of mentioned sort of about like enriching it with external data sources. Do you see the platform that you've built? Do you ever consider its application outside of esports, like enriching sort of traditional sports, or even outside of games completely? Like, you know, giving people richer ways of like visualizing sort of footfall on retail flow, retail environments or crowd management, or it's given a really powerful, insightful way to sort of look at just multiple data streams. Do you ever kind of consider other applications?
Yeah, sort of. So it's an interesting one because essentially, like I said, we're not really building anything from scratch. We're kind of learning from a lot of other platforms. So, for example, all our visualization tools, I'll be honest, like I'm on Tableau. I'm looking at how Tableau's doing it. I'm looking at how ClickView's doing it. I'm trying to like steal that essentially because they did the research. I'm only like, it's me and 3 other people. We're not going to be able to do all the stuff that they did. I think there's definitely an opportunity because essentially we get a lot of time to play around with these tools, and in a way that some of these other orgs are sort of, not orgs, but engineering companies are focused very specifically on solving problems. We're kind of solving our problem, but being a little bit general about it. So there's space for it, but not something we've looked into yet.
I think there's also like a data context problem as well. Like, for example, esports is very specific. Like, you need to know what sort of features that are, useful, and you have to find the patterns within. I think trying to make it generic for different use cases is actually relatively difficult. I think you do require specialists in the space. This is why I was saying earlier about having analysts, as part of the group. That's them bringing that value in within that data to basically cherry pick, what's important, what is not important within that data itself.
Anything else? Any questions?
So regarding the use of data, have you plans, or maybe you already said it, but I missed it, but for like predicting, say, for example, which is the best weapon against this situation, or, you are in 1v1, maybe this is the best outcome I can perform, maybe, flee or use this attack, whatever.
Yeah.
Are you using that?
That's a really good question because, yes, I mean, essentially, it's kind of what we're doing at the moment, actually. Internally, we're doing another couple design sprints to really highlight what we think is going to be important for the next 12 months for us. And what that means is kind of doing those sort of models and simulations where you could theoretically just snapshot at any point in the game and say, what's the best decision to make from here? The problem comes actually in the communication. So in football, keep going back to Arsenal, I'm sorry, I can't help it. But Mikel Arteta, he's on the bench, he's talking to the players, he's shouting to the players, he's communicating, he's moving them around. In esports, you can't do that. In fact, it's very strict. You cannot communicate with your players. You have a couple of minutes before on stage, but that's it. So what it means is you basically need to drill the players with these things ahead of time, and that kind of comes with the scouting. Because essentially a coach will scout a team that they're going to play beforehand and say, this is how they traditionally play in this situation. It's like, let's say it's CSGO, there's 3 players attacking this bomb site. How does this team normally defend? You can drill that 1,000 times, essentially, if you have the data. But the problem is, these teams play so many games. And that's where we kind of build the platforms, because essentially a team might have 100 games they need to go through. And one coach can't do that. He can't scroll through all those games. So long and short is yes. We're looking especially around like the machine learning aspect of sort of like the models that we can build. We recently partnered with HPE to kind of extend our machine learning AI capabilities. And they're kind of helping us with voice communication analysis in that regard as well. So that would be a player is making bad calls essentially during the game, and like how can you isolate the audio and say, this guy's not in a good mood, we need to communicate to him that he's not in a good mood and he needs to change his communication patterns. So it's definitely the future of where we're going, and it's really like seeing what pieces we can tackle bit by bit.
Thanks.
Cool. Anybody else?
Hi there. Sorry for my accent, French accent. But is React open, like the API, is it open for you to read from it, or are you getting the data from videos, or like how do you get the data itself?
Yeah, so there are a couple of official data providers. Each game normally makes deals with different providers. It's a weird space because essentially every game controls the rules of the game and controls like who they sell the data to. So We have a couple of data partners, and we try and get as much coverage as possible. For example, League of Legends has an exclusive partnership with, I think, a company called Baze, and basically we have access to their API. We have proper access, which is as a team, you get a certain amount of data, and then we have an individual contract that we've signed with them to say, like, can we get the good stuff as well, please, essentially.
Okay. As you are ever like you to buy your stuff, like, why is there no partnership between you and Riot doing that?
Yeah, that's a good question. So it's somewhere we want to go. Again, because it's super early, it's difficult. Essentially, you have to remember, like a company like Riot, they build League of Legends. Esports is a small part of that, but actually League of Legends itself has 300 million active users a month. Esports is a tiny slice. It's almost like a marketing activity to them. So for them, they're like, we just want to get rid of this data. We don't care who takes it. So as well, as a team, as evil geniuses, it's a little bit suspect if basically we become the only people who can get the data from them. So we kind of have to work through these external parties to make sure that we're all above board.
Okay, thank you.
All good. Anything?
Do you have any expectations for maybe making this kind of more like an API for like live streaming, so that the data can be harvested and immediately put up on a live stream of the actual game that's being played, right?
Yeah. So essentially, absolutely, like that's the goal. Part of it is like building media widgets that we could theoretically sell to a broadcaster, right? Or if you want to set up a tournament with your mates, all of a sudden you can plug into Factor and you get those widgets. There's some interesting pieces around like latency, because often it's easier and better to just get it direct from the game, which requires different data passes to what we normally use. But yeah, absolutely. Yep. All right, cool. If you have any other questions, come and find us. We'll be about the hall for the rest of the day, or add us on LinkedIn. But yeah, thanks for listening.
Thank you.
What a super, super cool team. At 2:30, we're going to have John Glass taking the stage, and he is going to be focusing on integration testing.
Hi, I'm Brian Craig. I work at Liberty IT. I lead the architecture team, which means I make sure all the engineering is focused in the right direction and our different job families are all going towards the continuous improvement. So Liberty IT, we have about 650 people based out of both Belfast and Dublin. We produce software and world-class engineering for our parent company, Liberty Mutual, which is an insurance company based out of the US. We do so many different things from them, from straight software engineering to data scientists to product ownership to product management to a level of consultancy. So that's that we deliver, and they're a Fortune 500 company. So NIDC, the big thing about it is it's community driven. It's talks by practitioners, by developers, all levels. It's inclusive, there's support if you need childcare. Again, it's just fantastic, the level of interest we get from people attending, but also the different variety of talks you get. And it's people who have like 1 or 2 years experience to people like myself who have 20 to 30 years experience. There's just such variety. It is really, really energetic is the other thing, really energetic. This year at NIDC, I'll be talking about how the marriage of architecture and engineering comes together to deliver business value, and how do we do that in a continuous way. Liberty in Belfast, we currently have our graduate and intern recruitment open, and it is open until the end of the month, so please go ahead and apply. We'd love to see you here.
party started. Hello everybody, you're all very welcome. We are about to kickstart with John Glass, who is the Director of Engineering at ESO. And John's going to be discussing in-memory integration testing. And at the end of John's talk today, we will be going off for break time for 30 minutes. And then afterwards, you'll be coming back to join us for Matthew Wilson's talk at 3:30. If you want to ask John any questions at the end of his talk, if you can either please look out for Glenn in the back, who can bring a mic to yourself, or you can pop up to the mic at the very front. So, John, thank you so much.
Thanks for the introduction. So my name's John Glass, and I'm going to talk today about in-memory integration testing. But before I started, I just wanted to say thanks to the organisers for a really smooth setup process, helping me get back into presenting face-to-face, which I haven't done for years. It's really great to see so many people back, and to be doing this again kind of properly after a few difficult years. So yeah, great to be back. My colleagues Ivan, Connor and Richard spoke earlier around some work that we've done in this testing space, and my talk today hopefully kind of complements that and does justice to what they've done earlier on. I'm Director of Engineering over Platform Apps and Field Ops for ESO, so that's all of our shared applications, the things that we use to pull everything together across all the different areas that we work, and also the applications that we use across both fire and EMS for emergency responders to manage things like scheduling, inventory, and so on. I look after dev teams, but I also still enjoy coding. I get a lot of satisfaction from trying to find creative ways to add value by writing code beyond just solving the obvious problem. And one of my recent fun projects that I managed to find time for was a Fluent database mocking library, which you'll see a little bit of later on. What I'm going to do today is give you a brief overview of kind of the big picture at ESO that kind of motivates what we're doing here. Cloud modernization is essentially the main thing that we're doing, and why testing at scale is so important to that effort. I'm going to talk about how we kind of assess the value, like ways in which you can think about the value that testing brings when you're working to put in place automated testing, and especially how that can actually give you value for the long haul, not just in the short term. I'll talk about how we put that into practice at ESO, and that's kind of in some of our newer, mostly serverless applications. And I'll share some examples that hopefully will bring that to life. And most importantly of all, I'll try and get you out of here in time for the tea break. So, my passion is technology, both kind of, building quality software and getting stuff out into people's hands to use it. I enjoy working at ESO because, what we do matters. I worked in financial services for a long time. I enjoyed that, but I like this better. Our focus, on quality comes from this mission of getting things out into the wild in a way that works. We can't afford to release software that doesn't work, and we have to get stuff out, as soon as we can to give the value to our customers. So let me talk about the big picture at ESO. I'll run through these fairly quickly. Our growth strategy at the moment is around sort of three main tracks. One is about organic growth. So as we bring new customers on board, we need to scale, and we need to give them tools that allow them to onboard in a kind of self-service way. Like historically, we've done a lot of very high-touch work in that onboarding space. We have a lot of acquisitive growth where we're acquiring companies, and we're trying to bring their software and their customers over onto our platform. I think that's a very common industry problem. Legacy applications and trying to migrate people and retire them. And we also have kind of geographic growth. So we're trying to go out into new markets, new geographies. It means, we need to stand up our environments over and over again. And it means that we need to have solutions to, regionalization, internationalization, all of those problems. So I think these are problems that a lot of organizations face. And kind of at the back of it all is this kind of big box modern cloud environment. We actually have this whole thing laid out in Post-its on a board in the office. But it's a bit too much for one slide. So the cloud environment piece is kind of broken out on the next slide here. We have three main threads of how we're making this happen. Database migration, moving off of hosted database onto PaaS. We use Azure, but the same things apply on AWS or wherever you host your cloud. We're migrating our legacy apps to be serverless compliant, and we're writing new applications according to a kind of modern web app pattern. So those are those 3 horizontal tracks that you can see there. And our testing patterns are a really key thing that feed into that. It's really important to how successful we end up being, that we're actually able to test and verify, and that we're able to do that consistently. The boxes that you can see, the sort of multiple boxes, these are things that scale out across dozens of teams and dozens of applications across the organization. So it's really important that we have good patterns for how to do this, and we think clearly about how we do it. So, that's why it's important to think about the value that you find in your automated testing. Like, how does it give you value? I would suspect that everybody who has a decent amount of industry experience has probably worked on a team where a lot of time was spent writing automated tests, and they didn't really end up delivering the value that they promised, and they kind of become a burden on the team eventually. The classic litmus test for me is like, when a build fails, do people on your team say, oh no, the tests are broken? Or do they say, oh no, the app is broken? Right? If you're just complaining that your tests are broken, it means you don't really trust your tests, and you think they're a burden. If you believe your tests, then you're like, oh, that's great, it's caught a problem with my application. Quite often people are in that kind of former camp. So let's take this right back. Let's think about, how does automated testing help? Compared to manual testing, it's repeatable and consistent. It runs sooner, faster, you get feedback earlier. You don't have to make trade-offs about what you test when. You test everything every time you deploy, every time you push your code. You can measure your test coverage. Now, this is a real kind of double-edged sword. It's a little bit like 4-hour waiting times in A&E. Like, if you set a target, people will gain the target. So this has to be something that's done in good faith. One thing I would say about test coverage is you could remove every assert statement from your test library, and your coverage wouldn't drop by a single line. So it's really important to think about test coverage as a useful metric. It's a really good thing to measure. But if you start driving it as something that you really goal people on, and you start, people get the fear about test coverage, you'll just drive out really bad behavior, frankly. And obviously, it's automated. Like, it's automatically actionable as part of your CI/CD pipeline. You can feed out, you can create gates, you can feed out notifications. It ends up being a push-based behavior rather than oh, did we deploy that? Did it work? I don't know who ran this thing. But there's downsides to it too. So test scenarios can be really hard to set up. And if you take shortcuts setting up your test scenarios, you can end up with flaky tests. Test runners have no common sense whatsoever. So they can fail hard, they can be flaky, they can fail in ways that doesn't give you the information that you need to solve a problem. And the last thing, I suppose, is that test runners only spot kind of what they've been told to spot. So as a kind of way of categorizing automated testing, there's sort of 3 different ways in which you can do it. The first is in-memory testing. And by that I mean testing in your build, in your CI pipeline. You're literally just building the code and then you're running the code. It's, can be TDD, kind of pure unit testing of maybe a single class or service. Or you can do more of a kind of integration testing approach where you test an acceptance criteria. And that might be using a framework like SpecFlow, where you can give it an acceptance criteria, a behavior that you want the application to have. And often then you'll mock out service dependencies. You'll build up kind of mocking around the thing you want to test in order to make it work. You can operate in partially deployed modes. There's lots of different ways to do this. You might spin up a Docker image to provide the database that you need. Essentially, it means you're deploying, but you're not quite deploying. You're not deploying in the same way in which you would for real. And then you can operate in a fully deployed mode. So this might be in a kind of dedicated dev environment or a staging environment. And it also might be in production. Like, you probably want to run smoke tests in production once you've deployed. So all of these things have a lot of value. But it's really important to have this kind of taxonomy, this way of categorizing them, so that you know what you're talking about when you're talking about a test. ESO is a kind of medical company, so we bring some of these kind of statistical things into play. False positives, false negatives. I'm sure you guys understand what those are. But essentially, in a medical test, a diagnostic test, as much as a automated software test, you have relevant elements, they're called here on this diagram, meaning like things that are broken, cases of a disease, bugs in your software. And then you have true positives, which are those ones that are detected by your test. Then on the right-hand side, you have true negatives, stuff that's working. And you have those false positives, which is things that are working that have been detected wrongly by your test as being broken. So sensitivity, that kind of statistical term, really means coverage. It means how broad is your coverage. Specificity, which is this rate of false positives, that's your flakiness, how flaky are your tests. And what do we want? We want them to be quick to run. We want to test the required behaviors of the application. Sometimes you end up writing tests that don't really test anything that's very real, and that's a real kind of warning sign when you see that. A really big thing about making tests valuable for the long run is they need to be resilient to refactoring. Like if you decide to re-architect or change your code, you don't want to have to rewrite all your tests at the same time because you suddenly lose all confidence that anything works. And that's why testing externally observable behaviors, these are the things your customers expect your software to do. If you test those things, then it will survive any refactoring, which the customer continue to think your software works, your tests continue to think your software works. That's where you want to be. And across those different layers, you want to test all components of the application, but without duplicating any of your test effort. There's a lot of UI automation, and I've probably worked across 2 or 3 teams where lots of UI automation has happened, and then it's become a real drain and a real kind of difficult situation for the team maintaining end-to-end UI tests. Like, oh God, the tests are broken, rather than, oh, my app's broken. This is the classic place where you get this. It tests everything, it exactly mimics the behavior of a user, so it's very tempting to think this is the perfect form of testing. But, the tests are slow. They only run once deployed. They're much less reliable. They're not very specific. So this is the false positive rate starts to climb. They often have to cover a lot of ground. You have to go through a whole user flow in order to do something useful, where in fact the thing you want to test is just one little thing. And because of that, if you want to test permutations of behavior, it can be very expensive and repetitive. So I'm going to finish this little section by just sort of talking about how we talk about in-memory testing. TDD, there's a lot of terminology here which people kind of conflate and get confused about and imagine things are kind of mutually exclusive. So TDD is, Kent Beck, like that's the best software book I've ever read, TDD by example, inventor of extreme programming, signatory of the Agile Manifesto, the guy's a bit of a legend, keeps it really simple. Red, green, refactor, that's it. I'm not going to go into that, but it's worth understanding. We know that unit testing means just testing a single component, whereas BDD means testing observable behaviors of your system. You can do both, like they're not mutually exclusive. It's not that BDD replaces or supplants TDD. You can be behavior-driven while also being test-driven. And lastly, just to confuse things, we talk about unit testing frameworks. So frameworks like NUnit, they are just in-memory test runners. That's all they are. So they don't have to only run strict unit tests. You can run, anything you can run in memory in your build, you would run using a unit testing framework. So this is kind of putting it all together. We say, I want to use a unit test framework. I don't necessarily want to use pure TDD for everything, or pure unit testing. And I want to write behavior-driven tests, and I want them to be in memory to get this early feedback without having to deploy. So how do we put this into practice? At ESO, we're investing heavily in serverless PaaS architectures. We've kind of skipped past containers, the gradual kind of thinning out of the server layer. For us, for what we do, we can usually find something in the kind of catalog of offerings that Azure provides, which does the thing that we need to do. And so we don't need to maintain or look after infrastructure. We're much happier, having Azure do that for us. There's lots of reasons for that. Ease of use, reliability, but also compliance with regulations. We have a lot of regulations we need to comply with. And a lot of these things come pre-certified, so it takes a lot of work off the plate for us. Microsoft have a kind of taxonomy of testing, which is kind of levels like L1 to L4, where L1 is kind of purely in memory. They describe it as testing the assembly and nothing else. And then L4 is a full product deployment. And those have exactly the same kind of trade-offs of shift left, shift right, early, slow versus full versus reliable that you would expect. But when you start using serverless like applications, you know, an HTTP trigger is literally just a method in your code that gets called. Like there isn't really a server. So there's not very much difference between using an HTTP triggered Azure function and just running, you know, a unit test in your build. And that kind of got us thinking about like how, you know, how can we, you know, take advantage of that? For something serverless, like what's the difference between this level 1 in memory and level 4 fully deployed? It's probably what you're thinking is external dependencies, right? So calling into the thing is fine, but it's going to call out to other things. It needs a database, it needs an external API, et cetera, et cetera, et cetera. So the next thing we're going to think about is, can we fake these out in a way that still continues to run like all of my code, but allows me to get back to this level 1 mode of running in memory? So bringing L1 back to L4. Martin Fowler, another legend, read up this Moxon Stubbs article, is brilliant. And he references Gerard Mazaros, who has this kind of taxonomy of test doubles, different kinds of ways in which you create mocks. Mocking, again, is another one of these things where there's a lot of confusion about what mocks are and what they do and what they're for. And this is a really useful list of you know, different types of mocks. Now, we ideally want to use a fake here, because what a fake is a thing that is actually has a working implementation, but like for some reason is not suitable for production. And you know, he references here an in-memory database is a great example. So if I can provide an in-memory database instead of a deployed database, then I can work in memory, and my, you know, my application code is none the wiser. Sometimes you need to use a stub. So if you need, for example, a external API, or you need to connect to a database, we can use mocking libraries to mock out those connections. So it's not mocking out the service, it's not mocking out our user code, it's mocking out the connection that the service uses to get to the outside world. And the kind of last thing that you might need to do is actually verify calls. So if you're trying to check that, say, an email has been sent or something, you might actually need to kind of spy on the mock. So, you know, a stub is kind of pure canned behavior. You set up some things it'll do. You don't really spy on what has been done to it. And then spies and mocks, you get more into call verification. Call verification, I'll use sparingly, because, you know, it doesn't matter often what order calls were made. You know, if the right calls were made or the right kind of things happened, you don't, you know, again, being resilient to refactoring, if you set up big chains of call verification, you can end up being very brittle with respect to any refactoring that happens in the application. So what do? We mock everything outside the application, and we mock as little as possible of what's inside the application. That's how we get as close as possible to that L4, like fully deployed, exercising all my code way of working. And the last thing is, we want to use what I call knockout mocking. So rather than building up mocks from the ground up for the services that I need, what I actually want to do is I want to start with the application as it runs in production. I want to start it up in exactly the same way as it would. And I want to knock out the services which are reaching outside of the application in order to mock those. So I use the same kind of startup process. So this is a little picture of how this works. This is an example of a web application, and the big circle in the middle is an Azure Function API, which is the back end to an Angular UI on the front end. The kind of dotted line around the edge is the application boundary, and the little scooped line, the thicker line with the scoops taken out of it, this is our in-memory integration test boundary. So this is how we effectively we take these minimal scoops into the side of the application and replace behavior that allows, for example, the HTTP client that one of my services uses to access an external API. I replace that with a mock using the mock HTTP library. An EF core database, I replace that with the SQLite in-memory provider. And the HTTP trigger, kind of the way in, I'm literally just calling the controller method. It's the same method that gets called by the production code. So although I've kind of taken these little scoops, these scoops are actually configuration. They're configuration in the setup. They're not actually changing or they're not reducing the coverage of my user code. I can actually achieve 100% coverage of my application code using this method, kind of exactly mimicking the way the application behaves in the wild. Talking about why this is useful. Well, strict unit testing gives us all these benefits of CI, like rapid feedback, but it's not behavior driven. It doesn't give us the behavior of the application. It doesn't test all of the code. And it doesn't test how the code is all wired up together. UI automation gives me that full behavior verification, and a little bit more as well. It gives me the UI talking to the API backend, but it doesn't happen as early. It's not as fast. It's not as reliable. It can be flaky. So there are reasons to use strict unit testing. There are reasons to use UI automation, but what I'm suggesting here and what we're putting into practice at ESO is to use in-memory integration testing where we can, use this behavior-driven in-memory approach wherever we can for as much of our coverage as we can get. So I'm going to just show some examples here, and if I can get out of the slides. Just a couple of examples of how this works. So if I look at this, this agency controller test. Now, this is an Azure function, and if you've used Azure functions, you'll know that there's a startup class that you create. And this is effectively how the application is bootstrapped. So you extend this function startup class, and what will happen, the runtime will call this configure method, and the configure method allows you to register all the services you need. So you basically create your kind of IOC container. What we're doing is we're using this exact same startup class. So it's the same startup that would be used in production. And what we do is we create the startup object within our test base fixture. We set up all the services on it. And then what we do is we mock out, effectively replace with mocks only those things that reach outside of the application. So this is the kind of important difference. We're not building up mocks as we need them. We're taking the whole application and we're knocking out the things that reach outside of the application, and we're adding mocks for those. So not only are you testing, the application code, but you're also testing how it's all wired up, like how is it put together in order to work. So there's a few little things that we need to do here to get that mocking working. But essentially, then I'm using the in-memory database provider, and so I can add some data. This is a clean, empty database at the start of this test. So it's very easy setup, tear down. Anything you'd be doing in a deployed test would be much, much harder than this because you'd be worried about state and data setup. This method here, this controller class, is the HTTP trigger endpoint. So that's what the Azure function runtime would be calling. So we literally call that, and we get the response. And that's what would be serialized back along the wire from the API, which we can then verify against. So that's an example of, the process of setting this up is a little bit fiddly, just like setting up a new, dev environment can be. But once we've got it set up, it's reusable for every test, and the tests themselves are pretty straightforward. The next example here. Yeah, so this is, that was one of the first ones that we wrote. This one here, rather than deriving from a kind of common base class, we've just gone for a kind of compositional model rather than an inheritance model. But it's the same kind of thing. So we have this test startup class, which goes to the real startup class, configures itself as it would if it were running in production, exactly as it would in production. And then we proceed to knock out different services that we need. And these are all commented here to kind of explain what's happening. So we knock out the access control, and in this case, we grant access to everything. We might not do that in other test cases. We have a different HTTP client handler so that we can mock out external API requests. And we're knocking out all of our EF database contexts and replacing them with SQLite and a few other things, blob storage, feature switch service, that kind of stuff. And so in here, this is how we mock out the HTTP call. So it's going to say when this call gets made, this is the response we want. Again, we're going to make a call, again, the controller method. This is the entry point to the Azure function runtime. and we can verify on the response. And the last one I wanted to show is just, you know, I realize it's very sort of Azure and Azure function centric. I'm pretty .NET centric myself, so I can't show you a Java example. But this is one where we've actually done the same thing with an older application that uses a different bootstrapper. So this is Grizzly is an internal library that was written a while back in ESO. It bootstraps the application. Again, we've extended that bootstrapper with our own bootstrapper, added a few things that we need to make it work, and then we have exactly the same ability here to set up these tests. So in this case, we don't have Entity Framework. We're using SQL Server directly, and using this nsubstitute, like Fluent database mocking library. We can set up queries. You know, when this query is run with these parameters, return this result set, or single row result set. All of that setup is kind of complete, and that means that we can then, in the test class, use our test bootstrapper to set up the test case that we want to run. And again, we can operate against the endpoint that would be used in production, and we can verify against the results. So that's all the talking that I wanted to do. Happy to take any questions if anybody wants to ask anything about that.
Hi, thank you. Just wondering, you mentioned about SQLite there as a substitute data store. We've had some trouble doing that just with the differences in what sort of column types and sort of things it can support. Do you end up making modifications in code to kind of look to see if you're running in test or running in production and change accordingly?
Yeah, there are some things that SQLite won't support. And so in that case, when you bootstrap the data context, you can detect, you know, what engine you're using, and you can make slight tweaks to how the thing starts up. I think another thing philosophically for us is that, you know, we're quite bought into this kind of Azure PaaS mentality of kind of using what's available. I think if you think about sort of, you know, do you really need that extra feature, or could you live without it for the sake of consistency? With both database engines. You know, it's a decision you need to make in the detail, but like our approach would be to try and stay as simple as possible until we needed to do a specialized approach.
Have you ever encountered any situations where by not doing say for example, the full stack, you've missed an issue being released that type of test might have caught?
I mean, I suppose it's difficult because we do have bugs and then we come and fix them and we add test coverage for them. This certainly isn't a kind of replacement for all tests, so we still have quite a fair bit of Cypress automation to do the end-to-end testing. But I think it's that point about the kind of long-running workflows and setups that you need to do, especially where you've got like duplicate paths through or permutations that you need to test. Being able to test the whole of the API kind of in its own right is really useful, but we still need that kind of end-to-end verification that Cypress gives us.
Time for one more.
Thank you. What is the startup cost for these kinds of tests? Like, from when I make a change to the code, I press F5 to when the test actually runs?
It's sort of the order of a second, I would say. So yeah, the startup, it's not, you know, pure unit tests will run faster, but it's not prohibitive in the way that like running a Cypress fixture would be. Cool. Thanks a lot, everybody. Enjoy the tea.
We'll be back here at 3:30 after our tea break, and we'll have Matthew Wilson, who's an AWS community builder, exploring serverless engineering. So see you then. Hello everybody, welcome back. I hope you're all fed and watered and ready and raring to go for our last side of NI Next up we have Matthew Wilson, who is a Principal Software Engineer at Instill and also an AWS Community Builder. Matthew will be exploring and discussing the transitions to serverless engineering. So, here we are.
Thanks everyone, it's good to be here with you all today. So a little bit about myself. My name is Matthew Wilson. I am husband to Rebecca, father to Joy Tabitha. I've just realized my brother's in the audience. I'm also brother to Caleb, just in case he gets upset. I'm a Principal Software Engineer at Instill, and I'm an AWS Community Builder in the serverless category. So I've been working on a project called Stroll for almost 2 years now, and I would say it's probably the best project that I've ever worked on. And I'm going to talk about some really interesting technology here today, but that's just one part of it. My colleagues are also awesome. They helped to build this platform, and our client Prestige, trusted us to build it for them. So a big thanks to anybody at Instill who's ever helped out in the Stroll project in any way, whether you're on their team or not. Thank you very much for enabling me to talk about something really interesting here today. So this is the official vision for what Stroll Insurance is supposed to be. But we're all developers, right? So that doesn't really matter. What we care about is that it's a shiny new insurance platform built with managed services in AWS. And we've worked on this project from the very start. And from the beginning, the team wanted to build it using serverless technology. Now, serverless has grown to mean many different things and can even mean something different depending on whose cloud you're paying for. But for our team and for the purpose of this talk, serverless is a way of building and running applications without having to manage the underlying infrastructure on AWS. Now, of course, there are still servers running in a data center somewhere. That's not what I'm saying. I'm simply saying that those servers are not our responsibility. With serverless, we as developers can focus on our core product instead of worrying about managing and maintaining servers and runtimes. So most cloud providers have something that looks like this, the shared responsibility model, which breaks down what your responsibility is as a customer of AWS, but also what AWS will take care of. So really, as a customer, the purple boxes is what we care about. And when we're using serverless and using managed services, we want to move that dotted line as high up as possible to have as little purple boxes as we possibly can. Let AWS do the undifferentiated heavy lifting. And what I mean by that is the stuff that adds no value to the product. So a good example is customers should be able to log in with an email address and a password. And really, you could build that yourself, but why waste that time? Just outsource that to AWS and get on with delivering some value to Stroll customers. So what we're talking about here today are managed services on AWS. You might have your own favorite cloud provider, but I'm hoping that we can all learn something here today. And the benefits of serverless are clear. There's no infrastructure provisioning or maintenance. You get automatic scaling. You only pay for what you use, and it's highly available and secure. And what I really want to share with you today are the things that we learned as a team from our journey from zero to a serverless car insurance platform. When I joined Instill 4 years ago, one of the things that I noticed right away was our focus on quality. Testing is at the core of every project at Instill, and you quickly buy in and appreciate the benefits of test-driven development and automated testing. And Stroll was no different. Without ever having to look back through Git history, I know my colleagues would have had at least good unit testing in from the very start. But there's one mindset that we started with as a team that needed to change, and that was our desire to be able to run the back end locally. It would be complete madness to not be able to run the entire stack on your machine, right? However, when you're building serverless applications, you really need to switch your mindset from running locally to running in the cloud. This will have a profound impact on not only how you verify that your application is working correctly, but also how you architect the solution. This project started off as treating AWS Lambda as just another way of getting some compute in the cloud. Yes, we were using a Lambda function, but really it could have easily been a Docker container or an EC2 instance instead. The team had built what you would call a Lambda-lith, a single Lambda running Apollo server and resolving all of the mutations and queries within that single Lambda. Now, why did they do such a thing? And they had their reasons. First of all, the entire back end could be ran locally. Because it was simply just Apollo server running in the cloud, you could also click the little green play button in your IDE and you had everything running locally. The React web app would be talking to the Apollo server back end, and it would all just work on your local machine. Once that Lambda had warmed up, it would be able to serve subsequent requests really quickly. And also, there's less chance of being locked into AWS. It's much more portable. But there are some downsides to this approach. And really, the importance of testing locally had forced the team to make an important architectural decision of a Lambda-lith, which had its own downsides. And the big one is cold starts. If you have ever used a service like AWS Lambda before, you'll have most likely have heard this term of cold starts. Your functions will shut down if they haven't been invoked in a while, and there's a period of time when they need to initialize the underlying runtime to get back up and running again. Lambdas have what's called the Lambda execution lifecycle. This screenshot's taken from the AWS documentation, and it shows what happens when a Lambda function starts up. And when we're talking about a cold start, we're talking about what's called this initialization phase, and it doesn't really matter what it does. All you need to understand is that AWS has to do some stuff before it'll start actually running your code. And in the early days of Lambda, this cold start was so much of an issue that it ruled the service out for many teams. But because you're using a managed service, and this is true of any managed service in AWS, they're able to work away and optimize things behind the scenes, and you essentially get those optimizations for free without needing to make any code changes. So there's one of the benefits of using serverless computing. But the mistake that our team had made is that we introduced our own cold start as well. So we'd already incurred the cold start penalty that comes with using a service like Lambda, but we had to have our own cold start, and that was starting up Apollo server. It took a little bit of time to get going. So our desire to test things locally caused us to incur a performance hit in production. There's one other downside to this as well. We weren't making use of other AWS managed services. Amazon already has their own GraphQL server implementation called AppSync, which has a lot of different benefits that we'll talk about in this talk. And there's other different things with using a Lambda-lith that meant that, yes, we were more portable out of AWS, but we couldn't move as much inside AWS. Now, if we're going to say that we need to enable developers to test in the cloud, we need to make that easy. And the first point, and I think this is really important when using AWS, is that every developer needs their own AWS account. You would never ask engineers to share a laptop to do their work, so why expect them to share AWS accounts? You could have one shared developer account and isolate resources using permissions or prefixes, stuff like that, but you're just asking for some kind of conflict. Accounts in AWS are free. You can have 0 to 1,000. It's not really going to change the cost. The cost comes from what you actually do inside those accounts. The second point is you have to make your deployment process fast. We make heavy use of the hot swap and watch functionality in CDK, which enables developers to essentially hot reload the changes that they make to their code. And if you need a shorter feedback cycle, remember that Lambda handlers are just a function. So we use TypeScript from the front end to the back end, and our Lambda handlers are just a TypeScript function. And you can run that in your local environment, no issues at all. And because all of the services in AWS that we're talking about here today are accessed using HTTP APIs, if you have the correct permissions, you can talk to them from your local machine. So I like to think of this as phase 1 of the project. It worked. It was using serverless technologies, but it had much room for improvement. The team realized that this approach wasn't going to work moving forward, and they decided to replace the Lambda function and the API gateway with AppSync and multiple Lambda functions instead. So really, we were able to break down our Lambda-lith and used a managed service instead. We didn't need to worry about maintaining our own Apollo server instance. We could instead hand that responsibility over to AWS. Let's get one thing straight this afternoon. Serverless is not the same as Lambda. You could build an entire serverless application on AWS with no containers and no functions at all. And that was the next exciting phase of our project. And like all good phases, it's going to start with a story. There I was working from home during a global pandemic. We were building what you can see behind me as the customer portal for Stroll. This enabled customers to log in, see their policy information, get their documents, submit a claim. And the task was simple. Execute a query to get some data from DynamoDB. And I'm sure throughout all our careers, we've spent time building CRUD operations like this. But not to sound too overdramatic, but little did I know that my life was about to change forever. And to understand this life-changing moment, we first need to understand what AppSync actually is. Yes, it's a fully managed GraphQL service. And I'm not really going to cover any GraphQL concepts in this talk because I would need another half hour. But for context, GraphQL is just a schema. There's many different implementations of a GraphQL server. We've talked about AppSync and Apollo already. And the benefit of using GraphQL is that you have a well-defined representation of your data model. And clients can only query the things that they're interested in. AppSync provides the GraphQL server, authentication, and the integrations with the various data sources. And we as developers provide our schema and how we resolve the fields inside that schema. There's two core concepts that we'll cover quite quickly. First one is a data source. And this is just a persistent storage system or a trigger, e.g. a DynamoDB table or a Lambda function. And there are other services you can integrate with as well. Once you have your data sources, you need resolvers. Resolvers simply help you map your GraphQL query to whatever kind of request you're trying to make to the underlying data source. So when a GraphQL query comes in, the resolvers will help map that to, for example, a DynamoDB query. And then once the response comes from DynamoDB, the response mapping template helps massage that into the correct format for your GraphQL response. So if we jump back and look at our updated diagram, each of these lambdas, each of these orange boxes was configured as an independent data source in AppSync. And up until this point, this is what we had exclusively used as a team. Every time our query was made to our AppSync API, it invoked a Lambda, and that Lambda would go fetch data from somewhere. It could have been a DynamoDB table, could have been doing some stuff in S3, it could have been making an HTTP request to another service. But AppSync had so much more to offer that we hadn't untapped yet. You can resolve data directly from various sources, including DynamoDB. I was able to build the various queries needed for our customer portal without having to invoke a single Lambda or write any code to make that happen. So if you're a Stroll customer today and you log into our customer portal, there's no Lambda involved at all. It's all direct service integrations. Because we were using two managed services, AppSync and DynamoDB, we were able to offload the gluing of these two things together into configuration rather than code. Now, that's not a scary Halloween story I'm trying to tell you today. Just because I'm saying we should write some configuration rather than code doesn't mean I'm saying we do that all the time. What I'm saying is that we should be writing the code that matters to our customers, the code that's going to give them some unique selling points in their respective marketplaces. But not only did this approach get rid of some code for us, remember, developers, code is always a liability. You do not want to write some code that you're going to have to maintain for 10 years if you don't really love that code. And it also had a nice benefit of being incredibly fast, because if there's no Lambda, there's no cold start at all. And this was the mind-blowing thing for me with AppSync. I remember the first time I did this, I was working on this at home, and I invoked my very first query, which was a direct integration. And I actually jumped out of my chair because I wasn't expecting a response so quickly. I was able to achieve performance that I couldn't do by writing my own Lambda function. And really for me, it was from this moment that I started to really trust the managed services that AWS provides and really dig deep into the serverless offerings of AWS. Now, sometimes as developers, we like to build these things up like AWS is the greatest thing ever, and I'm not saying that today. Everything has its downsides, and everything is really a pros and cons list. And there's one big downside when you're working with direct service integrations in AWS, and that's that you have to use VTL templates. So the example you can see behind me takes a GraphQL query and transforms that into a query to DynamoDB. This is a brilliant idea because most of the managed services in AWS are backed by APIs, and it's really easy to build up those requests. And with AppSync, you could effectively integrate with any of them. But for whatever reason, somebody at AWS decided that velocity templates were the way to go when we build up the requests and responses from these direct integrations. So these are really hard to unit test. And a colleague, I went through a rehearsal with this yesterday with a colleague and said that they're impossible to unit test. And she reminded me that she had written unit tests for her VTL templates. So I stand corrected. They're just hard to unit test. And they have limited utility methods versus something like a TypeScript Lambda. You can put a lot of complex logic into a VTL template. You can iterate over arrays and build up very complicated requests. But we as a team have a rule. If you can easily build up the request to your underlying data source like we have here, it's quite easy to look at this and understand what it's doing, then that's a good thing. If you're starting to write what looks like a mess in your VTL template, it's much better to use a Lambda function instead and have some really good unit testing for it. There is official JavaScript support on the way. There's an open RFC in GitHub, which the team at Amazon have replied to and said that this is something that they're working on. There's also community support as well for writing your VTL templates in JavaScript too. But those things are still in very early days, but we as a team will probably explore them when they become available. Working on a serverless app like Stroll, I started to notice that the team began to think of things in a more event-driven way. We perform actions whenever documents are uploaded to S3. We perform actions whenever policy and policy holders are updated in DynamoDB. And this is one of the key aspects when working with serverless applications. You switch, or you could say that AWS gently forces you towards an event-driven architecture. And for myself, what I found really interesting is that this was a natural progression for our team. I didn't have to say to the team, we're going to do event-driven architecture. It really just happened. And the reason behind this progression is that it's how serverless on AWS has been designed to be used. Whenever Lambda was first debuted, I think it was 2014, serverless didn't appear in the presentation. Serverless is really just a marketing word. Lambda was focused on a way to get event-driven computing. It simply just responds to events. There's no way for you today to build a Lambda function that runs forever, that hosts an entire API like you would with a traditional server-side application. Today, a Lambda function will time out after 15 minutes. Lambda functions have to be triggered by events. There needs to be an event source before your Lambda will ever be executed. And that function will then respond to the event and do something useful with it. And when you realize that, and you start to think about event-driven architecture and AWS, you realize that it just boils down to this. Something happens, and then we do something about it. And that's really it. Something happens, and we do something about it. Lambda was designed, built, and marketed from the beginning as a way to respond to events. And the rest of the serverless offerings in AWS fit this pattern. And when you buy into this serverless mindset, you will begin to architect your solutions in an event-driven way as well. So let's take a look at an example from our project. Obviously, we're dealing with car insurance here. You have a lot of documentation when it comes to your policy. And we had to build a document processing pipeline. Documents were going to be uploaded into S3, and we had to then do something about it. When that file is uploaded, it's placed onto an SQS queue, which in turn triggers a Lambda function. We as a team and as a company use CDK for managing our AWS infrastructure, and we were able to build this entire document processing pipeline in configuration rather than code. So we've got 25 lines of code here. It doesn't matter, it might be a little bit small to see, but in this code, we're creating an S3 bucket, our queue, a dead letter queue to go along with it, and our Lambda function. And there's some interesting parts as well. At line 23, you'll see that we're adding a notification from our S3 bucket to our SQS queue, but we're also filtering the events. So we're only interested on new documents being added to our bucket. On line 13, we're also configuring how our queue deals with retries and error handling as well. So a lot of things that you would have to write in your application code have been moved out into configuration, and you just let Amazon deal with it for you. So some of the benefits of this: we don't need to poll for changes. In my career, there's definitely been multiple times where I've built the same thing, a solution that watches for file system events, and particularly whenever FTP files are being uploaded via FTP. And it's always the same drawbacks. You need to ensure that your polling service never stops working, and for us, our document processing pipeline is critical to how all of Stroll works, so it needs to be very resilient. You need to determine the best intervals whenever you're polling for files and fetching updates. You need to ensure that you don't process a file that's only been partially uploaded, and you need to come up with some clever solutions on how not to process the same file twice. So I know for a fact I've built that multiple times in my career. But with S3, you simply subscribe to events on your bucket and just let AWS tell you when a new file has been uploaded. This greatly reduces the complexity of this workflow, and you can instead focus on delivering new features relating to those actual documents rather than worrying about getting those documents into the right place. The next benefit, and this is sort of like a benefit with serverless in general, your function only gets executed when it needs to. If there's no documents being uploaded, or there's documents that are just being updated, there's no cost. The Lambda function doesn't get triggered, it doesn't cost any money, It's as simple as that. That's an easy sell to your customers. And lastly, it provides scalability and extensibility. It's a really good idea to have these events go into some kind of queue first, like SQS. It adds in a layer of resiliency where the events will not be lost if there was ever any issues trying to process them. If you continually retry the events and it never recovers, then those events will put onto a dead letter queue and you can process them in whatever way you see fit. Building that kind of behavior ourselves would have taken so much time away from delivering real value to the platform, and it would never have been as robust as what AWS built for us. This also makes the workflow more extensible, and this is just event-driven computing. Other actions can respond to the same events, and they can be totally isolated from one another and do different things. However, as we adopted this event-driven approach, one issue became apparent for us, and that was observability. And this is a known downside to distributed systems in general, where it becomes harder to know what exactly is going on in your system at a given time. You can trace events through various log streams, and there's tools that help you do that. But if you haven't put any thought into how that actually works, you're going to have a very difficult time trying to figure out what's going on inside your system. And for us, we had issues. Our document processing pipeline was so important that it started to do too much. We needed to decompose it even further, or run the risk of having another Lambda lith of our own. But the more we decompose it, the harder things become to observe. And that brings us to step functions. Now, step functions were introduced to our team by my colleague Olin, who was supposed to be here today, but he's just welcomed his third child into the world. So I think he's got a pretty good excuse for not being here today. But what I'm going to try my best to do is sell it to you the way he sold it to us. He's our step functions guy, and I'm going to take on that responsibility today. So what are step functions? They're a visual workflow service that helps developers use AWS services to build distributed applications, automate processes, and orchestrate microservices. And for us, what we use from that marketing material is we use step functions as a way to orchestrate our serverless workflows. Rather than having to dive into the Lambda code to work out what exactly happens after this function is executed, you can instead use step function state machines to orchestrate that flow for you. Each step in a state machine manages the input, output, error handling, and retries, so that we as developers can focus on delivering features for the platform instead. So here we have a state machine, and it's called in AWS. Now, I have an elderly gentleman who works at Instill who informed me that state machines are not a new concept. And I just want to get that clear. I'm not saying AWS invented state machines. This is just what they call this visual workflow you can see behind me. You build this up in what's called the Visual Workflow Studio. So yes, it's a GUI that you log into AWS console to build up. Or you can write them in CDK as well. So you can write them in TypeScript if you really wanted to. But as a team, we recommend that you use the Visual Workflow Studio instead. It really helps you to see the benefit of step functions, and really you're missing out if you try and write these in code. There's no point trying to use a low-code tool and then write code to generate that. Each step in a workflow is called a state, and a state can simply perform various actions. Invoke a Lambda function, call an AWS API directly. You can have choice statements, you can iterate over arrays. And we use our state machines to orchestrate our flows between various Lambda functions. So this enables us to quickly and easily debug flows of events through the application. So what we see behind us, this is a screenshot from production. And this is what happens when a customer requests a printed copy of their documents. So we're a digital-first platform, but because of compliance reasons, customers still need to be able to get a printed version if they really want them. And this is what happens when they click that button. It executes this step function. This step function makes various calls to a third-party API, which deals with printing and posting out those documents. So each of these little boxes you see with the orange Lambda icon is an individual Lambda function that can be retried and backed off in case of a failure. And each one's configurable. So different Lambdas are going to fail for different reasons, and sometimes those failures might be okay, and you want it to retry after a certain period of time. You can configure each of them individually in a state machine. There's one really interesting part of this particular step function as well, is that once we send the request out to our third party, we want to wait for some feedback as to when that document has actually been posted. So we can then update the customer with an email saying, by the way, your policy documents are on the way. And the step function execution will wait until we get that callback, or until we get the webhook execution from the third party. So something that would have been really complicated to build, you'd have to maintain that state, probably in a table somewhere, and know exactly what had happened for a given document print request. Instead, the step function service does that for you. So this is a screenshot of the execution history of that step function that I just showed you. And for each execution, each row is a single execution of that entire state machine. And you can see that it's really easy to know, did everything work okay, or did something go wrong? And you can also then add your own alerting for whenever you get a failed document print request. So you can see that we've got a few failures here, so let's click through and see what went wrong. So once you click through, in the console you will see a visual representation of what that execution looked like. And for this, we can see that it failed creating a mailing request, that orange box. That was a Lambda call that failed for whatever reason. And you can then click that orange box, and it'll take you to that exact Lambda invocation. You don't have to go search. You don't have to go find an ID, search through CloudWatch logs and try and find that invocation. You just click through and it takes you right there. And this is really valuable when you're trying to support an application that runs 24/7. If you get a call in the middle of the night that something has gone down, you'll be very thankful for step functions at that moment in time, and so will whoever is in your house at that time as well. Another great feature with step functions, although it's still quite limited, is that it has its own way of doing direct service integrations as well. So if any of these Lambda functions that we have on here were simply just writing to a DynamoDB table, that Lambda function can be deleted, and you can just replace that with a direct call to the database instead. If you're writing glue code on AWS, try a direct integration instead. If you're writing a Lambda function that only takes data and puts it into DynamoDB, it's most likely there's a way where you can just do that without needing any code and just configure it instead, allowing you to move faster and focus on delivering value to your customer instead. Now, keeping myself honest here, what are the downsides of step functions? And the big one is the developer experience. It has a really good visual workflow studio, but you lose some safety when you get into working with code. We use TypeScript, like I said. We have interfaces to represent all our events. Like Eamon said earlier, we're following his best practices. And if you were to go and refactor one of your interfaces, the tooling isn't there yet to know that that's going to make a breaking change to a step function. So that's knowledge that you as a developer need to keep in your head, and that's a bad thing, because when new people join your team, they're going to have to pick up that knowledge as well, and it's easy for them to make a mistake. Now, we rely heavily on integration testing for our step functions to take care of that for us, but still, it's much nicer when you can use the compiler to make those decisions for you instead. The second one, and this happened to us, you can decompose into too many Lambda functions. It's very tempting to use all of the control flow statements inside the state machine, but sometimes an if statement inside your Lambda code is more than enough. You can put too much business logic into your workflow rather than being strict and using it only for doing orchestration between your different functions. There's also these things called built-in intrinsic functions. And really, they're just a way to manipulate the inputs. As data is moving from state to state, you can manipulate it. You can split a string into an array, things like that, things that we do day to day in our code. But they're still very limited. And as we try and use more direct integrations in AWS, we find that it's actually the intrinsic functions that hold us back rather than the integrations with the various services. We can't massage our data into the correct format. And you could just write a Lambda function to do that for you. But if you're going to that effort of building a Lambda function and you're incurring that cold start penalty, you might as well just use that Lambda function to make the database call for you, for example. So hopefully you've found this tour through our serverless journey useful. Like I said, this project has been really interesting to work on. I've definitely bought into the serverless stuff. When I started the project, I sort of was like, this could be a container, and it could have been, but now it definitely couldn't. Now we get so much more value out of the managed services in AWS. Anybody got any questions? All right, well, thank you.
Thank you so much, Matthew. In the next 15 minutes, we're going to have Dan Callahan coming on, and he's going to be discussing WebAssembly and looking at WebAssembly in production with an emphasis on security. So we'll see you back in about 15 minutes.
So I'm Russell Beggs. I'm the VP of Engineering for ESO. I look after all our engineering teams at ESO, and our company is very much focused on making a difference. Our mission is to improve the health and safety of our communities using the power of data. What that really means is that we write a lot of software that paramedics, firefighters, and hospital staff use to track what's going on and to help create the data, track the data, and provide actionable insights to improve the quality of healthcare that's provided to people. So I'm super excited about NIDC. Early in my career, I moved out to Australia, and I got to see what an engineering community looked like out there. And when I came back, we didn't really have much of one. It was a bit of a fledgling. And it's been fantastic to see NIDC grow and grow year on year. Even with the pandemic, we still saw a lot of participation, albeit remote. So I'm really excited to see us all get back together in person, to see more of the talks, the technical talks that people are giving, to see so many different things that are happening, and to hear from management and leadership and psychology of delivery as well. So super pumped to be back in person after such a long time being apart. We've got a lot going on in the fire space, but one that's particularly close to my heart here in Belfast is around patient registry. So you have stroke registries, trauma registries that really specialise in the care that they provide to patients. So if I give one example, a few years ago we recognised that there was a disparity between what paramedics were finding in the field and the hospitals were finding when it came to strokes. And there was about 50% chance that a paramedic would find that you had a stroke. And when we looked at the data and the correlation, the trends, we found two key things: ground level falls and diabetics. And when you look at that information, you publish insights on it. What we've seen in the last couple of years is that the detection rates have gone right up, and that's literally tens of thousands of lives that have been improved by that. So we've already done that. I'm really excited about how much more we'll be able to do now that we move further into that registry space.
That's what I should go for. And then I got laid off, but still like the Vans.
How long have you been over in NI for?
5 years. So yeah, moved over here, had 2 kids here. Oh, mic's on.
Did your partner from here?
No, we're both Americans, but I had dual citizenship and realized if the kids were born here, they would get but they get the American, British, and Irish passports.
Oh, triple.
So the triple threat. No, it's a pretty good deal. We quite enjoy being in Belfast, but.
Yeah, I have a few American friends who come over here like to study and then just stay because they're like, well, why not?
I mean, I don't want to speak too ill of America, but like between healthcare and gun violence, like I wouldn't want to send my kid to a school that has to practice active shooter drills.
You know, I'm coming here when there was an actual Civil War for 30 years, safer.
Right, yeah. It's like we have
World's messed up.
honest to God paramilitaries, and yet the gun violence is less.
Yeah, I know.
The world is crazy. Let's see. Fully remote, yeah. I've been fully remote for 12 years in various jobs now, so. It's I don't know, COVID remote work is not normal remote work. Try again. Are these being recorded at all?
Yeah, take a wee wave. See that green light up there? Very, very bottom. It's flashing at you.
Sweet.
That's it there.
Do I need to stay at the lectern for that, do you know, or can I be outside?
Do you have a clicker?
I do.
Right.
Sometimes it doesn't work though, so I may be back here. I can also just stay at the podium, that's fine too. Yeah. I think so. Yep, I've got, let's see, what are my displays doing? They're mirroring. Maybe a wee bit.
everybody. Good afternoon. We're almost there. I am delighted to introduce Dan Callahan to the stage. Dan will be discussing WebAssembly. He is also the engineer manager for a really cool startup called Suborbital. If I got that correct. At the end of Dan's talk today, if you do want to ask any questions, can I just please ask for you to come to one of the mics or look for Glenn in the back and he can pass you over a mic as we are live recording. Thank you.
Thank you so much. So, I'm here to talk about extending SaaS applications with WebAssembly. As mentioned, my name is Dan. You can find me on Twitter as Callahad. I also have scheduled a tweet that has some links to trailheads if you're interested in the things I'm talking about in this talk. A friend of mine recently tweeted that learning what to learn, but not actually learning the thing, is his favorite part of conferences. So in that vein, I'm not going to try to actually teach you WebAssembly, but I'm going to try to convince you that it's worth investing some time the rest of the weekend, later on this month, really digging in and kind of trying to understand what WebAssembly means for the applications you're building. The thesis of this talk is very simple. If you are building software as a service, you are building software that you are going to run on behalf of users, you are going to have to find a way to run code that those users give you. And I'm pretty convinced that whatever solution you find to this is going to involve WebAssembly at its core. Let's go back a couple weeks. I was reading Postman Pig to my kids. And in Postman Pig, he visits the Daily Sun, the Busytown newspaper. And this was published in 1978. And the professions that they highlight, you've got the press workers, you've got the editor, and you've got the linotype operator. These machines are so cool. So before the linotype machines, which were invented in the 1800s, movable type required literally picking up each individual character, putting them backwards and upside down on a composing stick, locking it all in place, and then printing from that. Very, very laborious, very error-prone. Don't want to do it. We have an industrial revolution. We have the linotype machine. We can mechanize that. And what the linotype machine did is it took lead ingots, sitting there at the foot of this operator, just a big old pile of lead, and it would cast an entire line of type, linotype, into a single lead slug on demand. So instead of working character by character by character, you could work line by line by line. So if you go on Wikipedia, you see a photo of the keyboard that these operators worked at, and every time they pressed a button, a brass matrix would drop down into place that had an impression for that character. And when you ended up filling out your line, you press another lever, and molten lead flows in and casts the entire line into a lead slug that you could work with. This is why when you're working on a content management system, they call the end of the URL a slug. It ties back to the same publishing history of actually casting literal slugs of metal. But that wasn't what I found interesting about this picture. Because over to the right of the machine is a white box that says the Selectromatic Star Quadr. And it has 3 buttons for right, center, and left. What is that? So I go looking, and I find out that there's a star quadr to meet every white space need. I'm not sure why white space is in scare quotes, but so it is. What the linotype machine was built for was for newspaper publishing, and by default it would justify text. So it would insert kind of expandable, physically expandable spaces so the line would go to the width of the column you're working with. But if you wanted things to be centered or left flush or right flush, you had to go in and manually do that sizing. Some company figured out a way to mechanize that, hence the star quadr. And this thing, you could set it to center, left, right justification, and when you finish your line, it would automatically throw in these kind of the quads, the blank parts of the mold, to pad out your line as needed. And I think there's a lot of what we want out of our software embodied in the fact that this physical third-party add-on exists. We want our tools to be useful out of the box, but no tool can serve every need. And so when I run into a problem that I want to fix, or if somebody else has an idea to make something automated or easier, they should be able to literally bolt on and modify the tool in a way that makes it work better for them. And we had this, we still have this with local software, right? If you go to the Visual Studio Code homepage, they show you a screenshot, and there's not a whole lot of code in the screenshot. Instead, it's a screenshot, literally, of the extension marketplace.
Same thing with browsers. Would you use a browser without an ad blocker or a password manager add-on? And this goes all the way back to the beginning of desktop software, local software. The ability for you as the user to modify the software to fit your needs. And that worked out great because when we were running software locally, it was on your computer and it was your data. And if you did something, installed a plugin, wrote some code that did something bad, that's your problem. We lost that when we went to the cloud because everything got inverted. Suddenly it's their computer. Suddenly it's not just your data in that database. Suddenly if you break something, it's everybody's problem. And that's what took arbitrary code execution from being a feature to being a vulnerability. Because suddenly we don't own the environment anymore. And so you have to take extensibility away. That's what SAS took from us. But we didn't take extensibility all the way away because software needs to be extensible. Software needs to communicate with other people, with other systems to be useful. Jamie Zawinski, 20 years ago, coined Zawinski's law. Every program attempts to expand until it can read mail. Those programs which cannot so expand are replaced by those which can. He clarified later, he means not that things get bloated, but that the more time you spend in a tool, the more you want it to do. So your text editor becomes an IDE, becomes an operating system. Your browser becomes an application platform, becomes an operating system. So we're not going to get rid of extensibility altogether when we move to SAS, but we're instead going to give you watered down extensibility. We're going to give you APIs and webhooks. And APIs and webhooks are great because you set up your own server that you can break and it doesn't cause anybody else any grief. And their server, the SAS server, can go and send you a notification when an event happens. And you can talk back to it with an API. And this works reasonably well, except for the fact that I need another server now. When I could, in the local software era, just write some code and be responsible for the consequences, now I have to go and learn an entirely new, highly paid profession to go and administer and maintain and secure a server. That barrier is too high. But we know that, so we build bespoke integrations. You sign up for a service, and of course, a couple clicks later, it will integrate with GitHub, or it will integrate with Slack. But what if you're using GitLab or Teams? What if the things you want to do aren't things that the software developer has already created a feature for you? What if you just want to write some code? So when we think about extensibility, we kind of have these three cases, the APIs, the webhooks, the bespoke integrations. But there's this fourth category of programmability that we have lost when you go to the web. But we haven't lost it entirely. So Docker has an API where it'll tell you how many times a given image has been downloaded. And I was kind of curious how popular a couple of Docker images were. But they don't give you a time series. You have to go and construct that yourself. And so suddenly I'm confronted with this problem of I've got a JSON blob. I can go and hit that every day, and I want to pull out this one value from it, and I want to stick it in a spreadsheet. How am I going to automate that? My laptop's not going to be on every day at that time, or not necessarily going to have network access. I don't want to go set up a server on DigitalOcean. Like, this is a pain. But I don't have to, because in Google Sheets, I can open up the extension menu, go to App Script, I can slap in some JavaScript, I can tell Google to run it every day, and I'm done. They worry about running the code for me, and they run it in their infrastructure. They run it right near my data. That application, Google Sheets, is programmable. That's what I want. That's what I used to have with local software, but now I can get it in the cloud in some places. A more familiar version of this might be GitHub Actions. GitHub Actions can trigger arbitrary code on arbitrary platforms. Like you can run a Windows VM, a Linux VM, a macOS VM, in response to literally a couple of hundred different flavors of events on the GitHub platform. Someone pushes a commit, opens a pull request, changes a label on an issue. You can run completely custom code in response to that. You can run custom code on timers. You can completely program GitHub like it was a platform. I saw a blog by Simon Wilson where he said, I figured out a GitHub action pattern to keep track of a file published somewhere on the internet and automatically open a new issue anytime the content of that file changes. So for example, he's like, hey, gzip.py was updated, here's the diff. And that issue got opened on his repo by the little script he wrote. And that script was run by GitHub. He didn't have to, and this is kind of the story of serverless, right? But it's serverless inside the application you're working with. GitHub's providing the compute. And if the thing that you're trying to do is sufficiently common, Again, there's a marketplace where you can go out and you can find reusable snippets of code, reusable behaviors, and you can program your application, your SaaS application, you can program the GitHub platform to do what you need. This is great for you as the user because it means that you're not constrained by what the SaaS application says you can do. It's great for GitHub because they don't have to build every feature. They can give you the tools to empower you to do it yourself. So programmability is here in the cloud, but it's mainly in these hyperscalers, Google and Amazon and Facebook and whatever else. I don't know if Facebook has any platforms that do this, but the commonality is that all these big companies have more money in servers than God. GitHub's owned by Microsoft, which runs Azure, whose whole point is to have millions and millions of cores available at the drop of a hat. And so GitHub can afford to say, sure, every time something happens, we'll let you run a 16 gig, 2-core, couple of gigabytes or tens of gigabytes of hard drive space VM. Go for it. We've got tons of those just out in the shed. But you're not GitHub. You're not Microsoft. You're not Google. So when you're building a SaaS application and you want to empower your users to have that same degree of programmability, what are you going to do? I mean, you're going to start with APIs and webhooks because that's kind of table stakes. But the thing is, the experience that people are having with things like GitHub Actions is going to change their expectations and change what the barrier is to software being considered capable. And you have the answer literally in your pocket. If you reach into your pocket right now, you will find a phone, and that phone has a web browser. And hey, you know what runs untrusted code all day long? A web browser. You go to a website, JavaScript flows down. You've never seen that before, your phone's never seen that before, and it's going to execute it, and it's going to do it in a safe manner. Because the whole reason we've been trying to isolate things into VMs or put them on your own server is to limit that blast radius and limit the impact of arbitrary code execution. Like, what happens if the wrong thing gets run? Web browsers have been doing this forever, and they're efficient. My car, for God knows why, has a browser. Apple Watch has a browser. You can run web content everywhere. The web's a universal platform, and you can do it safely. Web technology is, I mean, you think about what browsers have access to. This is one of the most kind of real-world, battle-hardened execution environments out there. So let's take that. Let's use that. At the core of every web browser is a JavaScript runtime. And that JavaScript runtime on its own, JavaScript, the language, doesn't know anything about how to act on the outside world. It can do math, it can create objects, it can create strings, can't do anything else. What you have to do is you have to provide APIs from the host environment to give it capabilities to do I/O. So things like console.log or the Canvas APIs or whatever else. These APIs are provided by the browser, by the runtime environment, to bridge that gap between computation and the outside world. And they don't just blindly grant any permission that's asked. The browser intermediates all of those requests, and the APIs are designed in a way such that the browser can intermediate them. So when you're writing JavaScript for the browser and you say, I want to get user media, I want to get access to the camera and the microphone, the browser will prompt you and say, hey, do you want to allow this? And the APIs are shaped and the implementations are designed such that you, the user, then have a chance to block or allow that specific access. All of the APIs are designed around this intermediation. And so that's the web platform. For 2 decades, we had HTML, CSS, and JavaScript. We had data, presentation, logic. And then Ryan Dahl came along and was like, hey, what if I just get rid of the browser? What if I take the JavaScript engine out and run that on its own? And that's Node.js. And that has had a huge impact on how we build software, because JavaScript's a good language, and it's fast, and it's useful, and it fits a lot of the paradigms that we're trying to work with when we're building network services. The problem is, once you take away the browser, how do you get I/O into the JavaScript engine? So Node has to have its own standard library, and other JavaScript runtimes like Dino have to have their own standard library that define what are the names of the functions, what can they do, what are the permission models around them. So that's the browser ecosystem. On the server side, you can choose any language you want, right? But if you're in the browser, you just have JavaScript. There have been attempts to expand this, to say, well, let's add Dart, or let's add Python, or let's add Scheme to the browser, because no one language is the best tool for every job. But then you end up in this kind of asymptotic thing where like, all right, no 2 languages are the best tool for every job, no 3 languages. What about languages that haven't been invented yet? So how do we take the browser runtime, the browser ecosystem, and give it access to every programming language like we do have when we're on the server side? Well, the way we do this on the server side, the way we do this on desktop, is that your programming languages, your runtime environments, can target your machine code, like the actual physical CPU architecture and operating system you're running, right? You can compile to whatever else, and then you've got code and you can run. We can't do that on the web, though, because the web has to be universal. Like, how awful would it be if Apple comes out with the Apple Silicon Macs and you go open up Gmail in Safari and Google's like, we haven't recompiled gmail.com for ARM yet. Can't do it. So we can't go all the way to machine code. How do we get every language into the web ecosystem? We make a thin little abstraction over machine code. And that's what WebAssembly is. We looked at ARM and Intel and MIPS and RISC-V, all these various CPU architectures, and we said, what's the commonality here? What's the very least common denominator that we could build to act as a compilation target, just like any other CPU architecture? And then we can leave it to a runtime to take that WebAssembly machine code, the virtual machine code, the abstract machine code, and convert it into real machine code. So you can take a compiled WebAssembly blob, a binary blob, in WASM format, hand it off to a device, and if that device has a web runtime in it, be it a browser or a node or whatever else, that will then translate that code safely and securely, very, very quickly, into native code for whatever processor you happen to be on. And this has been in browsers for 5 years, like literally 5 years as of this month. Every major browser ships support for WebAssembly. So what have we done with it? Well, if you can write a compiler that targets ARM and targets Intel, you can also write a compiler that targets WebAssembly. And then you can do things like take the, this is Unity engine, run it in the browser. You can do the Unreal Engine in the browser. You can compile AutoCAD to the browser. And this was kind of the genre of the demos that we got in those first couple of years, is just people taking existing software and saying, all right, I'll just recompile it and I'll port it at WebAssembly, and now the browser will take it that last step to machine code and blah, 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 and now it runs in the browser. This isn't super useful for a lot of things, except software preservation is actually really interesting. The Internet Archive has gone and compiled DOSBox to WebAssembly. And so you can go and boot up Windows in your browser, and then you can run Netscape in Windows in your browser. And I can give you a link to this, and it will just work. If you go to the Internet Archive software archive, they're just compiling emulators to WebAssembly, and like you can just run the software in your browser, and it's great. I'll go ahead and, can I fast forward here? No? Anyways, you get the idea. That's in a browser. But it's not just that. We've started seeing people say, all right, how do I add this incrementally? Instead of just taking existing desktop software and porting it to the web, how do I start using this incrementally to enhance the software I'm already building? Figma is a big pile of C++ that happens to be compiled to WebAssembly and runs in your browser. There's a startup called StackBlitz. Their whole story is run the back end and the front end. They will run an entire Node.js stack, including databases. You can run Postgres in your browser because they can compile it to WebAssembly, and that's really cool. So now the web stack isn't just HTML, CSS, and JavaScript, it's those plus WebAssembly. But it's not just those plus WebAssembly, it's those plus a compilation target which can accept any language, including JavaScript. You can run JavaScript in WebAssembly, and there are reasons to do that that are awful. But good, you can do it. You can run any language, virtually any language you can think of has a way to run in WebAssembly. Because, hey, it can run on native, right? Like, you just change the compilation target. So we talked about how the web started with just HTML, CSS, JavaScript. And then we got rid of the browser, and then we had Node. Well, now the JavaScript engines also have a WebAssembly runtime, and that's kind of cool. But that begs the question, what if we get rid of the JavaScript runtime? And we might want to do that because WebAssembly is really, really small. It's meant to mimic machine code. So you don't need, like, WebAssembly just does math. Like, it doesn't know what an object is. It doesn't know what a string is. It just knows integers and floats and 128-bit packed vectors. But, like, that's it. It can do math, and it's tiny, and you can take a runtime spend just a little bit of time porting it to the back end, and suddenly you get this really, really efficient, really, really fast portable runtime. But okay, how, what, why, who? There's an organization called the Bytecode Alliance, which, there we go, which is a consortium of a couple dozen companies that are working in the space of trying to say, well, all right, WebAssembly was born out of the browser. We are not. Yeah, you're missing the Bytecode Alliance logo. That's fine. I can talk through that. I don't know why the signal is bad. Let me switch HDMI real quick. Anyway, so the Bytecode Alliance is a bunch of folks trying to figure out what can we do to run WebAssembly in the back end. I've got nothing. It went dark over there too. All right, sorry about that. And they're facing the same problem that Node had when it jettisoned the browser, which is you have to define that system interface, that API. And what they've done is they've started work on two really important projects. One is WASI, the WebAssembly System Interface. This is what defines the APIs for how do you open a file, how do you listen on a network socket, how do you get the current system's time. They're also working on a runtime called WASMtime, which is an implementation of this server-side WebAssembly idea. And WASMtime is really great because just last month it went to 1.0. It's production ready. WASI is still in the works, which is one of the cautions with WebAssembly is that we have a production grade runtime. What we don't have is that system interface yet. So if you're doing computation, if you don't need to interact with the outside world that much, or if you're comfortable with the fact that those APIs may change, you can go and use this in production today. And people are. So Shopify has been in production with WASMtime for over a year. Fastly helped co-develop WASMtime. They've been in production for over half a year. Previously, they were doing WebAssembly for their compute at Edge using an in-house runtime called Lucet. They've now switched to the open source WASMtime project. Microsoft has been offering WASM plus WASI instances on Azure for a year. So if you want to run WebAssembly in the server, you can do it now, and it works. And what we've done is we've taken the experience looking at the Node standard library, looking at the browser security model, and we've tried to figure out what shape do these APIs need to have so that they're secure by default, so that they're safe, just as safe as running code in the browser. So that runtime can kind of intermediate access. And the direction that we're taking is the idea of a capability-based API. So there is no ability for a WebAssembly module, unlike on a traditional like raw hardware, where you can just say like, I just want to open this file and here's a name. WebAssembly can't do that. WebAssembly can't gain access to a resource using the WASI interface unless that interface has already kind of pre-opened it and given to that module access to that resource. For a bit of an idea of what that looks like, I wrote a little hello world thing in Rust, and I'm going to go cargo build release. I get a binary out of it. And so what I get when I compile this thing in Rust is a file that is designed to run on my operating system on my CPU architecture. So ARM Darwin, which is the macOS code name. I can give that to anyone that has the same hardware and it'll work for them, but I can't give it to somebody that's using Windows or somebody that's using Linux on Intel. It's not going to work. But on my machine I can run it and it works. If I want to build it for WebAssembly, there's a Cargo plugin. Cargo is the Rust build toolchain called Cargo WASI. So I can say Cargo WASI build, and I'll get out a .wasm file. And that .wasm file is that kind of abstract machine code that is completely universal and completely portable. I can give that to anyone, and no matter what architecture you're on, if you have a WebAssembly runtime, you can convert it into machine code and execute it. But hello world, how do you do hello world? Well, hello world, you have to open a file descriptor, you have to print to standard output like that. That has some capabilities in it, so we're targeting WASI. But if I try to run this, I also get an error saying, well, wait a second. Failed to find a pre-opened file descriptor through which my SSH key can be opened. Why is hello world trying to access my SSH key? Well, maybe one of my dependencies has become malicious. And because by default, WASM modules are denied by default, you have to proactively grant them access to resources. If I didn't grant it access to that part of my home directory, If it tries to go and do any funny business, it's going to get stopped. On the contrary, if I wanted to grant it access, I could say --dir, you can map this, and it'll then be able to go in and write there. But the whole thing is like, these APIs are designed to be very easily and humanely sandboxable and manageable, and they're designed to be safe by default. Because this is a real problem. Every couple months, yet another malicious package found in NPM targeting cryptocurrency wallets, or in PyPI, or in Ruby gems. The software security, or software supply chain security is a really hard problem because in the traditional server-side model, traditional computing model, when you run a program, it has the same privileges that you as the user running it have. And so if you could delete your Bitcoin wallet, so could a bad library. Following the invasion of Ukraine, there was a node module, node IPC, that at a random interval, when that dependency was invoked, would try to geolocate the IP address of the server it was running on. And if that resolved to Belarus or Russia, it would go and delete a bunch of files. And it could do that because our runtimes, like the node runtime by default, doesn't enforce this sort of deny by default access model that is built into the core design of the WASI system interface. So that's why you might want WebAssembly on the server side, right? Like, because on the server side, I could run Rust, I could run Python, I can already do these things. Why would I want to wrap them up in WebAssembly? Well, that gives me a safe sandbox runtime. And that safe sandbox runtime is what gives me the ability to run untrusted code that are things like my users might hand to me. That's the key to this. We're taking browser technology, which has already been through hell and back trying to be compromised, and we are applying it to the server side. It also gives me a universal binary format, so I can take that single WASM module and I can run it on Intel. I can run it on ARM. If I hear that I get better performance per watt or price per performance out of a Graviton instance on AWS, fine, go and deploy there. Same code will work. That's why I think WebAssembly is going to be at the core of this whole idea of getting your users to be able to write code. The trick is, like I said, like the runtime is ready, the system interface is still in the works. WebAssembly has some limitations. It can only address 4 gigabytes of memory by default. You don't have multi-threading or parallelism yet. If you're doing computation, if you're doing basic functions, like it's ready. If you want to go out and do more stuff with networking or file access, it might be a little dicier right now. But I'm convinced it'll get there because I think the value here is overwhelming. You think about the isolation of a virtual machine. Those images tend to be gigabytes in size, and so we have containers instead. And containers don't provide the same security guarantees, but they're smaller and more agile. They're hundreds of megabytes. A WebAssembly module will tend to be a couple megs, maybe a dozen megs, much smaller, much faster to start. The Bytecode Alliance folks have done an experiment of compiling Firefox's JavaScript engine, SpiderMonkey, into WebAssembly, and they can instantiate that in single-digit microseconds. And so this thing can run fast. It can run as fast as any native code, more or less, but it can do it in a way that's sandboxed and safe. How this might look in practice. I work for a startup that's trying to kind of commoditize this and like say, hey, you can just drop this in and let your users write code, but we're in private beta. I don't have anything to sell you other than the idea. Open source things will also do this. But one of our customers, Avenue, does alerting, where they connect to your data warehouse, you write SQL, and then they will alert if certain conditions are met, like this returned a weird number of results or whatever. But encoding business logic in SQL is really hard. And so they've provided some triggers at the end, so you can say, like, here's a simple query, but if you see this threshold exceed, go in and fire an alert. But even that, they can't anticipate every need. So they want to let their users write code. And so they put an editor in where you can just write some JavaScript. That gets compiled to WebAssembly, and they can run that right there in their infrastructure, where it's close to the data, where it's high performance, where it's safe. And what this ends up doing, giving your users the ability to just slap in code inside your app and change its behavior, it's really useful, but you also get fun things like, this is a screenshot, we should have an alert that randomly fires and tells people to be real on Slack. And then a few minutes later, it's time to be real. You have 2 minutes to post what you're working on. Kind of a parody of that, the social media app. This was only built because one of their devs was like, oh, well, I have a place I can just slap some custom code, and now our platform does this other thing. That's what we got to work for. We got to work for enabling our users, if we're building SaaS products, enabling our users to write custom functionality, custom logic. WebAssembly is going to do it. Here are your trailheads. One, like I said, I'm Calahad on Twitter. I've tweeted out links to these. The Bytecode Alliance is where you're going to find information about WASI and WASM time. There is also on Monday in Detroit, Cloud Native WASM Day. This is part of KubeCon North America, hosted by the Cloud Native Computing Foundation. You're going to see a whole day of content of the people working in this space of trying to bring WebAssembly from the browser into the server. Fair amount of announcements, fair amount of like just what is the state of the world here. That's going to be your really detailed update on the status quo. I've got stickers. I'm happy to stick around. I'm happy to answer questions, but I do believe my time is up. So if you have questions, meet me at the door. Thank you so much.
Thank you so much, Dan. Okay, in about 15 minutes, we're going to have Mark Allen, who is one of the organisers for the event today, and obviously a massive NI Tech community champion. So it'd be great for everybody to join us in here whilst he discusses adopting React and Redux in about 15 minutes. Okay.
So my name's Darren Abel, so I'm the Director of Engineering at Apex FinTech Solutions. So I joined the company 2.5 years ago. My role is really to supervise all the technology projects that we do in Belfast. Apex FinTech Solutions was formed in 2012 by Peak 6. So Peak 6 is an investment company, and Apex is essentially the technology company that is behind the trading solutions that we build for our customers. So the whole mission of Apex is really to democratize trading. They're one of the big disruptors in the industry. So it's because of Apex that people now can actually trade through their mobile phones. A lot of the work that we do, we can't disclose. It's under the radar, so to speak. We are really looking forward to, we have one of our other companies is speaking on it as well, Evil Geniuses. So we're looking forward to hearing what they've got to say, and as well as one of our own managers, Niall Haslam, he's also speaking at the conference. So we're really excited about those and to see what else other people are doing in Belfast. And like I say, the tech community in Belfast is huge, and we can't wait for the conference. Yeah, so obviously we were given the opportunity to sponsor NIDC, we jumped at it. So NIDC is obviously a conference for developers, by developers. So one of the big things for us in Belfast is really getting our brand out there. We were previously known as Peak 6, and now we're known as Apex, so we're a subsidiary of Peak 6. So it's making sure that we get that out to our target audience, who are developers, because we're a technology company. And really then, obviously, during COVID, for instance, everybody's been at home, so we recognize how important it is to have events like this where we get everybody together. So that's why we kind of jumped at the chance and the opportunity then to sponsor NIDC, and we're really looking forward to the conference. So over the past 2.5 years, we've grown to 98 people. We're continuing to grow and continuing to hire in technology and operations. So if you're interested in joining us, please get in touch or speak to Clark and Robin in our stand.
It's me. I'm getting the crowd hyped up. Hello everybody and welcome to our final talk today in Hall 1. It has been a really amazing day in this hall if you've been able to join us with it, with some amazing talks. And I'm absolutely delighted that our final talk today in this hall is with Mark Allen. Most of you will know Mark as an NI tech community champion. He is always so engaging both on Twitter and Slack and helping out startups, Coder Dojo. There's quite a lot of job titles we could probably give Mark, but he's now known as a seasoned software engineer at our Diamond sponsor GearSet. And in his chat today, he's going to be talking about adopting React and Redux. After Mark's chat today, if you do want to ask any questions, could I just ask that you come to one of these mics or ask Glenn in the back there for a mic to be handed to you. So could we give it up for Mark Allen to come on stage, please?
Morning all. I see these are presumably the people who are actually here just to find out about the after party, and they may as well sit in the room. Yeah, so I'm just going to wear my GearSet hat for half an hour here rather than my NIDC hat. Basically, what I'm going to be talking about today is GearSet have been going through a process recently of moving from a JavaScript and knockout-based front end, which has been around for, well, presumably quite a long time if it's got knockout in it, through to a React and Redux-based front end. So we're in the migration process of that at the moment. So this is slightly different for me. Normally I come up in here and just talk about stuff that I know well, but this is more about what we're doing at the moment and the thoughts that we had while we were going through that process. If you went to Eamon's talk earlier, you'll have heard about the JavaScript to TypeScript bit, and this is the knockout to React and Redux bit. So if you want to know about the JavaScript to TypeScript, go and find the online one on the NIDC YouTube channel once it's been chopped up and published. Yep, nothing on there. That's me, and that's what we're talking about. So yeah, I'm just going to go through essentially where we were, or sort of a few months ago. Talk a bit about React and what that is for those of you who aren't that familiar with it. Then I'll talk about Redux and the way we've attempted to tame Redux, and then I'll have a wee chat about the lessons learned at the end of that. And hopefully after that there will be some questions and opinions, because certainly when I was talking to people about it at lunchtime, they were all ready to tell me all about how we shouldn't be using Redux at all and things like that. So hopefully there'll be a little bit of conversation can be had at the end of that. Right, so where we started was with Knockout, which if anybody's been around for a while, they might remember Knockout. It's a very simple but quite effective in its own way, framework. All it's really doing is two-way binding. So if you've got your text box on the screen in the browser, then what Knockout does is binds that to a string in what's called your view model. So a big pile of data which maps to what's on the screen. And anytime you type something in the text box, it will go into your string. And anytime you update the string, it will go into the text box. So essentially, your logic is just about updating that view model, updating that JavaScript, and then that automatically appears on the screen in whatever form. So pretty much, sort of something like that. So you go off, fetch your message, you put it into the view model. The view model has this observable thing, which is pretty much the same as the things you might use in Angular or reactive extensions or anything like that. But that, when you put it into the observable gets picked up by Knockout, and it goes and sticks it into whatever you bound that to in the user interface. And ditto, if you come back, then when you update that text box, that observable will update, and anything that's listening to that observable can then go off and do something. So it's nice, it works. We've been using it for years. In fact, the Azure portal, Microsoft Azure portal, actually still uses Knockout. They kind of cheated and hired the person who wrote the Knockout framework. But, it can be used to do things, but it's not great for when you start to grow larger, it's not terribly efficient working with the DOM, and two-way bindings, tend to bite you after a while, and if you're doing things at scale, then it can get a bit awkward. So, so we decided, and there's no community around it at all, of course, so we decided that we needed to move to something more modern. React is the obvious thing to move to for UI frameworks these days. I won't go into the UI, sort of the thing about Vue versus React and Angular here, but we chose React, and then so we went and looked at the state management and started working on that. So this is what React looks like. So have we got we've got that. So you've got your initial component here. So you've got your root level component, which may have subcomponents as well. And when you've got your component, you've got these things called hooks in the modern version, the more recent versions of React, and essentially they're just hooking into the life cycle of that component. So the points at which it's rendering or what have you. But essentially, what those the point about those hooks is they're going to update some sort of state of that component. That can either be local states that you're storing just within that component. It can be a context which will cover a whole tree of components, or in our case, it can be a Redux store, which is sort of more like an application-wide store of state. When that state updates, then the component gets that new state, re-renders, calls more hooks, and also goes off, checks what was on the screen before, what you want to be on the screen now, does an efficient diff in the background, and updates just what needs to be updated on the screen to get that going. The other thing that happens is that sort of when something happens in sort of on the screen, so when you click a button or something like that, you'll get a call back to here, and sort of you can then call another hook to update your state accordingly and get re-rendered again. You'll notice that there's lots of circular things in here. So the first thing to note here is that it's quite easy to get things that trigger things that trigger things that trigger things, and you end up getting into a bit of a confused state of rendering and rendering and rendering and rendering, which sometimes just shows up as a really slow UI, and sometimes shows up as everything not working anymore. But at the end of the day, it's just a fairly simple thing. So you've got your properties here which come in. So this is just a thing that renders a heading. So you pass in a heading to it. It prints out the heading on the screen, and then it's got a subcomponent here where we pass in another property with hello world. So if we add on to that the idea of state, then we've got this here. So this use state thing is one of those hooks I was talking about. So what we're using here is a thing that says that we've got a thing called message, which is a string. We know it's a string because we've set it to initial as its initial value, and then we're going to have a function called set message, which allows us to change that. And here we've got the button, so on click, on change message, calls through to here, and calls that set message. So that's that cycle going on there. The hook sets the local state, it fires back to the component, and the component will re-render with the new value of that message. If you want to go for context, you essentially create a context which contains whatever your data is. So in this case, it's just a string, but it could be a full list, a full object. It could contain functions as well. But the idea behind this is that we can pass in that we want this component here to have a theme context where we're going to have a dark context, and that will pass down through the toolbar here to the themed button, and we can just pull out the theme from the context there. If we wanted as well, there could be functions in that which would allow us, we could call through from here to update the context later on. So those are both fine. They're fairly simple state mechanisms, and some people actually do just use those for all their state management. But if you've got a large feature going on, so you've got sort of a big product, or an application, and you've got lots of features in it, and there's shared state which is going to go through a whole lot of components, trying to pass the state between the parent components and the child components and then back round to other components that might need that information as well, it gets really complex to manage all those flows. So what Redux does is to sit there, kind of detached from the components and store your state and use, make that state available to all the components that you've got rendered, set up in React. And the way it does that, basically you set up an initial state and pass that into Redux into a store. Specifically, you set it into a slice of store. We use something called the Redux toolkit, which is a fairly common thing that people use with Redux to make things a little simpler and more organized and patterns around it. But your feature, which is a slice of the overall Redux state, goes in there. And then you have these things called selectors, which select information out of the store, and so the component can use those to get the information it needs to display. Then when you do things, you can perform actions. So you basically got what are called actions, which are synchronous things, so things that you can just do straight off. And you've got thunks, which are asynchronous. So those are when you're going to have to go off and call an API or something like that, and you're going to have to wait for it to come back for a while. But what those both do is to do their thing, and then they feed into this thing called a reducer, which takes that information that you've got back and reduces it down into a new version of the state. So that reducer then gives you a new state, which comes back to here and can then be selected back into the component. And the final thing we've got going on here, using middleware, which is a way of plugging into Redux, you can do things like the observable pattern. So you can say, okay, and if this thing changes in the state, then also go off and do something and do another change in the state. So without having to go back to the view component, the UI component, to go and do things which are nothing to do with the UI and haven't been caused by the UI, then you can keep all your logic nicely, safely away from the user interface, which means that you don't have to do all that hooks thing and you don't end up with all those sort of cycles and things, basically all the bugs that happen, even if you're a relatively experienced React programmer using hooks. So the way that looks, you create a Redux store. So that's an application-wide thing. So we get a bit of middleware here. And you can see there, for our thing, we just got this one feature. So we're going to talk, the store is going to be watching our feature reducer for new versions of the store. So we create an initial state object to store whatever it is that is important to our application. So we just got a message here and a message ID and a loading indicator type thing. And what we can then do is set up these things called selectors. So we've got one here called loading selector, which is just going to pull out from the Redux state your feature's loading Boolean. What you can also do, as well as just pulling out those individual ones, is to combine selectors. So here, I've given an example where we want something to happen, based on either loading or message. So if we're not loading and the message is not oops, then we know that all's well. So we can pull that selector through as well if we wanted to have an all's well indicator back in the UI. So that we've set up the store, we've got the selectors, and the component can now pull that information from the selectors. So on the other side of it, when somebody clicks a button or whatever, then we've got these reducers. And these are the things that are coming through from the actions and thunks. So the way we do this with the Redux toolkit is to create the slice, which is effectively, which is the feature, and say what actions are going to be happening, what things are going to be happening. So here we've got a normal reducer, which is a synchronous action. So we've got one here called update message, and all that's going to do is to set the state message. If we're doing an asynchronous thing, so if we've got a thunk running, so we've got one here we're going to call fetch message. We get 3 of these. So we've got one that kicks off when it starts. So yeah, we can say when it's starting, so when it's pending and we haven't finished yet, then we can set the loading indicator to true. When it's finished and it's happy, we'll get a payload back from it, so we can set the loading indicator to false and set the message to whatever message it was we got back from an asynchronous API. And then if something went wrong, then we'll also get something through here. So we'll get an error state there, but we can say loading false and message equals oops. And that will then, that reducer then returns a new version of the state, which then goes around and fires through all the selectors and comes back to the UI. So the thunks are pretty much just normal asynchronous functions. Now, this is the nice thing about doing something like Redux, is that you don't have to worry about watching for things in the UI layer. I hate it when my UI and my logic get mixed up. I'm very keen on separation. And this is a nice way of doing an asynchronous thing and being able to handle all the stuff that happens, good or bad, out of that asynchronous thing without having to bother the UI about it. So, in this case, we're getting a promise, which will be, whatever comes, whatever we're going to return from this, which in our case is going to be what the message is. So we get the state, we get the next message ID out of the state, we call through to this API with that message ID, and with a bit of luck, we get a response back, which is, this next message. If that fails, then obviously that will go through and call that rejected reducer, but normally we'll hope it will call the fulfilled reducer. And while it's in process, it will have called the, the other one, the pending reducer. And finally, on the middleware side, you can largely ignore most of this, but what we can do here is we can watch the message that's in the state, and if it changes, then we can do this thing, just something I made up called update our subtext. So we can take that message, fire it off to the server and say, okay, what's the subtext going to be for this message, and return that back. So hopefully that gives you an idea. So this is largely what we've settled on for the way we're doing things in GearSet. Now, it's certainly not the one true way of doing React, or it's not the one true way of doing store, but it's something that works well for us. Now, as I was saying, there are people who have opinions on sort of doing everything the pure React way or using other libraries. But part of the point of this is this is something we've taken Redux, which is powerful and can be quite scary to people, but we've managed to get it down to something which is actually, to us, easier than dealing with all the hooks and stuff. So, some of the lessons we've learned here. Hooks at the start seem easy. If you go and look at the React tutorials, then you'll see all these lovely little state management things and effect management and all the rest of it. And it all looks simple enough. But when you start to have lots of hooks in a real application and lots of things happening and lots of async stuff going on and things coming in and out and this depends on that, then it gets actually really complicated for the average developer to keep track of all the paths around the code that might be going on, because something happens over here and that, through magic in the background, goes and makes something happen over there, and sort of you don't necessarily know about that. So following through when things are going wrong as to what exactly cycle has gone wrong there can be quite tricky. On the other hand, Redux seems complicated. Everybody comes along and says, "Oh, I'm not sure about Redux. That seems like something large I'm going to have to add and deal with and work out." But if you use the Redux toolkit and if you sit down and work that out, then you can get something very similar to the standard Redux thing, but living in kind of back-end code, which is generally a lot easier to deal with. It's a lot more immediate what's happening, where you're going. When this asynchronous thing happens, this is exactly what's going to get called, and only at the end do you update your state. and the state updates your UI. So it kind of feels a little bit like Knockout, only more modern, quicker, faster, and with a lot of community around it. So lots of ready-made components for this, that, and the other. Full stack. In GearSet, most of our developers are largely what you call full stack developers. So they work on the front end, and they work on the back end, and they work on the database, and generally everybody's mucking in on everything, which works well. And sort of the previous companies I've worked with, sort of the best teams have been the ones where everybody can do a bit of everything. But on the other hand, it does mean that you don't get that many specialists. So again, if you're using pure React and hooks and things, then it's very easy for somebody who isn't a keen JavaScript developer or TypeScript developer, or is used to doing C# or Java in the back end, and they come to do this front end stuff, it can be quite dizzying for them. So again, it's really a case of taking that, sort of those patterns that confuse the non-fully front-end developers. So, because the people I was talking to earlier, this was a front-end developer, and he was saying, well, can't you just use the normal React stuff? And the answer is, you do this all the time. It seems simple to you. You're used to it, but if you're not, then it can be really hard work to work out what's going wrong when something goes wrong. So yeah, if you've got a full stack developer, then this is a good way of doing it. It keeps things simple. It also works in a very much more back-endy way, and personally, I think that's good. I've done a lot of mobile development. I've done a lot of web development, and when you start putting code into your UI, then it never seems to end well. It always ends up sticky. So yeah, the last thing I was just going to say there is that it's worth having these patterns. So one thing we did notice is when we were first starting to move into React and Redux, everybody was piling in and doing things their own way, and which was good because it meant that we worked out the good way to do things. But once you've worked out a good way to do things, write it down, implement that pattern, and make sure that your devs know about it so that they can all start working the same way, because otherwise you'll end up with a whole load of Franken code all doing things slightly differently, and cutting and pasting from one person's code and cutting and pasting from another person's code to make your little feature go on. So yeah, that's essentially what I was going to talk about. So if anybody has any questions or opinions or more of an observations, feel free to ask. Or if Eamon just wants to correct everything I've just said, then
Hi there. Do you find that, I know you mentioned about patterns and things there, do you find that there's a lot of abstraction that can be done for repeatability with shared Redux functions?
Yeah, I mean, certainly, that's the nice thing. The code is code, so lots of things can be reused. Like in the middleware there was a shared function which I hadn't shown the implementation of, but that's a function which brings in, checks which bits of state have changed, merges those together, and effectively does an observable on them. I mean, obviously, the nice thing about React is everything's componentized anyway, so you can componentize all the UI features. But yes, you can set up things like XHR patterns for calling off to the APIs and things like that, and that all plugs in very, very nicely. So yeah, that's another thing.
I just have one other, actually, just on the unit testing side. Are you using Jest?
Yeah, we use Jest for that.
Is it quite cumbersome for the mocking of?
If you do it right, it's not too bad. At the moment, we don't. For the amount of work that we've done, we haven't actually had to mock anything. The only thing we had to mock at one point was because we've got some knockout stuff and some React stuff, we actually have to put wrappers around things, some of which has Durandal in it, and there was a problem with Durandal causing problems if it was hooked up in the router sort of in the States somewhere. But we actually managed to fix that at source. So at the moment, we haven't actually had to do any mocking. We did have to do, so we did mock for a short while we were working out the problem in Durandal. But yeah, so far it's not been a big problem for us. Anyone else? It's a shame Herman's not here. We could have carried on our argument. Okay. In that case, we'll put that's me, that's us, that's sponsors. So yes, I'll step down for 15 minutes here. I will stop the live streams and things. When everybody else comes in, I will tell you where the after party is, and then we can all go and get beer and pizza and things. Okay.